medium.
Yeah, I know that. Okay, but it can't like vanish a star like the sun. There'll still be a lot of light.
You don't know what this thing is.
I know it because the more the light travels from medium, the less of it like can travel forward.
You don't know what these things are made of or how far away they are. No one does.
What?
No one knows what these things are actually made of, nor does anyone know how far away they are. It is what it
But
is. Calculations
people
aren't
have found
measurements.
it out.
Who?
Just because you personally haven't like felt it, haven't seen it, that doesn't mean it doesn't exist.
Who found it out? Who?
The the scientists.
Almighty scientist on the top of the mountain. Oh, guru, tell us everything about everything. Who? Give me the name of the guru. What's the name of the scientist?
Okay, wait, let me see. Okay, the guy is I think Ars Aristotle of Samos, ancient Greek astronomer.
Eratosthenes?
Yeah.
He stuck two sticks in the
No, I
ground.
think
That works
no.
perfectly fine. He actually didn't do any of that, but that actually works perfectly fine over a flat and level surface. And globe earthers have debunked this claim a long time ago. You're talking
No,
about
I
sticks
mean
and shadows, right? At the bottom of a well?
no, I don't mean him. I mean Aristarchus of Samos.
Oh, Aristotle?
No, wait, let me just type it for you.
So I was thinking you're either, I don't know if you're saying Eratosthenes or Aristotle. I assumed Eratosthenes. That's usually what people say. Oh, Aristarchus of Samos. What did he do?
He I think he was the first one to like attempt to find the distance between Earth and Sun using
How?
trigonometry. Oh fuck,
How?
he was largely
Do you have a
inaccurate.
citation to anything related to this? I want to know what specifically did he do?
He like attempted to find out the distance, but I think it says he was incorrect.
Okay, so your proof is the guy who was incorrect.
Wait, let me find out the like recent scientists.
Hey, I'll be right back. I'm going to grab some coffee.
Oh, okay. I just found a guy. He was
Yeah.
Giovanni Cassini from Italy.
All right, I won't be long.
Okay.
I think T-Dub's still here too, so.
Sorry, where are we up to?
He was asking the name of the scientist who found out the distance between Earth and the Sun, and the guy's name is Giovanni from Italy.
Giovanni.
Like, yeah, he just proved the distance between the Sun and the Earth, and it's a really long distance.
How did he measure that?
Um, using parallax methods by observing Mars from two locations using Kepler's law.
Oh, we're talking about the sun, not Mars.
I mean, yeah, I think he used the Mars to like find out the sun's distance using Kepler's law.
Okay, so how did he find out the distance to Mars then?
I think with Gian Richter via paradox.
With a what? With a paradox.
No, I mean parallax. Parallax.
Parallax. Parallax. What was his references? What was his
Mm,
references?
I think he just used some science stuff to like accurately calculate it, and he just showed the method to
So it's
everyone.
not measured, it's calculated.
What's okay? Explain the difference to me. You just keep saying I'm getting it wrong.
No,
What
I
do you
didn't
mean
say
by
you were getting it
parallax?
wrong. I said it was calculated, not measured. You just told us that they calculated it. They didn't measure anything.
But that's the same thing.
They must
No,
have
it's
had
not.
measurements of something. You'd need measurements to input into a calculation. Like you know the distance, right? And
Oh,
you can calculate.
you mean it like that? Okay.
Right. So you need, yeah, you can't just calculate and think you know something through calculation. You
I
need to
mean,
know
you can
something
also
first.
measure stuff by calculating them if you know other measurements of the stuff.
Okay,
No,
we'll go
you
with that. No, let's hold on, Tito. Let's just say yes, you can calculate something. I agree with you 100%. You can calculate anything you like. But at some stage, after it's been calculated, somebody has to measure and confirm that the calculations are true and correct.
Confirm. You can confirm it.
How do you prove that your
Okay, but
calculations are correct?
yeah, but it's impossible to like measure the sun like physically.
Excellent. I'm glad you agree with us.
That doesn't mean it's not true.
So here's you are, Kenji. Just don't carry someone else's water, please. You're only going to fry your own brain. Take a step back. You've read a story on the internet that says how all these mystical, magical things were done, and you yourself have already worked out that it's impossible to do.
Yeah, it's impossible right now. Maybe in the future we can.
Well, hang on a minute. Wasn't this story from the past? So maybe in the
Yeah.
future we can, but yet you're telling us something that's, 3,000 years old that's already been done? Hang on a minute. Something's not mathing here.
I mean, like in the late future when we have like spaceships, better spaceships and stuff.
Cool story. But anyways, interesting how you work that
Okay,
out
but-
yourself, that it's impossible.
It's impossible right now, sure. But
Yeah.
okay, but of course you can't like calculate. You can't go to the sun.
So it wasn't measured then. We all agreed that it was calculated and that these so-called
No, okay,
calculations
okay.
have never been confirmed.
You can measure something unknown by using calculations with measurements that you do know about the thing, like different measurements.
So you are measuring it.
like what? Like what? Like for instance, right? Your parallax, right?
Yeah.
Parallax of what?
Gian Richer, we have parallax.
Yeah, parallax of what? So you'd be measuring the apparent angular change between 2 points, or what? Over time? Because parallax would mean something's in motion, wouldn't it?
I mean, he basically measured the Mars position against background stars from two distant locations simultaneously.
How?
And then he just found out the distance.
So
That's what it says.
what was the measurements he had the knowledge of to be able to determine what he was seeing?
He probably knew like the distance between the stars and stuff.
Yeah, how? How would you know that? This is a paradox. This is a conundrum, because you're saying that he knew the distance to the stars when this is the thing you're trying to figure out?
No, I mean he's using different stars in this case, like not the sun, different stars.
How does he know the distances between them? How does he know
Someone
which one's
calculated.
closer and which one's farther?
Someone calculated before him.
Yeah, who? This is the method. This is the method you're trying to tell us how you work it out. You're saying you use parallax to figure out how far away these things are. Now you're saying that, well, to know that what you like to figure out what the parallax, right?
Yeah.
Differences. You'd have to know that how far one is from the other. Right?
Yeah, that's true. And this he did know it.
So there's another way to figure that out besides parallax.
Yeah, probably.
Parallax, because basically you're saying at the moment is we know the distances to these objects in the sky because of parallax, but we and how do we find out? How do we find out the distances? Right, because of parallax, through parallax, right?
They
And how do we
probably
know?
like found out a distance using like science stuff, like how large the object appears to us and the stuff.
Yeah, you can't say that you knew when you're trying to figure out how far they are. You can't say you know how far they are when that's the thing you're trying to figure out.
Yeah, they knew other stuff. They knew the other distances.
Then why were they trying to figure out how far they are using parallax if they already knew how far they are?
Okay, they knew two different stars how far they were. They were trying to find out how far sun was accurately.
What?
They knew like how far the other two stars were.
No,
from
they
Mars.
didn't. That's the problem. They keep claiming that they did. You keep claiming that they did. But what we'll do now is how did they get the distance to star number 1? How did they get the distance to star number 2?
Using Kepler's law.
What does that tell you?
Oh yeah. They use Kepler's law. Like they calculated how much time it took to them to like circulate around the sun. So like they use that.
To
And it is
circle it around the sun. What are you talking about? You don't know how long it took something to go around the sun if you didn't see it go around the sun.
you can you can see it with a telescope like how long it appears again and stuff. You can calculate it.
Yeah. How does Kepler's law like prevent it from being closer and going slower or further away and going faster? How does it distinguish the difference? How does it give you a fixed distance and speed?
They probably found out that planets weren't moving further or like coming closer by like observing them, like they appear at the same time and stuff. So they must be like on the same thing, and they calculated that the sun can't let them go away.
There's a nuance here that you're missing. Like there has to be something that they already think that they know in order to be able to start basing these ideas off of, right? That they're basing these ideas off of. What is it that they think that they know already, right? Which allows them to start using a unit of measure.
Oh, they I think they just found out Kepler's law maybe on like smaller things on Earth. Like they observed that if a object moves around like this is the time it takes. This is how big it should be according.
You'd still have to know something. You'd have to know something because you can look at something in the sky and it could be like it could be.
Yeah, they know. They like I think they can test it on small things and they can apply
Yes.
it on planets.
You'd still need to know something because the object could be smaller and closer, appearing bigger, right? And going slower. Or it could be bigger and further away and moving faster. How would you know the difference?
Because we already have laws to calculate this stuff.
You'd have to have a knowledge. You'd have to have a ground-based unit from which to measure with.
Hmm. Maybe we can calculate other stuff like how long it takes it to appear again.
What's that based on?
Um, Kepler's law.
What's Kepler? What's at the heart of Kepler's law?
What's the?
What is at the heart of Kepler's law?
I mean, the Kepler's law are basically like laws that we apply to the planets to like find out different stuff about them.
What do you mean?
I mean, yeah, that's what he gave us. Like, yeah, basically, we can like find out different stuff about planets and the distance. Using the Kepler's law, like if it has this much mass, it is this big, so it must take this much time it to rotate, and then different stuff like that.
That's a lot of assumptions all linked together. So if it has this much mass, okay, how did you get the mass?
By like seeing how big it is, calculating how big it is.
Again, you're calculating, you're not measuring. Have you noticed yet how all of this stuff goes in a great big circle? One thing proves the next thing. That thing proves number 3. Number 3 proves number 4. Number 4 proves number 5. And number 5 circles back around and proves number 1. Have you noticed that circle yet?
No, it doesn't circle back. It just keeps like going. That's how
Oh,
it works.
yes, it does,
Like-
my friend. And you haven't noticed it yet.
How does it circle back then?
Every single one of these things helps you prove something else. All I have to do is sit here and wait for you to go through that cycle again. You might do it 2 or 3 times before you realise it.
Experience like it.
None of
looking
your
back.
things actually measure these claimed distances, these claimed masses, these claimed sizes. They are all just assumptions. They are all calculations.
Yeah, they are calculations and maybe they are assumptions, but they're like they're the most accurate we know.
How do you know they're accurate if you can't get there to measure and confirm the calculations? I'll give you an example. Let's say I tell you my table is 6 foot wide. At the moment, you've got a story. You can choose to believe me, you can choose to not believe me. Either way, I don't really care. But how are we going to confirm that the table is 6 foot?
You'll have to observe it.
I did observe it. I've made the claim that it's 6 foot. How are we going to validate or prove or verify what I'm saying is right or wrong?
You can show it to me, like you can just bring me there.
And you can
So I
come
can
and look at. You can observe it.
Yeah, so I
That's
can-
great. I've got no problem with that. And what is you looking at it gonna do? That's not gonna prove anything.
That's gonna prove it, because if I observe it myself, then that's proven to me
So what has it proven to you?
that the table is 6 foot.
How do you know it's going to be 6 foot? Are you going to look at it and go, "Oh, it looks pretty close"?
I'm gonna bring a measuring tape and measure it.
Ah, we finally got it out. You're going to measure it. That's the important bit. So, somebody makes a claim, and then to verify that claim, we measure and we test. At the moment, you've got claims of distance to the sun, distance to Mars, difference to star 1, difference to star 2, mass of some of these stars. None of them have been
Okay,
measured.
wait.
None of them have been
Okay.
measured to verify the validity of any of these claims.
I can use other things to measure it instead. Like if there's an iPhone sitting on your table, I can like see how long a standard iPhone is, and then I can measure it by that and other stuff.
That's awesome.
So yeah, I don't need to know. I don't need to like literally measure it with a tape. I can just like assume like
You're
with the
going to
iPhone,
literally measure it with your phone. As long as we agree upon the values and you say that my table is 15 iPhones long, I'm good with that.
I mean, yeah, I can measure it from a distance too. Like I can see like my point of view, and I can like calculate it with my eyes too. Like with
Yeah,
the
no.
angle I'm seeing it from, and this.
No. If you see my table from a distance, let's say I put it 1 mile away, it's going to look like it's about maybe 3/8 long. And that's really not going to be useful. You're going to look at it and go,
No,
oh yeah, it
but
looks
you
really
can-
small from here. Don't say no. You're only backpedaling because you realise the stupidity of it now.
No, but you can.
You got
you can
it. Hey,
factor it in,
Kenji,
like
Kenji, you got it right the first time. You measure it.
you don't have to. You can like you can factor it in. Like,
Okay?
I
Yep,
see it
yep.
from a
Kenji, stop making stupid excuses now. You, my friend, got it correct the first time. Anything you're saying now is not helping your cause.
No, I'm just saying you can measure it by different stuff too.
I agree with you. There's lots of ways you can measure things. But the problem is,
You can
when
measure-
you were talking about all this space bullshit, which is a load of crap in the first place, and you're lucky that we're bored and we're entertained it for this long, all of them are
It's not
nothing
made up.
more than calculations. That is it.
It's not made up, and you can observe it from a distance.
All right.
Too. That's true.
Time to nail it. Space is a violation of the second law of thermodynamics.
How?
Entropy.
I already told him this.
Yeah, I know. It didn't
How
sink in the
space
first
denying
time.
Okay, how is space not following it?
How does space not?
Not follow second law of entropy then?
It's a thermodynamic impossibility.
What?
It is a thermodynamic impossibility.
Possibility. I mean, sure, it's possible.
No, it's
I mean, no, wait, no, it's
impossible.
not
It's
possible.
impossible. It's
Yeah.
impossible. Yeah, it's outer space.
Yeah.
Vacuum.
Yeah,
Yeah,
it's,
vacuum of outer
it's
space.
impossible. Yeah, it's impossible to not follow it. Sure. So, what's your point here?
So, in order for you to have your outer space, there must be a container around Earth in order for us to have air pressure.
Yes, and yeah, that's true. That's our atmosphere, and the atmosphere is there because of gravity.
Wrong. I want you now to show us a scientific experiment that validates, verifies, proves, backs up that claim that gravity holds air down.
Of course, when gravity applies on all.
No, don't tell me the story. If the stories are true, you should be able to back it up with a science experiment. I'm not expecting you to drop everything and do one now, but you should be at least able to cite one.
I mean, there's
Last
a
time
lot
I
of
checked,
experiments.
when we're dealing with air pressure, you need a container in order for you to have your gas pressure.
You can also
No,
have force.
no container, no gas pressure, because the air will try to fill the next available space.
This
That's
is
how
literally
gas pressure
what
works.
this is literally the point T-Dub was making, that you need a container for the
Excellent.
gas, and I'm saying,
So for some reason, it didn't sink into your head. You seem to not
Yeah.
want to understand it.
no, I'm saying that forces can also apply on molecules of air.
Wrong. Give us a demonstration of this happening.
Okay, if gravity can apply on you,
No. I don't want your hypothetical stories. I am not gas pressure. I am Matrix, a very nasty Aussie who's got a very short fuse. I want a
You are
demonstration. Listen, I want you to provide us with a demonstration, a citation, or a scientific experiment that backs up your claim of gravity holding gas pressure, causing it, cause-effect relationships.
Okay. Okay, if gas expands faster on like moon station than Earth, so does
You're
that
not on a
do it to
moon
you?
station. You're on Earth.
No, no, but like people have been on moon, so like
You're not
would
on the
it do
moon.
it
You're
to
on
you?
Earth. You can only
Okay,
do with
I'm
what
not
you've
there.
got. So stop with the hypotheticals of places you can't go to.
I can't go there, but it's true. People have recorded it.
Oh, yep, okay, it's on the television, so it must be true. So show us, post it in the side chat, the scientific experiment, the citation, or some kind of way that you're going to prove that this gravity is causing all the air to hold down.
Yeah, TV
Okay, hold
screens
on.
are not barometers, bro. There's no way that you could tell just by looking at a TV screen and see some guy or an
Can
object and say, look, there's no air around that thing. There's no way you could be able to tell that by looking at a screen.
can I send two videos where like gas expands, one on a moon station, one on Earth, and you can see that the one on the moon expands faster because there's less gravity there. That just proves it.
What, someone blew a balloon up on the moon?
No, like someone like released gas in a container on moon station, and it expands faster than on Earth.
That's a cool story, bro.
That's true.
Post it in the side chat so we can have a laugh.
That's um I can't find like a legit like a video of it.
Well, that's a shame. I was looking forward to some kind of proof that you could back up your claims.
Okay, someone hasn't like made a proper video of that.
So what you've got is, again, a really cool story.
No, people have like problem, if we have solved for it.
Okay, go onto the Caltech website then and see if there's a citation to back up your claim.
Caltech.
Or some other university. I'm not fussed on which one, as long as you've got some kind of citation to back it up. And whilst you're doing that, I'm going to get a little thing and post it in the side chat, and I'm going to read it out to you. I think I'm feeling nice for once. It's pretty rare. You should enjoy it.
Okay, I just posted a proof.
What, you copied and pasted ChatGPT? That's great. Anyways, I'll read this out to you. I think you should listen to it. If your theory is found to be against the second law of thermodynamics, I give you no hope. There is nothing for it but to collapse in deepest humiliation. Arthur Eddington.
And I agree. Like, if something doesn't follow thermodynamics, then it's not true.
Excellent. So you telling us about space, you know, a vacuum next to a pressurized system without a barrier or containment to separate them, sounds pretty childish, doesn't it?
There are forces there.
There's no forces there, mate. This is the bit that you can't provide. You can't provide any proofs of gravity holding air down. We need a scientific experiment or even a validation citation to back up this claim of yours. At the moment, you have just given us a cool story.
There is proof. You can look it up.
If you can look it up, then you can post it in the side chat. You've told us you can look it up, but you also have failed to post the one up you were talking about. Maybe it doesn't exist.
It won't make sense for it to not exist.
Well, if it does exist, you can post it in the side chat. Since it's your claim, I wouldn't want to see you fall flat on your face. I'm hoping you would be able to back up your claims.
Yeah, I can't find it at the moment.
Oh, don't worry. This is 24/7 Flat Earth, not 24 seconds Flat Earth. We got plenty of time, my friend.
And besides, you'll never find it.
Oh, come on. Take my fun away.
Okay, but how would it make sense? How would it make sense that gravity doesn't apply on molecules of gas, but applies
Hey,
on molecules of your body?
Kenji, the problem is the stupid shit you get taught at school. Gravity does everything. No, it doesn't. Gravity, as you know it, is just a mathematical formula to describe down. Nothing more, nothing less. You might claim it's a force. It is a mathematical formula. That's it. There's no force. There's no magic gravity. It is just a number. And how about this? 9.8 meters per second squared is the average rate that things fall in the medium of air.
Why, if there's no gravity, why do they fall then? That's so stupid.
That's a great question. And here's the answer. Science and scientists to date do not know what the causational mechanism of down is.
But down is only a possible on flat Earth because there's no such thing as down on a ball.
Yeah, that's true. But gravity also explains that phenomenon, and we observe gravity.
Gravity,
No, it doesn't.
pull up with
There's
the
no such thing
gravity.
as gravity. Stop talking about gravity, fool.
Kenji, I'll make it easy for you. I want you to think about this. If gravity was real and described perfectly as a force, why would there be the necessity for 79 other theories of gravity?
I already told you this before, man. Gravity's just math. It's a mathematical construct. Math is not a force.
No, it exists. Gravity exists.
Math is not a force. Yes, your
Yeah, math
perspective
is not a
exists.
force.
I agree with
I
you
agree.
that your perspective exists, but math is not a force.
Yeah, math is not a force. I agree. And
Well, that's all gravity
What are
is.
these-
It's just maths.
what are these gravities that you just posted?
That's all the theories of gravity. So which one's correct?
The one that exists.
They all do. Which one's correct? Do you see the problem now? Here's you telling us, but gravity, but there's no place like home. Dorothy,
Explain one other theory of gravity to me. Explain it. Anyone.
why should I need to? Relative
Because
density.
you're saying what?
Okay, I'll change the name of it so it makes you feel better. Specific gravity.
Okay, what's that?
The relationship of an object within the medium that it's in. For example, a piece of wood. If I hold a piece of wood up into the air and let it go, it will fall down to the ground. If I hold that piece of wood and place it underwater, it will float up. Why? Because of its relative density comparatively to the medium that it's in. It is more dense than the air, so it goes down. It is less dense than the water, so it goes up.
How about this? Here's my theory. Everything goes to the surface of water when you're moving with density. So if wood is at the bottom, it goes to the surface of water. If an apple falls from a tree, it goes to the surface of water. See, I solved the mystery for you guys.
That makes no sense. Okay, and you were saying that this is specific gravity, right?
Or relative density, whatever you want to call it.
This is literally gravity.
Same
but
thing.
This is gravity. This is not something other than gravity. It's just
Okay, Kenshi, the word gravity. What does that one word mean to you?
gravity means the force between masses.
This is incorrect.
I mean, the force that mass applies on other mass.
That's great. Mass attracting mass.
Yeah.
So what is mass? The resistance to acceleration, or maybe if you look it up, you'll find in scientific terms there's no real definition of mass.
Okay, wait, hold up. Your mic glitched. Sorry. Can you repeat that?
In scientific terms, the definition of mass is, please.
The definition of mass.
Yes, you know, the force, mass attracting mass. I'd like to know what the definition of mass is.
Mass is just stuff, just mass is just stuff, particles.
So stuff particles attracting stuff particles equals gravity.
I guess we got to define what stuff particles are now so we can really understand what he's talking about. Because he just said mass is particles.
Stuff particles.
Stuff particles. Mass
No,
is
I mean,
stuff.
mass is just stuff.
Yeah, mass is stuff. We get it. Okay, yeah, we get it now. Oh, God, that makes so much more sense. Now I understand why it's a globe. Because mass is stuff.
Okay, but what's your explanation then? What is mass according to you?
Well, We're not really worried because it doesn't prove the shape of the ground.
Yeah, something made up for you guys to believe that things fly towards each other.
You wouldn't agree on my definition, but you can't even like give your own definition.
And the reason for it, your definition is outdated by about 110 to 115 years, somewhere around there.
And besides,
superseded.
I said things go up and down, and that's flat Earth. You can't go up and down on a ball, can you?
Yeah, sure.
Hello. What do you mean? Yeah, sure. Can you go up and down on a ball?
Up and down, no, that doesn't exist. Like,
Okay, so why do you
doesn't
keep
exist.
saying things go down?
It's because you're talking relative to the person.
Nah, I don't think so. You're talking relative to horizontal.
Nah, it's relative to the person.
Horizontal.
Nah, man, that's not the case.
You already said you can't have down on a ball. Now you're saying you're standing on the side of a ball and down is relative to that person?
Yeah, you're talking relative to that person. Relative to that person, that's down.
What's making that person stick sideways to the ball?
Gravity.
No, that's outdated.
Yeah.
Yeah. Mass attracts mass. That's over with.
Hello. Yeah, your mic glitched out. What are you saying?
Mass attracts mass is over with. You can't do that anymore. It's all done.
How's it? Oh, it's still true.
No. How is it still true when it's never been proven?
You can observe gravity, bro.
No, you can't.
You can just
No, you
see an
can't.
apple falling down.
So, okay, what is gravity? That when something falls, or is gravity something different?
I just told you, like, gravity is just the forces between the force
Gravity
exerted
is
by
not a
mass on
force. Gravity's not a force. I don't know who keeps telling you this in your DMs, but gravity's not a force.
What's gravity then? It is a force.
It's not a force.
It's a mathematical formula to describe things going down at 9.8 meters per second squared on
And
average.
down is a flat Earth, relative to people. That's flat Earth. Because there's no down on a ball. You already said that. Do you see how you guys got everything screwed up with this pretending you live on a ball thing?
Nah, it's because you don't understand relativity.
Okay, go ahead. Explain relativity.
It just means that from someone's other perspective, things can appear different.
Oh, so that means Earth is a ball.
It doesn't mean that, but it supports the claim that Earth is it supports it.
Oh, so if you're standing on a street and I'm standing on top of a building looking at you, relatively, we're looking in different places, but I can still see you. So that means Earth is a ball. Do you see how
No.
confused your fucking answers are?
I'm not I'm not the one confused.
You are so confused, you don't know what's going on today now at this point.
I do know.
And the reason we know this, Kenji, is you've jumped from mass attracting mass to, which was Newtonian, to now Einsteinian relativity. So which one is it?
I mean, both things are true.
They're both true. Well, how about you do a bit of
Yeah.
research and you will come to the same conclusion that everyone else in this room here has done so. And you'll find out that mass attracting mass was superseded about 110 years ago.
superseded by what? What came after?
Einsteinian. Benny
Was
Warpy
Einstein?
space time.
Oh, but I think that only applies to like speed of light.
Whoa.
I mean, yeah,
He went,
that.
yeah, you now went from gravity to speed of light. It's amazing how you guys can jump around.
I mean, yeah, the relativity theorems only apply to speed of light.
Okay, so how does the speed of light make you stick to the side of a ball?
That's not what I'm saying. Gravity is what makes it stick.
And you said that's relativity.
That's not relativity. That's just force.
You should. You know what? You sound tired. I bet you're gonna fall asleep. Have a good sleep. You might not sleep at all. You're gonna be up all night thinking about how can I prove the Earth is a ball when I already know it's flat now. That's all you're gonna be thinking about.
No, you guys are asking me different questions and I'm answering different things
No.
and you're trying to connect them.
We're asking you questions on the dribble that you're giving us. At the moment, you believe gravity is some mystical, magical force that makes ball-tards in space. Well, okay, I'm going to give you your gravity and your ball-tard in space. So why is it when the good people go out to measure for the curvature, they don't measure any?
How are you measuring it? Are you measuring it correctly?
So all of a sudden you've jumped from are you measuring it correctly before you even find out how it's measured? That's a little rude, my friend. Maybe you're the one that's fucked up in the first place. Now
Hold
that you
on.
told us you believe it's gravity.
Wait a second. That was a good question. Yeah, are we measuring it correctly? Well, go ahead and tell us how to measure it, and then we'll tell you if we're measuring it correctly.
That's a great idea. You tell us how to measure it, and then we'll tell you what we've done, and we can compare the two, and maybe
Yeah.
we might be wrong.
Go ahead. Tell us how to measure it.
Okay, sure.
All of a sudden, he doesn't know anything. Isn't it
Wait,
amazing?
no, other people have like done it.
Yeah, that's cool. I'm not interested in what other people have done at the moment. I'm
You want-
interested
you wanna
in
do-
how you're going to tell us how to measure it. That's what we're interested in now, because you've already said maybe you've done it wrong. Okay, maybe we have done it wrong. So please tell us how to measure it correctly.
Yeah, the correct way. We need to know the correct way to do it. Not people from the past. We know that's not right.
Okay, you measure it by like seeing at the horizon and calculating angles and stuff.
You can't calculate an angle from the surface of a ball, so that's out.
You can.
Yeah, wrong.
You cannot. It's over with. You can't use that one. Cross that off your board. Say you can't put a ruler on the side of a basketball and then make an angle. So that would be silly.
That's a no-no. You see, the definition of an angle is the point at which two straight lines intersect. So if you've got one straight line and one curved line, that doesn't fall within the definition.
Yeah, you don't
No,
have an
but
angle then. You have I don't know what you got.
No, but
Actually,
like
what is that thing called anyways? One straight line, one curved line.
It can't be called anything. I
Tangent.
don't know. No.
Tangent to a curve? Tangent to an arc?
No, it's not tangent because tangent is touching the side of the curve.
Yeah, not intersecting, yeah.
I just
Anyways.
sent a video, by the way,
Sent a video of what?
calculating the curvature of Earth.
So not measuring again.
How do you?
Haven't we been
What do you mean
through this?
calculate? Why would you give us something on calculating things? We want to know how to measure it.
You measure it by calculating other stuff like angles and
No,
Dude,
Oh my
I
God.
told you before, man. Measurements aren't calculations. Calculations are not
I'm
measurements.
going to put new carpet in my master bedroom. Should I measure or should I just calculate?
You can do both.
Okay, so I can do both. All right, I first want to start with calculations and then I'll confirm it with measurements. Where do I start?
You can like calculate it with like your phone, I guess. You can like see how
No,
much.
that's measuring. That's using your phone as a measuring device. I know what you're talking about because I use it.
Hey Kenji, just a quick one. I've just had a look at your video and I've scrolled through to 3 minutes and 15 seconds in, and the gentleman's got the lady to draw a circle on a white piece of paper. Why are they?
Oh yeah.
Why are they assuming a ball when what they should be doing is being outside and measuring, and then getting the answer that they get? So we'll go and measure it, we get the answer, and then we come back and tell people the answer. These guys have created the answer first.
I know. I think you're right. They should have like put it at the end of the video, but it's just
Yeah.
It's already proven. It's already proven.
So Kenji, when you create the answer first and then you put everything else in front of it to back it up, in logic, what is that called?
I agree, but that's just a mistake he made.
You agree with what? Affirming the consequent?
No, I agree that she should have put it at the end of the video. She shouldn't have like put it at the start.
So they haven't really measured anything. So you're telling us that we're wrong in our measurements before you even found out how our measurements work or how they're even done, and you are going to tell us how to measure it correctly. And what you've given us is a calculation affirming the consequent TV show. That's great.
No, but you can literally see them like calculating it with like
No,
degree
you can
angles.
literally see the first thing she draws on the table. I haven't listened to the sound. I'm looking at the picture. The first thing drawn is a circle. Where did she get the circle from? You have to remember, Kenji, we are stupid. We don't know what shape the Earth is. If you're going to do this, you have to do it from a non-biased perspective. You don't know what it is, so you're going to go out, you're going to measure it, and the results are going to be what it is. If it comes back as a ball, so be it. If it comes back as flat, so be it. If it comes back as a cylinder, so be it. But you can't say the answer and then reaffirm the answer.
Okay, maybe she just assumed that it was fair and all her calculations supported that.
It's an assumption. Very good,
I mean,
Kenji. You have been watching.
You can assume something, and if you prove it right, then it just becomes fact.
Excellent. So we can assume things. Okay, so if I assume we live on a ball with a radius of 3,959 miles, if we do some calculations, because you love those, we can work out that at a given elevation, the horizon should be at a very specific distance. Do you agree with that?
Yeah, agree.
Excellent. How about I chuck up a few pictures for you and we'll have a look at these and we'll see what the problem is. Eeny, meeny, miny, mo.
He's going to reset. You guys are going to reset this one. He's going to reset soon.
That one right there, because it's got the options.
What's the problem here?
The problem is quite a simple one. Where is the horizon in that image? A, behind the oil rigs. B, in between the oil rigs. C, in front of the oil rigs. Or D, you're coping.
It's A.
A, behind the oil rigs. Excellent choice. And I agree with you because it is. That was ever so simple. Now, the issue we've got is there's a little formula. 1.22 times the square root of the observer's height in feet. Now, this is based on a 3959 mile radius ball. Now, we're assuming that it's a ball. In that case, for some context, this image you're looking at is from video footage. That video footage is taken from less than 1 foot above the surface of the water. Now, as we know, the formula 1.22 times the square root of the observer's height in feet. So observer's height, 1, square root of 1 is 1, times 1.22 equals 1.22 miles. That's where the horizon should be. Now, you've quite clearly informed us that it's behind those oil rigs. We also know the distance to those oil rigs, 9.41 miles and 6.21 miles. Do you see the problem here, Kenshi?
Oh, so you're saying that the horizon should be like closer?
It should be well and truly in front of those oil rigs. Comfortably in front of those oil rigs. Now, the problem now exists because the horizon is so far back. When you do calculations, it actually works out that you now have debunked any ball up to a radius of about, 268,000 miles. The one that you allegedly live on is supposed to only be 3,959 miles. That's a problem, isn't it?
Can you drop your like formula in the chat? Like what formula you used?
1.22 times the square root of the observer's height in feet.
Can you type it down though?
No, but I'll repeat it again. 1.22 times the square root of the observer's height in feet.
Because I'm just gonna see if this is the correct formula. Yeah, this is the right formula, sure.
Wow, what, did you think I would lie to you?
Oh,
I've got better things to do,
I
my
think
friend.
I think the distance is correct then.
You think the distance is what? Sorry, you dropped out.
Yeah, like this distance is like 6.1 miles. It's incorrect then.
No, the distances are accurate.
They can't be.
Well, they are, B. Now you understand the problem we're having. You're still going, but it's a ball, Dorothy. It's a ball. And we're saying, but the measurements don't line up properly. Now do you understand what we're talking about?
Yeah, there is a problem here in this image.
Exactly. And not only is there a problem in that image, let's grab another one. There's also a problem in that one. Let's grab another one. There's also a problem in that one.
Okay, what's this image have to do with anything? This mountain one.
That's not a mountain. That's a lack of mountain. The one with the windmills in it? The very back one. How far is that? 11.2 miles.
Yeah, that's what it says.
Yeah. And camera height, 3.5 foot. So let me get my calculator out. Move it there. 3.5. And we need the square root. Times 1.22. Equals 2.82 miles. There we go. And oh my god, the horizon is behind 11.2 miles. Well, that can't be right, can it?
Wait, why not? It should be behind them all.
The horizon should be behind them? No. The horizon should be quite clearly in front of all those windmills. Even the closest one at 8.4 miles is still further than what the horizon should be in front of that first one at 1/4 of the distance.
Then most likely the distances in these images are wrong.
Well, most likely the distances are wrong. Most likely there's no curvature.
Yes.
The distances are correct. This is why we don't take too kindly to calculations. This is why we prefer things directly measured. It eliminates possibilities of things could be wrong.
Oh, I never asked you guys how you went to flat Earth theory. Can you tell me, guys, how you went from like I'm assuming that you were like round Earthers before and then you went flat Earth. Like, can you tell me why it happened?
Why it happened? An
Because we got
accumulation
pictures
of
like this. Yeah, we got pictures
That
like
helps.
this. You should be the same way now too. You should be going, oh shit, the Earth is flat, and then you should just be done with it. It shouldn't make you sad. Nothing should be like your world is not ending. In fact, it's going to get better. All that.
Oh, so you saw pictures like this and this made a change.
For a lot of these guys, yeah. No, I have my own equipment.
So before I go to bed, Kenshi, have a look in the side chat. There's a whole pile of laser tests.
Oh,
Yeah, where they shoot
yeah.
lasers over
I think
long distance. Yeah.
oh yeah, I think I've seen this video, this laser one.
Which one? All of them?
So, with a game over. I think someone disproved it, I think.
You think someone disproved it?
No,
I think
I've seen the video.
He doesn't know who, he doesn't know when, he doesn't know how, but he thinks he does.
Yeah.
So I want to see this video when they went to that spot and then debunked that guy.
No, I think they debunked it on YouTube. I think they just talked
Oh
about
no,
it.
you
Like,
can't.
they provided-
You can't just pull a video up and say I debunk you and then post that. That's retarded, dude.
They're talking
That's
about
what they
some
do.
science stuff.
Kenshi, I don't know if you heard
Yeah.
earlier on, but this is not a question of science. This is a question of geometry. Okay?
Wait, what is it? It's a question?
This is not a question of science. This is a question of geometry. You, my friend, are placing yourself in a category error. You're talking about the wrong thing.
Oh, I mean, geometry does fall inside science.
Whatever you want to believe, mate.
Sure,
Seriously.
I mean, sure, geometry is like.
Last time I checked,
accurate.
geometry was a subcategory of mathematics, but if you believe that it's science, all good to you.
I mean, sure, it's like more accurate to say that.
So it's not science. Excellent, because if it was science, we'd be conducting scientific experiments to adjudicate cause and effect relationships, wouldn't we?
Yeah.
Excellent. We're not doing that, we're just measuring it. Yeah.
Also, yeah, you're right. I think it's just simple geometry.
Yeah. This is why you're having trouble understanding because in your head you're thinking science, 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 and here's us saying geometry, geometry, geometry. Just measure it. She'll be all right, mate. Just measure it.
Hmm.
But
Nah,
anyways,
I'm
my
not a
friend.
flat earther, man. Oh, you're going?
Anyways, I'm going to bed because it's 1:10 in the morning, and I'm sure my neighbours appreciate my loud voice. But anyways, ladies and gentlemen, you have yourselves an awesome one. I'll probably see you in a couple of hours, anyways. Peace.
Oh, can you add me though?
Add you to what? You can come in here anytime.
I mean, as a friend, because I think
Oh, we're all friends with you.
no. I mean, like in Discord, so I can talk to you later, maybe.
Oh yeah, we like to talk in text, chat, and voice. That way, we're on YouTube and the listeners can hear what we're really talking about.
Hi
Wait,
everyone.
Hello,
you're
I,
everyone.
I support flat earth.
Ah!
How do you support it?
Yeah. I,
It's one of the four
wait.
pillars
Hold
of the
up,
whole
hold up.
world.
Answer me first. So, like, are you on YouTube?
Yeah, you've been on YouTube the whole time for the past 8 years, 24/7. Even Christmas Day, even when you're opening presents, we're on YouTube.
Okay. So, are you like a YouTuber?
Now you are now because you're on the channel. You're streaming live right now. You're a YouTuber.
No, I'm not a YouTuber. I'm just in Discord.
Yeah, but, well, unfortunately for you, you became a YouTuber when you came in this channel. You now have a
Are you
name.
streaming this?
What? Yes.
Oh, yo,
Two
tell me
times.
what
Two
tell me
streams.
again.
2 live streams. Look at the top and you'll see 2 YouTube streaming bots.
Oh, damn. Okay,
It's all good,
what's
man.
the channel? What's the channel?
Go
If
to
you
the
click the
streaming
box,
bots and look at them.
yeah, if you click them, they've got the
Oh,
links.
okay.
You did good though. Thank you for being polite. We get a lot of people in here who are very rude. So thank you for the polite conversation.
No, he became
Man.
famous today.
You,
Yeah.
you guys were like more polite than me. You guys were so nice to me.
Why wouldn't we be polite? We're always polite. I'm always polite.
Oh yeah, I could see that.
Radwin is the most polite of all the polite ones.
That's right. Better get that straight.
Wait, it's not opening for me though. I'm clicking on them.
I don't know. Maybe that doesn't like you.
Okay, wait. I click on them. Then what?
Then you have the live stream. You can rewind and listen to yourself, how you made up stories. You can go back and go, oh my God, I can't believe I made up a story like that. That's the fun part.
Yeah,
Okay,
but
wait.
dude,
I'm
let me show
clicking
you.
on them.
Are you
I'm
on your
clicking-
phone? Bro, are you on your phone or are you on PC?
No, I'm on PC.
Oh shit. Okay. Well, if you click on the first YouTube bot, I think on PC there's a panel that opens up,
Yeah.
right? Well, in the About Me section or the description section or whatever it's called on PC, there's a few links.
Oh, yeah.
There we go.
No way. This is true.
Yeah,
You're
dude.
famous. You're famous now. Almost famous. Just like the movie, Almost Famous.
Let me see if my voice if our voices are in there.
Oh, yeah, it's in there. You sounded foolish and all, saying people stick to the side of balls. You can measure angles off a basketball. It's all in there forever.
It's now part of the
Oh my
ether.
god! That's us. That's us there. Th- Thanks for this, guys.
If God wants to check in the accounts, God will just rewind the tape and listen to you.
Like it or not, you're already a flat earther. Flat Earth is going to live rent-free in your head for the rest of your life.
I'm not a flat earther though.
Everyone is.
Nah, I think most people aren't.
Your ears, your ears have a liquid inside. It's called the vestibular system. And in the vestibular system, right, there's a liquid, and it's level, horizontal, right? And
Yeah.
you are a tool that demonstrate the horizontality of this of your own existence.
That's because the earth like feels flat to me.
Oh, it's how it feels.
Yeah, it just feels flat to one person because they're so small.
You're so small.
It's not. Yeah,
But if you were
it's not.
big, then what? If you weren't small, if you were big, then what?
If I was big, then I could see that that wasn't flat.
How big
How big
would
is
you have to be?
How
Let's
big?
follow the logic. Let's bring this logic to some logical or nonsensical conclusion. Go ahead. How big do you need to be to not be part of reality anymore?
You have to be like 10 times the size of Earth so that you can grab it.
10 times the size of Earth. Remember, this is being recorded, though. Just pick your words carefully.
I mean, yeah, I'm certain. I'm sure.
And then you're 10 times bigger than the Earth, and then what? The Earth
And
is a
then
globe now.
yeah, you can like grab it. You can like play with it like a ball, and
So you being big, you are the cause of the Earth being a sphere. You being big.
no, it's just that I
No?
can.
Are you telling me if you were that big, you could hold the earth in one hand and then hold a tree in another and right next to it and let go and it'll shoot towards the earth?
With what?
Nothing.
Yeah, well, that's what I'm saying.
I'm trying to figure out how water sticks to a ball in a vacuum, but you guys won't tell me how that happens.
That's gravity.
Yeah, is it gravity or your nonsense? Yeah.
You also don't believe in gravity?
You believe in it. You.
No, you're the one who believes in
you are the
gravity,
believer.
dude.
No, I'm asking if you don't believe it. Don't believe it.
No, I don't believe
No.
in things that don't exist.
Exactly. No, I don't believe in fantasies that don't exist. Yeah, I don't believe in that.
all four of you like don't believe in gravity and stuff. That's pretty crazy.
Remember, no, that's a crazy thing that you believe in something that you cannot demonstrate, show, verify. You cannot show it in the physical natural world. When you say the word gravity, you actually have you ever seen like birds? You know these parrots that repeat words.
Yeah.
You know when they say a word like gravity. Do you think they know what that word means?
No, they don't know it.
You think you can teach? Yeah, the bird doesn't know exactly. So, do you know what it means?
No, but it's different though. I can
Exactly. So you're parroting a word that you don't even know what it means.
It's different when we do it.
Oh, because you have a different accent than the bird or something.
No, because I understand that it's like proved it, and I can look at the proof if I want.
What proof?
Like the gravity proof and stuff.
Well, okay, yeah, but what proof? What can you point towards it so I can look at it? Can you just say, look, right here, there is a proof, right here. Show it to me.
Yeah, this like physical. I mean, this proof of gravity.
Where? Where is it? Where?
And I think Einstein's theorem and something.
Einstein is dead. Can you show me something like now, right now?
No, I'm talking about like words on a sheet, that kind of proof.
Oh, gravity is words. Exactly, like the bird. Gravity. Paka.
And no, I mean like proof of gravity, like it. We can prove it because these things happen, and only gravity can prove them.
Can you just stop yapping and show it to me?
You can observe. You can actually also observe gravity. Like you can see things falling down.
Oh, that's what I'm looking for. I can observe what falling down, like helium balloons going up. Is that gravity?
No, that's because of buoyancy. They follow buoyancy.
Okay, so when something goes down, is that what you're saying? Gravity is?
Yeah. Like if you see
Okay, so
apple
welcome,
going down.
welcome to flat Earth. Down, you cannot have down on a sphere. You know that, right?
Bro, every flat Earth
You know that
answer
there's
like
no
has
down on a
some
sphere, though. There's only in to the sphere or outwards from the sphere. There's no down on a sphere.
this is relative down to a single person.
Yeah. There, in reality, we have up and down, right? We have an up and down. Yes, we do.
No, like I'm talking relative to me is down.
Reality for you is down?
No,
No?
re- this.
Hey, dude, you
Also
forgot
this law.
everything when I told you before. Down is a flat Earth thing. You don't have down on a ball, and you said I agree with that. Now you reset somehow, and now you're messing with Gemsy.
You can have relative down.
Why are you messing with me? Why are you messing with me, huh?
No, I never said that you can't have relative down and up. You can have relative.
What's a relative down?
It's down to you.
Ooh, so
if I
my
was-
down,
if I
my
had
down
my-
is not your down?
If I had my ankles, I was attached to the ceiling by cables, and my feet were on the ceiling. Down would be the ceiling?
Yeah.
No, down would be when you let go of my ankles and I hit the floor. That's down. Believe me, you'll know what down is.
No, if you were on the ceiling, then down
He
would
said
be.
no. He doesn't know what down is. He doesn't know.
Okay, what do you think down is? What's the definition to you?
Towards the floor?
What?
I mean, what? You know when things go down to the floor instead of going up
Yeah.
to the sky, away, down to the floor, and then when he says ceiling, that's up. Down is below your feet. Up is above your head.
Oh, down is below your feet.
Yeah.
Interesting, because when you are on the ceiling,
Down to the earth. Have you ever heard down to the earth? Up to the sky?
these are yeah, I've heard.
Yeah. It's pretty simple though.
Okay, but okay, imagine your friend is standing in front of you and he says, "There's an ice cream truck on the right." So is it on your right too? Explain that to me.
What?
Your friend is standing in front of you and he says, "There's an ice cream truck on the right." So is the ice cream truck on your right?
To his right, right? When he's speaking and he's telling you to his right, that's where the ice cream truck is, right?
That's what the
To his
guy is
right.
saying. To his down.
He's down is down. That's it. Down.
No.
Down is not right or left. Down, down is not right or left, right?
And you're supposed to use
Correct.
directions like north, south, east, and west. You don't say, go up here and then go right and then go right in this, because you could be turned around and you'd be all screwed up.
Right and down are also directions.
East, west,
So,
north, and south are only flat earth directions, by the way.
Guys, I think I have to go for a while because I need to buy some tofu.
Get some soybean sandwiches.
Nah, I don't eat like soybean. I mostly eat like tofu because I'm vegan.
go buy some lamb or beef.
Nah, man, I
Don't eat
that,
anything
man.
with protein. Don't eat anything with protein. Stick to a pure soy diet because you think that you can stick to a ball because you're made of air in a vacuum.
Proteins actually come from plant, by the way.
Oh, really? That's better for you eating. I go out in the backyard, eat my grass. That's better for me.
If you could digest it, then yeah, it would be better for you.
Oh, if I could digest it. Jeez. I wonder why I can't do that.
Okay, but because you can't digest cellulose, that's the issue. That's just the only issue.
I guess I'm not supposed to be eating it, am I?
Okay, but you can digest other plants. You don't have to eat cellulose. It's just that it's like unnecessary and like it
No,
harms the animal.
there'd be too many animals running around if we only ate plants, and then they'd be eating us because they don't have plants. So we have to eat them first. There,
No,
I
but
win the argument again. I always win these
No.
arguments.
In the meat industry, people actually force breed the animals cruelly to produce more animals. So you're giving birth to more animals instead of like decreasing them.
You know what happens if you eat only plants, right? You know what happens, right? You die. You know what happens if you eat only?
Yeah,
know
you
what-
turn into a plant. What happens is you no longer breathe and have a heartbeat. You fall into the dirt and you become a plant when you eat plants.
Yeah, you feed the
Nah,
plants.
man.
You become part of the soil to feed the plants.
You can be absolutely healthy on a plant diet. There's zero nutrients missing from a plant diet.
We're not talking about nutrients. We're talking about real food.
That's if you don't want to have any muscle or anything. Be weak. Yeah, you can eat plants if you just want to be timid and weak and feeble.
You don't need
And
to kill
feminized.
animals to have muscles, man.
Oh yeah, you gotta be very strong to kill the animal. Yeah, you gotta be very strong.
So you better
Wow.
start with eating rabbits first, and then you can get stronger and stronger and work your
No,
way up to
like-
lion. What? Yeah,
you
you
don't.
can't like listen, check this out. You can't be a baby and eat plants until you're 25 years old and then decide you're going to go wrestle a lion because you're going to be lion dinner.
No, I'm saying that you don't need to kill animals to be like have muscles. You can have it without
But,
them.
no, we don't need to kill the animals. We won't kill them at all. They're just going to eat us because we don't want to kill them and they're going to get hungry when we eat all their plants.
No,
How
you don't
can a
have to
kite?
kill it. Listen. Kenchim, you don't have to kill it. You just fish the fish, and you turn the fire on, and the fire will do the job.
No, that's still cruel. You're cooking it alive. What the fuck, man?
Yeah, delicious, yummy.
Okay, but you guys,
Okay, how
you guys,
about this? How about this? Without being cruel to the animal, say you go buy a cow and you have it in your backyard. How about, and it's your only cow, just for you. Everybody in your family gets their own cow. And then what you do is you just go out there and take a big bite of the cow, like every 3 days or something. And then as that one heals up, you take a bite from another side, and then that one will heal up. And then you just keep eating your cow like that, and you can eat it forever because it'll just keep healing. What do you think of that?
you're still exploiting the cow. You're treating it like a slave.
Wait, you
No,
exploiting the plants?
no, not on
You
my
treating the
farm.
plants?
Not on my farm. They're allowed to do whatever they want. They just can't go across the street because they'll get hit by a car. So on my farm, we don't treat them like slaves. They don't have to do any work. They just have to lay in the grass and moo and just do that fun stuff.
Kenchi, why you being mean to the soybeans and the bacteria that ferment the soy? Why you treating them like slaves?
No, because they aren't sentient.
Have you ever heard a plant scream before?
Plant?
Yes, plants.
Plant what?
Have you ever heard them scream?
They, they they can't scream because they don't even have a brain.
Oh, really? You better start looking this
Yeah,
stuff
they have
up.
no
That
brain.
plants can communicate, and
Yeah.
plants do feel pain.
No, they have no brain. They have no nervous system. They can't feel.
No, you can't prove that.
You're being racist against plants. Why you being racist against plants?
Yeah, he
Okay, you
thinks
guys,
you
I
can do
just
whatever you
really-
want to plants just because they're plants.
Yeah, you can
No, you
abuse the
guys are-
plants, kill the plants, huh? Huh? How you feel? How you feel about killing plants? You're
No,
being
no,
mean
no.
to plants. Why?
You guys are just
And
taking
then
this
you know
lightly
what
because-
happened? You know what happens, Kimchi? The bacteria that ferment the soy, when you eat the soy, you're abusing the bacteria. Why are you doing
Bacteria
that?
aren't sentient. Bacteria aren't sentient.
Bacteria are probably
And-
smarter than you.
And same with drinking water. I wouldn't do that either because you don't know what else is in that water that wants to stay alive, like parameciums and amoebas and weird shit like that.
Yeah, why are you being mean to those?
No. You guys are taking this lightly because you don't know the reality. If you see like the animals crying and before they're killed, if you see them suffering, you will not take this so lightly. You can watch it. You can watch Dominion.
Every time I go to
It's a-
take a
it's a
drink of
truth.
water, I can just barely hear my water screaming at me. But I scream back. I'm like, yay, anyway.
Hey, can't you know that if you're in the forest eating all the plants and then the bear comes, doesn't matter how much you cry, the bear is still gonna eat you.
Oh yeah, the bear
Okay,
bear
but-
wants you to cry more. Bear likes it when you cry because then he likes to bite harder. Because you're still alive, so
Okay,
he's
but-
trying to kill you faster.
Okay, but the bear doesn't understand what it's doing. He's just following nature.
Do you
Oh,
think
I
the
don't
bear doesn't
understand. I don't
understand?
understand either. I don't understand either. I just want to eat a cow.
No, you do understand.
No, I don't. I just want to eat a cow.
You obviously have morals because if someone was hitting you, you would say that's wrong.
Well, I wasn't talking about eating a person. Earth is flat and we eat cows. How do you like that? If you're going to be a flat earther, you're going to have to start eating better.
Nah, I'm not. I don't think I'm a flat earther
Listen, that's
right
part of the
now.
plan. That's part of the plan for you guys, to make you guys only eat plants so you can't really think critically anymore. And then you guys will just be like little tiny plant robots for us, doing plant robot things. You guys will love landscaping.
That's actually not true because the government pushes propaganda for meat and milk more. Have
No,
you seen ads for milk?
no, you're not supposed to listen to the government. You're supposed to listen to your people that know everything on the internet.
No, the government actually supports animal like harming and stuff. The government literally
How the
supports
hell
meat
are
and
you
milk.
supposed to eat if you don't harm an animal?
By living vegan like me.
No, I'm not gonna listen. I talk to my grass before I cut it. How do you like that? I say, listen, dudes, I'm not killing you. I'm just giving you a haircut. We do this every week. And I say the same shit over and over because I know the shit's alive. How do you think that? What do you think of that? And then I'll go and pick something from a garden and eat it. Or go over to the tomato plant and say, look, you made that for me, not for you. Click. And then I eat it, and it gives me more.
And then I'll rip a weed out of the ground by the roots and be like, you don't belong here.
You guys are taking it as a joke.
No, how many?
Dude, I am not joking. My wife thinks I'm crazy because I talk to the grass. When I'm walking out to get my mower, I say, hey, grass, I'm giving you a haircut today. So just like the last time, you didn't die, so don't be afraid.
Let Morphin talk. Okay, Morphin.
I was just going to point out that in order for you to live your vegan lifestyle, certain animals must die.
What animals have to die for a vegan lifestyle?
The pestilence that would destroy the crops that you consume.
So that's a very common argument against veganism. It's called a crop death argument, and it's not true.
It is what it is. Unless you're raising your own yourself, you can't know.
No. Because the crop death argument has been.
Kenshi.
What?
Does a newborn? Do you know? Have you ever heard of the Happy Meals? Happy Meals?
Happy Meals as in McDonald's.
Yeah, but have you ever heard of the original Happy Meal? The numero uno, made by God. Have you ever heard of it?
No, what's that?
It's the original Happy Meal because when babies get it, they are happy. It's called the mother's milk, and it's not vegan.
It's vegan. You drinking your mom's milk is actually vegan.
What?
Yeah, because you're not harming any poor animal to get it.
Oh, so you drink milk?
Yeah, if your mother consents to it, then there's no issue. The only issue is because cows can't consent to you drinking their
mother's milk and you're vegan?
Yeah, of course.
So right now you're gonna go to the store and buy milk,
No, he's gonna go to his mom and get milk.
Oh.
I'm just gonna go, guys. I have to go to buy the tofu.
No,
Hey, hold on. I just want you to know before you go, I'm a carnivore and I eat as much meat as possible. I just want you to know that.
You're actually gonna you're gonna die quicker because of your clogged
No, that's not proven. You need lipids. Lipids are good for your.
That's proven.
That sounds like something that you would see on TV, so they can sell you some medication for it. That just sounds like an advertisement.
No, animal fat has more saturated fats than plant food.
Yeah, your brain is made out of fat, so if you don't eat animal fats, you have less brains.
Maybe that's what's wrong, Kenshi.
Nah, man. Just watch Dominion, watch
Dude,
some YouTube.
listen, go back and listen to the replay of this, and you're going to hear how you sound when you talk about people standing on the side of a ball and down is actually sideways and all that stuff. Go listen to yourself, and then you're going to come back in here and say, guys, you know what? I did sound foolish. Earth is flat.
And I cannot be a vegan anymore because it's dumb.
Okay, I will think about your points. I will watch the video again to think about what points you guys made. But that's all. I'll just think about it. And if you're right, then I'll let you know next time.
All right. You said that the vegans drink milk. Let me check that. Maybe it's true. I don't even know. Let me check. Vegans.
I'll let you know. While you're checking that up, Jimsy, I get my blood work checked every 3 months, and my blood work comes back great.
Nice. I'm good to hear. Hey, Kenshi. No, vegans do not drink milk from cows, goats, sheep, or any other animals. Why? Veganism is a lifestyle and an ethical philosophy that seeks to exclude all forms of animal exploitation and cruelty as far as possible and practicable. So, if you're drinking milk, Kenshi, you're not a vegan.
Really?
So it's not even about eating plant-based products. It's just about reducing animal exploitation. That's the most beta thing I've ever heard.
Yeah. What the fuck?
Okay, so I can. So if I go fishing and I fish the fish and then I eat it, I didn't exploit it. No one. The fish was there available.
What?
So I'm a vegan then if I eat the fish because I didn't exploit any animals.
No, if you kill the fish, then of course you kill it.
No, it doesn't say about killing. It says that veganism is a lifestyle and an ethical philosophy that seeks to exclude all forms of animal exploitation. When I go fish, I'm not exploiting anything.
You're exploiting the fish.
What do you mean? So are you saying that sharks are also exploiting the fish?
They don't have morals like us.
I'm just making more room for the new fish that are going to be coming in.
Yeah, I'm making. There's overpopulation of fish in the ocean. I'm helping the new fish, making room for them.
That's not actually what I'm doing. And having sympathy for animals is actually not a beta thing to do. It's actually
You have to have you have to have homeostasis. There has to be a balance in the ecosystem, and unfortunately, we are the ultimate balance in this world. It is what it is, man.
We don't have to kill cows and rape them to bring that balance.
So
I am
Kenshi,
so thankful. Go ahead, Jimsy.
No, you're so thankful. Go ahead. You're so thankful.
I am so thankful that the creator put that cow in front of me, taught me how to raise it to full maturity and how it can bring nourishment not only to myself, but my entire family and even friends because of the abundance that it produces.
You can eat other stuff instead, and you can live a healthy life on plants. You don't have to rape little kids, cows, and little kid mom to get your milk and meat.
What the hell are you talking about?
Yeah, that's what happens in the dairy industry. They literally forcefully put their arm inside their the stuff to get them.
Kenshi, but it doesn't matter because you're not a vegan. You say you drink milk, so you're not. You're a fake vegan.
Okay, search up. Can you drink your own milk, own mother's milk? It will say yes.
Then go. I want to see you do that.
Okay, I'll show you. Don't worry.
You're milking your mom, Kenshi?
I think you're gonna go to jail, dude.
For what?
I mean, I think I've seen 8 years old, still drinking mama's milk. So Kenchi's probably like 25 and still drinking his mom's milk. I mean, why not?
Okay, I'm talking about newborns.
No one's talking about ripping a baby cow away from the mom to kill the baby cow or kill the mom, right? Like when you slaughter a cow, you're not supposed to do it while the cow is in the middle of mothering or birthing.
Okay, but even if you do it after, that's still fucked up.
I mean, she brought in a bunch of other cows behind him and just making room.
Where are we
You're not-
supposed to put all these animals that we're not getting rid of, dude? Where are we putting them all?
Inside my belly.
This
No, we're not allowed to. He wants to eat grass in the backyard. He doesn't want me to cut the grass anymore. I even tell the grass it's just a haircut, all that spiel. I'm not going to do that anymore. I'm
Bro,
just
you
gonna
were
eat
killing the
I'm-
grass.
Now I'm going to have to tell it I'm eating you now. And then it's going to be like, well, shit, I'd rather have a haircut.
When you put that grass in the frying pan and it starts sizzling, that's the grass screaming.
I know.
Can I have media
Because
pumps
all those
so I
cells
can
are
show
alive.
this guy? Can you guys give me media pumps so I can show this guy?
Kemchi, the media parents required you leveling up in the server. Just send me whatever you want to send, and I'll share it for you. Because it might take you some time to get those perms in the server.
Oh, okay. I'll just share it to you.
I'll send you a friend request since you're not accepting stuff from people that you are not connected to. Accept my
Oh,
friend
really?
request. Okay. I got it now. You want me to share this?
Yeah, just share it.
Alright, I'm sharing something. It was sent to me by Kenshi. What is this about, Kenshi? What is it?
It's just the proof that if you drink your mom's milk is actually vegan, and it's just veganism just means not to harm animals unnecessarily.
So what's your mom got to say about this?
She consents.
Oh, gosh, your house must be crazy looking.
Okay,
No,
so
I mean,
Kenshi, if you don't if a person doesn't eat what it requires to be healthy, like protein and animal fats, and they suffer, then you're saying that if it causes animal suffering, so you think that person is an animal. If they're suffering, then your philosophy is broken. It's bankrupt.
Yeah,
No,
you're exploiting yourself and you're part of the animal kingdom.
I'm not exploiting myself because there's not a single
Yeah,
mineral.
you're suffering. Your brain
It's
is
not
suffering.
I'm not suffering.
But your brain is suffering. It's not
No.
developing correctly.
There's not a single vitamin or mineral that you can't find in a plant-based diet.
How do you get animal fats from plants?
What?
How do you get animal fats from plants?
Lipids. You need lipids. Lots of different variety of lipids.
You can get plant fat.
Bro, you're not gonna get booby milk from a plant. What are you talking about?
Okay, but
Well, I don't know, man. Coconut, the water in coconut is supposedly the sperm of the coconut.
Yeah,
Wait.
and that doesn't grow in
drink coconut milk.
your mother's breasts, and that's not what you get fed when you get born. So stop being a clown and enjoy what God gave you.
Did you think about, not you, the other guy, what you said when you said, when you're talking about breast milk? Because cows eat greenery.
yeah.
Okay, so they produce milk, but they for feed, but they still eat vegetarian or whatever.
What about all the
Yeah.
insects in the grass and all the worms and all the larvae and all the other non-plants stuff that is in the grass that the cows
Yeah,
are
guys.
eating?
I'm not gonna lie. I have to go. The shop is gonna close real soon. I have to go. I have to make dinner also.
Oh. Well, I just want you to know I don't eat plants that much because I don't want to be selfish and harm the animals because those animals they'll starve if I eat all their plants.
Okay, man. I just had a really fun time here, so I'm just gonna thank you and I'm just gonna leave.
Yeah, man. You stay blessed.
Have a good one.
Have
Thank
a
you.
good one.
Thank
I
you.
don't
You know
like
what
the
they
hurt.
Bye.
you know
I
what
don't
they
like the hurt.
feed a bunch. Oh, go ahead, Elijah. My bad.
I don't like to hurt the plants because the plants dance.
They dance with the wind.
Jamesy, you were saying something. What were you saying?
I was saying that yeah, the animals they do eat some of the grass, right? But in the industry, many of the animals when the that grass is not like fulfilling for them, they might get sick. They get parasites and stuff, so they have to treat them, and then they have to feed them plasma from other animals. Like plasma, they get it from the blood, so they mix the plasma in their feed, and they get better with plasma. So basically feeding them like the plasma from the blood, so they can be healthier.
Yeah,
That
Yeah.
doesn't make any
and that's
because left alone, they would just be in the wild living. Like they don't need us to interfere with their plasma and shit.
true. That's true.
Well, in the wild, they eat insects, larvae. They eat bacteria.
Oh,
So
you're
so
saying stuff. It's not. They get sick. Something's missing.
yeah, because the I think it might be like the pesticides and the grass, because only grass is not full nutrition for them. Only grass. It needs more stuff than that.
That
You
makes
cannot
sense.
just they cannot just
Even
eat
if
only grass.
Even if it were, their body's going to convert. So the milk that they produce for their calves is not made of grass. So it doesn't work. It's not like a 1-for-1 conversion from grass to milk. It's still an animal product. I mean, look at bees, for instance. This is why some vegans are so specialist. They won't even drink honey. Because it's the nectar is one thing, but to turn the nectar into honey, you have to do a conversion with that which comes from the bee uniquely.
That doesn't make any sense because I mean, don't they eat nuts that, and berries that plants produce? Or what's the point of not eating honey?
I'm saying not all of them, because you got a range of retards, right? You got vegetarians, you got pescatarians, and then you got full blown religious vegans. But some of them won't eat honey. But the thing is, the reasoning behind it is silly. But regardless of the reasoning, that wasn't really my focus. It was just that it's not the plant matter alone or the plant product alone that produces the honey. It has to be converted with some kind of I don't know. I don't know what you call the process, but then they make it inside the actual bee itself. So whether it's saliva or something else. And I'm using that as an example to compare that to mother's milk from a cow, right? It's not the grass alone
The
that
cow has a
produces
bunch of bacteria and organisms that actually are digesting the grass, and those organisms are basically tiny animals.
Because if it was just a 1-for-1 conversion from grass, then we could just make milk in a lab. But we can't. We have to get it from cows and goats and then our mothers. We have our heads on straight.
Well, I don't think that. I think we can. I don't really know exactly what the deal with eating is. What I do know, what I specific,
Breatharians.
Say again.
You're gonna start
He's,
the
he's
new
a
religion,
breatharian.
the Breatharians.
Well, no,
I could respect them more than I could respect vegans.
but what I'm
At least
saying
they're
is
willing to die for it. Sorry, go ahead.
this is what I've experienced. When I was a vegetarian, basically I didn't eat meat, but I still ate everything else. So when I say everything else, just think of all the garbage we still eat minus the meat. Candy, cookies, all this, the stuff with the animal products in it, whatever. I think most people do this, trying to thinking they're healthy. But anyway, I had a lot of stomach issues, and nothing like I had to go to the hospital for, but it just, I remember there was it's not like there was a significant change where I was like, that's odd. Now, when I started, maybe, what was it, 6 years ago or something, in here, y'all will probably remember Jay talking about eating and health and stuff. And at that time, I was only eating chicken, salmon, and maybe rice and like plantains and stuff. And sometimes I would do the salad. But I started backing away from the salad because it used to upset my stomach. And what I realized during this period was I wasn't using the bathroom frequently, like as frequent as I assumed I should. They say you should, use the bathroom twice a day, number 2 or whatever. But the funny thing is, during that process, like I could go like once a week, maybe
That's actually
more.
true. That's
And I'm
actually true.
saying
What you're saying.
I'm saying that to link it to what we're talking about now. I had not experienced anything like that until now with my newborn, because I thought it was odd that she wasn't using the bathroom. Well, apparently, when a baby is breastfed only and they're not given that Enfamil bullshit or any of that other powdered stuff, they don't have to use the bathroom every day or every other day. It could be a week, it could be 2.
Yes, sir.
So I'm thinking that our bodies get rid of waste quickly, and the foods it can use, it actually keeps and breaks down. Because why, when I was only eating meat, I wasn't backed up, because I went to the hospital. I thought something's wrong. They looked at me. I ran a bunch of X-rays, whatever they run to check your stomach, and they were like, "No, everything is fine." So I just thought that was interesting to share.
Yeah, many
It's
people
very personal.
that eat only meat, they report that they don't go to the restroom often, because bathroom will include the bath. If you're gonna do number 2, you don't have to go to the bathroom. You can go to the restroom, Elijah. It doesn't need a bath. But most people bath. I mean, a lot of people bath after number 2. Yeah. So yeah, the bathroom, sure.
And then the really special ones, they bath first and then they're number 2 in the bath. But anyway, yeah, if you're not full of shit, you don't have to go to shit all the time.
And that's what I think. What is shit? Well, like I'm saying, shit is waste, and I'm saying it's interesting that when I was eating more just meat, when I was more meat focused, there wasn't as much shit. So my body was, because that's a lot of meat. I used to eat in a half a chicken, another half a chicken, like, because that was all I was eating. So I wasn't filling my body with cookies in between and drinks and juices and all this other shit. So when I was hungry, I would eat. And when I wasn't, I just wouldn't, because it wasn't an entertainment thing for me at that time. It was just, I feel like I need to eat, so let me go eat. And what I'm saying is the waste came out of my body was less. It's almost like my body was actually utilizing the stuff I was putting in it.
Yeah, and this is why the culture has changed so much, because previously it was outhouses, or not even an outhouse. You just go out with a spade and dig it in the ground, right? But as they've messed things up over the years, you start bringing all that stuff in house, so you didn't have to go so far. But the use of an in-house shitter had would be next to nothing if your diet was like your diet or like the old school diet where people were healthier. Because you're like, what am I going to dedicate a whole room to this thing that happens like once a week, and I can go and do outside and fertilize my ground with? But they played the trick on people, man. Eat 3 times a day, shit 3 times a day. It's like, well, something's wrong there.
Man, we could be living a total lifestyle, and we don't like. We think we're different, but we're all under a system that forces us to live a certain way. We don't even know what other ways of living are better for us, because we need it. It kind of, well, no, I guess it doesn't take the society. I mean, but it's very hard to overcome. That feeling of doing what everyone else is doing, needing to do that. Yeah, think about it.
You grow up in it, and your only
Elijah,
exposure is
Congress on the my bad, Elijah. I think there's 2 Elijahs, but Congress on the baby though. That's amazing and so joyful to have the children. It brings so much joy to the families, new babies, newborns.
Really does. It's not stressful at all. I don't care about sleep. I don't care about none of that. Pretty cool.
Do your best to keep the baby exclusively breastfed for at least 2 years.
Yeah, I'm trying. It seems like that's possible. Seems very possible.
It's the healthiest for everyone. The only thing you want to be considerate of is the mother and whether she has sufficient nutrients for that. So do a bit of research and keep her well fed and well like minerals and all that stuff.
I've been trying to do that, but when you say trying, I know. When I say trying, I know you're like, what do you mean? But the way that I don't even want to put it on a we and say it's American. The way that the way that you may deal with women are probably vastly different. And so my things are suggestion. Annoyingly, she may or may not accept. And then when the situation arises that could have been avoided, it's like, well, now you have to deal with that stress instead of saying, well, you caused this. Now you have to fix that too. It's like,
Yeah, well, I mean, I'm not going to make it personal. It's not my point. It's just the general stuff, because it's an important topic and it matters to both parties and then the future children that people plan to have. Like the height that they can grow, the health, the beauty of the child, it's all related to this breastfeeding thing. It's really important.
Yeah, it's like,
you ever heard about that? Like the beauty side of it, because the way their jaw develops. Because if they don't breastfeed enough, they don't get enough jaw development, and then their teeth get crowded, and there's so much stuff that's like compared to it.
And the brain development as well.
Yeah.
Well, with the brain development, what they say with breastfed babies is that they need a vitamin D supplement. What do you think about that?
Listen, vitamin D, all you need is sunlight through the window, or not go outside to the ceiling, to the roof, and let the baby, if the baby can be naked on the sun, just let the baby just be all half naked, like just with a leader thingy covering the parts, and just get the morning sunlight or the evening sunlight. The noon sunlight is good, but not, it could be really hot in some areas. But all you need is sunlight for that.
Well, they say that that's not enough, but perhaps people aren't doing exactly what you're saying. Because people, when it comes to cooking, people understand there's a formula. But when it comes to handling people, relationships, and communication, that's when people want to, think that, well, that's when people want to take for granted that should be formulated too.
Yeah, regarding vitamin D, they be lying. All you need to
That's
do
what
is that, right? You can get enough
saying.
vitamin D in this horrible country, man.
All of the cavities and stuff. I'm like, but doesn't everyone brush their teeth twice a day? It ain't even the fluoride. People just don't brush their teeth. I promise you that's what it is. You'd be like, damn, you got all these people that are going to the hospital because they smell funky and they say, no, that motherfucker just ain't taking 2 showers like they're saying they are. It's not possible. And people are like, yo, I've been doing that to lose weight, and it's just that it's my hormones and I'm a woman. I'm like, no, you can't be eating a diet where your calories are in a deficit. Like, there's no way you could be eating less and gaining more. That doesn't make sense. But we've told ourselves that does make sense when it's actually simple. So it might be simple as laying her out naked in the sun, in the sunlight a little bit. Like, most people will probably do it for 2 minutes, not have them unclothed and be like, this isn't working after 2 days. So I don't know, you might be right.
The cholesterol that the baby is getting from the mama's milk, the sunlight and the cholesterol work out together to produce a bunch of other hormones that is for brain development, bones development, and just growth overall of the body, the overall growth of everything, bone health, everything. And what you're saying, yeah, that's it. The sunlight, bro. The sunlight is just part of this whole world. I mean, that's just an important key. Just that, because the supplement that you're saying might help, yes, but it will never compare to the sunlight, to the light of the sun. Like, it's just made by the creator. What do you want me to do? I cannot make it more complicated or more simpler than that. It's just sunlight.
Yeah, there's no synthetic alternative to sunlight. You either get it or you don't.
There is artificial lights, but obviously they are like a lower version than the sunlight. But you still can get like a full spectrum.
Yeah, the closest thing to a beneficial light source to the sun is the fire. Like, sat by a fire of an evening. That's the closest thing. That's why cooking your food on fire is a good thing. But all the others are either neutral, like incandescents are neutral. They're decent to like have your home with, but they don't really do anything good or bad, right? Necessarily. But if they're not neutral or like tiny benefit, they're all bad for you, like LEDs and fluorescents.
Shouldn't there be like somewhere on the earth that there are people who live better and thus their development is much better, therefore they're healthier, more intelligent beings? Like, shouldn't there be an area that kind of dominates the dumbness of the rest of the world because they're doing, like, we're dumb because we're under this system? Shouldn't there be somewhere else, completely free of all of the government bullshit, who I would think would theoretically grow stronger and more intelligent, and thus get to a place that they could actually,
The answer is yes, they should be, but if there was, we'll bomb them.
But I'm like, we'll bomb them, but shouldn't they like just get, if we're that, like, we can't be that much dumber if we can just bomb them and that's the answer, right? That means we're smart enough. Are we losing that much? We should be able to overcome idea of bombing, right? If they, if
I mean,
I'm
my
saying,
bad. YouTube. I don't want to use that term. What I mean is military. I don't mean like bombing. Like I don't know. I'm not gonna do that. I'm not saying I will, but I'm saying like people kind of like do that during war to other people, and that's the way it is. I'm not saying I'm doing that. No, I'm not.
You might
I just think
just because the group possesses intelligence doesn't mean they're going to use it against other people.
that's true. There might be a it might just be obvious that when you're not a narcissist, you just don't seek to do those things.
Yeah, in the context, right? Because like, if you would make a generic argument that like hunter gatherers are more intelligent than your average American citizen, it's like, oh, but those hunter gatherers, they don't know how to use a phone. It's like, well, because nobody ever gave them one, and they don't care about it. So you have to like sift through the nuance and the context. How are they choosing to use their intelligence? The fact that without the internet they can survive out in the wild, doesn't that suggest that they're more intelligent than you, your average retard, coke drinking couch potato? You know what I mean? Now, obviously, that's not directed at you. That's directed at the stereotypical waste man.
Yeah.
Yeah, people don't. I don't think people even know what intelligence is. And then on top of that, you're like wisdom and intention. Intelligence can only take you so far. Wisdom is of more value than intelligence.
Right. Is that what people are missing then? Because we have, I mean, it's not like we don't have the facts. It's not like we haven't been sharing the facts. So it's not the knowledge. One of the kids, they came up to me randomly yesterday and they were like, "So, are you a flat earther?" And I'm like, "What do you think that is?" So that's how the conversation begins. But ultimately, I asked, "Okay, so what do you believe?" She goes, "Well, I believe what we know for a fact because of the scientists, the pictures, and the blah 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 blah." And I said, "Okay, have you checked?" And she's like, "Well, yeah, because like obviously." And then she goes back into the satellites, and I'm like, no. Have you checked? Do you know what I mean by that? So I go into, living on the surface and there being a consequence of curvature and all this stuff. And I'm like, have you checked? And she, well, no. But then she said, "Oh, for a fact." I'm like, but you haven't checked. So you can't say that you know for a fact you believe. Like, why can't you just admit to yourself that it's a belief you have? It was very difficult. She couldn't accept it. So the thing that's missing is the wisdom, because she doesn't have an experience of what I'm saying, but she's telling me something that she's learned as a fact. That's the difference between intelligence and wisdom. Is with wisdom, it's an exchange of your experience in the moment and whatever God is doing to give you epiphanies or understanding in that experience or whatever. So when we talk to these Globers and it's like they don't have any experience. They keep on talking about outer space and these measurements of spherical excess. And it's like, what is your experience? Everybody in here saw something weird. Like pulling out some binoculars and seeing a boat. Now, obviously, why would you do that? Like, if everyone was honest about it, It'd be like, well, I pulled it out because just like everybody else in the world, I believe that the ships are disappearing beyond the horizon. So how come is it I can't see a ship, but then when I put binoculars on, I can? So the cope or the way to not really respond to that is, well, it disappears eventually. Now, that's not the point. The reason that people pulled out their binoculars in the first place is they thought that when they don't see something with their eyes, this is what we all believe. You're looking out into the ocean, you don't see something, it's probably because it's beyond the curvature of the earth. So once that condition wasn't met, more and more of us started asking more questions. The bottom line is the people that have made this place possible, that have made our debate tactics possible, all of this shit that we've done, and the one thing that they haven't considered is that they simply haven't checked.
I have similar situation with what you're saying, and the issue is that obviously we've been fed certain information, so a lot of the people that ask me the same question that that person asked you, I kind of tell them, so what do you believe, right? Oh, what do you learned? Oh, I learned Earth is a globe, whatever. So you learned that in school, right? You saw it in the book. Yes. What did it say in the book? Yeah, Earth is a globe. This is how big it is, or whatever, right? No, sometimes they know, sometimes they don't know. So you got that data, you got that information already. Have you checked, like you were saying? Have you checked that information? Have you verified for yourself? Many times the answer is no. I haven't checked. So now there is a question on the table. Is that information that you learned? You passed the test, right? Yes, I passed the test, whatever, right? They graduated school, so they did pass the test. Have you checked? No, I haven't checked. Now there's other information contrary to that information that you learned from the book, and that information goes against the belief that you're holding at the moment, because it's not knowledge, because you haven't checked, you haven't verified that information. Now you can check the new information and maybe check and verify that, or falsify. You know what I'm saying, Elijah? It's kind of like there's two different books that you can look at and maybe check which one is fiction and which one might be factual. You have two sets of information. You already have one planted to you. Earth is a globe, whatever. But there is other information that is contrary to that belief. And I get, yeah.
If you get I know this is probably not what you meant, but what I just thought about is very simple. Let's say I give you a book about plants. What can you do with it? Or a book about planting, whatever it's called. I know it's botany. Whatever it's called. I don't know. Anyway. So you know what you can then do with that book? You can go plant something. You're not gonna. Yeah. As a matter of fact, you're not even gonna question it. You're like, okay, let me see how this works. And then you're doing it, and you're like, oh, it's doing the thing. Now you're getting an experience. Okay, let's crack open your earth science textbook. Okay, now that you know it's a globe, how do you go check?
Yeah, how do you use that information, and how do you can go verify it? And contrary to that, like I was mentioning, you have another set of information, which is laser test, long distance observations, maybe infrared optics, and like, for example, the example that you gave about the boat disappearing, it was planted in most people's minds that the reason they observing this effect of the boat disappearing is because of one variable. The Earth is curving, so therefore the boat is going behind the curvature. But then you can present other variables that are reasonable, like there's humidity, there's particles in the air, angular resolution, a bunch of other variables that the person probably have never heard before. But you can, I mean, there's more data now. And now are you gonna say that all these other data is invalid and only that variable that you were kind of like given, that's the only viable thing? And a lot of times people say, you know what? Let me check let me check the extra data, the extra information. Let's check that. If you know what I mean.
Yeah. Yeah. Eventually, they get some eventually get to that point where okay, because I don't know what it is. I think that discovering something is the most interesting thing in the world. The most interesting thing in the world. It's fun. It's new. It's everything. Right? Like, so it's like, what is the motivation for someone to come up to you who's explored and say, what's the point of you exploring? We already know this. Well, what I'm exploring is actually contrary to the thing that you're telling you know, which is why it's interesting. If that weren't the case, I wouldn't be doing this because then it wouldn't be interesting. I wouldn't have anything. They'll go, why are you doing that? It doesn't. What's the motivation? Why is it fun to tell somebody that you know what you know, especially when you don't have any experience other than what somebody told you you know? What's fun about that? That's totally boring. So you're going to tell me what to think. And then I'm going to believe my lying eyes. And then I'm not going to believe my lying. And I'm not going to go with my experience because of what you told me? That doesn't make any sense.
Yeah, a lot of people don't even have any experience at all. So
exactly. And the person A has no experience, and then they go, well, what have you done? I'm like, well, I have this experience and that experience. And they're like, oh, who cares? Why'd you ask then? Like, isn't it pertinent to the conversation being fun? Like you say something, I respond to that thing. And it's like, this, who is the guy? You know who what's that? He's always in here. What's the he has the glasses.
Guy with glasses. What does
like he has
about?
He has a picture in his icon.
Oh no, Scott.
Yeah. Scott, like he will really put himself into a corner. And he'll like what word were we talking about? No, I don't think we were talking about gas. I mean, we've talked about everything with Scott, right? At this point. But I guess all I'm saying is like he will say something for sure or that he thinks is for sure. And then will present a citation along with some type of evidence that he can actually go and experience for himself. And he'll be like, well, why are you doing that?
He's just silly. What you're doing is silly.
That's fine. You telling me you believe this? You think that this is a fact? So here's the thing that contradicts that. Go explore this. Tell me I'm bullshit. Go see for yourself and tell me I'm lying. They never do that. They just complain and cry about what they believe. And I know it's hard, but should I have I want to be I was just like you. I want to be compassionate, but there's no compassion for the people that are telling the truth. What about that? You know, just because people think they know this, that, and the third, they think they could just be disrespectful to us. Like we don't know what the fuck we're talking about. It'd be crazy because we know more about science. We know more about geometry. We know more about literally everything. And it's like when people find out that we actually do know more, we don't have to Google it. It's still like, oh, well, fuck you. Because you're a dumb flat earther. But I know more than you about what you believe. How am I the dumb one? Explain it.
Yeah, because what you know goes contrary to what I believe. And what I believe is it was given to me by the experts. And you're just silly. That's what Scott will tell you, basically. You're just silly, and the experts know what they're doing, and you're a silly guy.
Right, the
That's
expert.
Scott.
Okay, and I'll go, okay. Well, I mean, what is it? Some sort of religious text that I don't have access to, or when I open it up, I wouldn't understand? Is that because, like, I already know what you know. So it's like, okay, circumference, roughly 25,000 miles, radius, 3,959 miles. You can use that for the cosmic distance ladder. That's how you know what orbits are what speed, what distance. From that one particular number that I know that you don't. So I'm like, okay, using that number, we can use trigonometry to check. And every time we talk about that, it's like, why would we do that? We have pictures. Okay, so the pictures should go along with us checking then. Because the point is, once you check and you see that they're lying, that's the point. Because I'm not trying to tell you anything. You're a whole human being. You should know the truth for yourself. You should love the truth, and you should do good in the world with it. Because everyone else is not going to be like you.
Elijah, can I throw you a curveball?
Sure.
I've been entertaining this idea, and I heard multiple people bring in scripture before, right? And they say that the Creator was said that He will send a great deception to them, right? Because they will not accept the truth or something like that. And it says in the scripture, probably shopping it, but it says something like that. And I was thinking, what if the Creator to deliver His deception to the masses? What if He needs people to spread the deception? Like, let's say agents, right? Let me use that word, agents, right? But what if these agents are designed to believe in the deception and not actually have the capability of getting the truth? You know what I'm saying? Like
what? Like
Scott, the professor, the mathematics professor. What's his name? Everybody loves him. Matthew Learns.
Well, okay, that makes sense. Because I was going to say, but why would that prevail over the truth? But that's the whole point, right? Is to like spread the deception. Well, what if okay? Can you tell me why it says that he did that, or why? What's the motivation for that?
AI guy said that because they will not accept the truth or something like that. We have to read
They
the
do not
scripture.
love the truth. They do not love the truth.
They do not love the truth.
So,
And that
okay.
adds up to me too. Matthew Learns, Scott, all of these people that are just basically spreading the freaking deception.
Matthew is a good example because he's a math teacher. He has over 500,000 subscribers. And he'll come in the room and we'll have a conversation. And we'll talk about, like I brought up when we were talking about celestial navigation. And I said, well, considering that you have to subtract 90 degrees, which means you have an elevation angle, which means one of those lines represent the earth and that line is horizontal. And so when you get a radius from the GP to the boat, where however that number gets calculated, it's a straight line. And he'll just go, well, it is what it is. Like, I still believe what I believe. And I'm like, that it breaks my heart because it's like, if I'm in a debate with somebody and I lose, that's one thing. But if I'm in a debate with somebody and they concede and they still go, but I'm going to believe what I believe regardless, I don't get that.
Like I'm saying, like imagine a computer that has a limitation and cannot process. It can only process to a certain point, and it cannot process like the next level. Like you and I, we learned the globe, we processed that, and we got it, and then we learned new information, a new data set, and we were like, you know what? This data set supersedes the other data that I got before. So scratch the old one and let's go with the, with this new data that is actually adding up to, let's say, the truth. But the people that are part of the deception, they cannot get the new data set. They cannot process it. I mean, they might be able to entertain it, but their computing power is just not there to actually kind of like be part of their programming. By design, like you design a computer. One with more RAM, the other one with less RAM.
So then should we be telling anyone anything then? Like, if that's the case?
That's what I'm questioning. Like, so then what we're supposed? I think there's other stuff in the scriptures that says that you have to. I mean, you have to kind of like, I don't know. Someone back me up. You have to bring the truth and spread it. Yeah.
In Ezekiel, it talks about the watchman who's on the wall. If he looks out because he's guarding the city and he sees danger and he warns the city and the city's safe, then him and the city are safe. If he sees danger, doesn't say anything, and the city is destroyed, then the city's destruction's on him. If he sees danger, reports it, and the city doesn't heed him, and the city is destroyed, the city is not on him.
Yeah. And is there some sort of spiritual benefit? Like, are we getting stronger for, like, because I didn't really need. Well, I mean, you need day to have night, right? Because here I am saying I don't really need to get boosted up with the truth. Like, it kind of just is something that's there. Like, you either discover it or you go about your day discovering something else. Like, because the only thing a lie is a contradiction to reality. No matter how you that's it. Everything else is just what it is. So the lies start happening when people start saying things that aren't relevant to reality. whether it's how they feel, whether it's what they claim they, whatever it is. So I forget what point I'm trying to make. Oh, trying to. I get though. I like you. I feel like I definitely should say, hey, watch the cars while you're crossing the street. It's dangerous around this corner. I should say that. But what I'm getting at is, how many people do I have to see go fuck off and then get hit by a car? Like, is that supposed to be strengthening the truth in my eyes or something? Like, I already know it's true. Like, how much more true can it be? Why do I need to suffer everyone else's delusion? Because we already know, like, what do I mean by suffer? I don't have to go to it. It comes to me. Right or wrong. Like, when people engage you and want to talk to you, like, it comes to you. I don't give a shit what you believe. I'm not sitting here like, what do you believe in? Okay, now let me debate you about it. I'm not going around doing that. People will come to you and go, right? Look, hear me out. People will come to you and go, man, Artemis 2, huh?
Yeah, that's what happened to me. Yeah, exactly.
That's what happens if I say absolutely nothing.
Yeah, mine too. I was saying nothing, and they were saying, "Look, the moon landed. They're gonna land on the moon." I'm like, "No, they're not."
April Fool.
You damned if you say something, you damned if you don't. You just can't say, look, I don't believe what you believe. That's a fight.
I
What do
said
you
I'm
mean?
skeptical about it. I said I'm skeptical.
Like that.
It was just on the news. They were just telling me what the news are saying, and without me asking. I wasn't talking about anything. I was just there doing my own thing. And oh, in the news they're saying that have you seen the going to the moon? Like, oh my gosh, should I should I pull my sword out, start chopping heads?
Well, yesterday they offered me the question. Well, it was during lunch, so it was like several people. They were like, "Hey, what do you think about them going to the moon again?" I was like, "April Fools," and then I left it at that.
That's another See, So, okay. So the remember what, maybe 3, 4, no, like 4 or 5 years ago, there was a rocket launch that was, we were all into it, right? And the ones with the the mice and shit. It's like, what's that? Oh, it's just a block of ice. Like, no, it looks like a mouse. That shouldn't be possible. That's not possible. But that's what we're looking at. What's that? But back then, right? They had another launch after that, right? And we were all tuned in. Remember the Rick Astley joke? That you would get Rick rolled? Remember that? That was fun, right? To get Rick rolled, like, oh, here we go. Yo, NASA didn't tweet nobody else but Rick Astley. Never Gonna Give You Up, the Rick Roll song. How does you troll? How does bam, right? Okay.
Yep.
So now, like Gypsy said, oh, let's talk about Artemis 2. On April 1st.
Yep.
So you're trolling. You're trolling for sure. On April 1st, there was no other day. Okay.
Well, you gotta remember though that these dates are in many cultures for a long time. This is like very important, let's say, religious and celebration days based on people believing in God and the Creator and following His like calendar and the timing of the year. It's kind of like a celebration time, but it was changed into like a fools party, and now, well, that's what we got. We got a party of fools that are fooling each other, and we have the astronauts that are mocking the Most High, calling themselves the highest ones because they're saying that they're going higher than the Most High. So it's like a mockery of God or something. And these weeks is like a very important weeks for in many cultures across the world.
And you know what's crazy? Well, you're saying it's a mockery of God, but because they're saying they're going higher than, well, if you believe in the Bible, because there's like the Quran and there's the Baghdad Vita, whatever, all the other shit, right? Like, okay, all of those cosmologies have a ceiling. The only one that doesn't have a ceiling is ours. That doesn't even make the word ceiling has no meaning in our cosmology. Okay, so that being the case, when you say what you say, obviously, me as a secular person, I'm gonna go, everything you're saying is bullshit. The first thing you said was God. That's all bullshit. Everything you said, right? Because obviously technology and science and the advancement of the world and yada yada yada. So fuck you, right? That's common sense to say. People would say.
Common nonsense.
But it makes it like that being of the world. The feeling in me, like that still arises. I'm only aware of it. The feeling where I go, Jimsy, shut the fuck up. You don't know. But that's the primal feeling in me. But then I go, except for the fact I actually already measured it. So them doing the contradictory thing, it makes what you're saying possible. Because had I not measured anything, what you would be saying would be absolutely ridiculous. Had I not checked, you would look like a moron and a retard. We all understand this, right? Without that wisdom, without that experience, that's what we sound like.
You know what? The person that was talking to me about the Artemis and they're going to the moon. This is a person that is very like old fashioned, and she's a believer, and she believes in God, but she also believes in this NASA stuff, and she also believes in these weeks that it should be like a like a celebration of God and coming with the family together and kind of like getting closer to God, but then she believes that they're going to the moon at the same time. So she's having like, I don't know, it's kind of weird. How do I put that together?
Well, what's happening is
she's missing information. Go ahead.
She's got two religious truths, and she's trying to make both of them be true at the same time. If you try to point out the one religion is false and that her core belief actually comes from the other one, but the core belief supersedes or is supposed to be greater than the other one, she makes the core belief bend the knee to the secondary belief, right? She's Christian. She says God is real, the Bible's true, but then makes the Bible bend the knee whenever it says that, the firmament gathered everything underneath it into one place, meaning you're in a contained environment. Because the second belief is now the new belief, and it has to take precedence because everyone else believes it also, blindly.
You know what's interesting about that? And tying into what I said to Jimsy about the way we appear to others. Most people won't do enough research to realize Like they'll be like, "Oh, religion is so dumb. Fuck God. Fuck this. Fuck that." The reason you believe what you believe about the sky and the earth they came from the Catholic Church, who still holds the power to this day. That is the longest line ever when the Pope comes into town. There's no, the president can't get that much pull.
There's no second to that. There's no number. I mean, there's no superior to that line. Yeah, there's no longer line. Yeah.
So when you know that Nicholas Copernicus was, you know, the nephew of a priest, and he went to all of those schools, and his motivation was because the church wanted him to change the calendar that we still use. At what time is it? 2026 after Jesus's death, right? That calendar, the religion that we were under, that we're still under, that people think they're not under, but they'll curse it and go, "Oh, you believe in God, this, that, and the third." Everything you believe about cosmology and science came from the church. How ironic is that? But people will never know enough because they'll never be interested enough because they're so caught up. It's the people that brought you the deception are the people that you hate and despise the most. How funny is that? Ha, ha, ha.
Well, the Bible predates the Catholic Church, and its founder claims that there would be wolves in sheep's clothing, and there would be people claiming to be his people, and they're not actually his people. And then it gives great descriptions on, you know, who the whore is and all this, and who's the beast, but everybody ignores it whenever it paints the picture of the Catholic Church.
2 Peter chapter 2. It's one of my favorite chapters.
2 Peter chapter 2. Look that up. And it's crazy. So like you said, that's a very good point, that the Bible precedes the Roman Catholic religion and all that. Like it precedes a lot of the bullshit. And for it to say, hey, people are going to come along and act like they're this, that, and the third, and then you look at the history of what happened 500 years ago, because we're in school, right? Like they do all this. Okay. In high school, what you learn about the Protestant Reformation, right? You learn about the religious wars and all of that in history, right? You learn about why. Right? Guess what never comes up? The fact that at the time everyone thought the earth stood still, and then the church decided, no, it doesn't. It goes around the sun. Change your whole cosmology because I said so. That part, they never said that in school. They never said that. How could you, the reason that we follow the calendar we do today, how could you miss that part? That doesn't make any sense. It's on purpose.
Hey, sorry about the background noise, but Elijah, real quick. Isn't it weird that back then, if you spoke against the church, it was heresy, right? But somehow Galileo said we weren't the center of the universe anymore, and he gets put on house arrest. And heresy was punishable by death back then.
That is interesting. That's a tiny golden nugget that I could have in my back pocket for extreme situations for history buffs. Because I wouldn't be able to flex that on nobody else. That is interesting, though.
But you are right. I didn't know that Copernicus was a bishop or a priest or whatever. And that's an important thing. It's funny how the heliocentrism is completely made up every step of the way by the Catholic Church. And then the telescope that they use to look out into the universe is Lucifer.
Right, the Lucifer, well, or is that a town? Either way, it's funny, you know. They left a Bible on the moon, supposedly. Why would you even say that? Why would that even be in the lore? Why would that be in a nonsense story in the first place? You know, like, and then you got people, you know, one of our most popular shows, The Big Bang, you know, full of a whole bunch of science geeks that know a lot of stuff and all this, that, and the third. The Big Bang, coined by Georges Lamaître, who's a French mathematician who was also a priest. Hello. 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 You know what I mean? A priest coined the term Big Bang. Not that that
You know what I
matters,
learned?
because
You know what I
if
learned
it is,
recently?
how do you know what you know?
Oh gosh, I'm in the wrong.
How do you know what happened in a time no one was around? Obviously, you don't. That's the fact that people can't accept the difference between them believing something and knowing something. To me, it's the most simplest. It's the thing that'll set you free. You get set free when you know the difference between, like, you have a certain tool belt and you're like, this is what I know, this is what I don't know. You know? There's not actually an answer for how do you know? Is there an answer for how do you know? If 500 years ago they said we revolve around the sun, they didn't explain how they knew. They didn't say, they just said this is what it is. That they wasn't, this is what we experience, this is how we know. They're just like, this is what it is. And then 400 years later, Edwin Hubble comes along. Edwin Hubble says, based on what my founding fathers have said, this is what my research is going to then branch off from. So you mean to tell me in 400 years, there's been a claim on the table that nobody's validated? And then he goes, oh yeah, well, based on that claim 400 years ago, I'm going to continue forward off of that. And I'm going to add a couple of my own assumptions as well about the expansion of the universe along with my friend Einstein. My problem is, why don't people know this timeline of events so that they can make up their own minds? I don't want to tell people what's what. I want people to make up their own minds instead of accepting the minds that were given to them. They think it's theirs. It's not. As much as they want to laugh, as much as they want to, as much as they want to feel how they feel, the moment they get pressed, what does math professor Matthew Learns do? Absolutely nothing. We got anybody new in the room?
We do have people, but this is A deep topic that can go many ways. I'm talking about the baby and how good the sun is for the baby. It's kind of like it was designed to be that way. And how the sun is April's Fool. April's Fool was devised by calling the people of the past that were against when against the new calendar, right? And they were saying no, the God's clock or calendar of the sky that we've been following since I don't know millennia. It works this way, and it has it's different than the ones the ones that you guys are pushing now. So they made it April's Fools. So called those people fools, the ones that don't want to go with the new calendar, the new timing from. You know what I'm saying, Elijah? So you were talking about the calendar, how they changed it, or something like that. So April Fools is related to that. So the sun, put by the creator, that is acknowledged by people as a designed by a designer, and people kind of like came to certain conclusions and follow certain ways of livings, and a lot of a sudden the Catholic Church and those people were kind of like also take over. Who is here that knows about the Catholic Church? Because I learned recently that even the Roman Empire was kind of like replaced and taken over by other groups. I know the politics, like it's kind of like an example of today. Many of the nations kind of like being replaced by other people, being put in positions of power. The Roman Empire has a similar history. Other people taking it over and changing stuff. So it's kind of like history repeating itself in a sense. I find this interesting, but I don't have much knowledge about that history compared to some people. Sun, bringing the spring, bringing the light. It's a good thing for the land, for the flowers, for the skin of your baby. They grow healthy, strong, happy. That makes parents happy. Thankful to the Creator for doing something so good, designing such a good environment. I imagine people can acknowledge stuff like that and be thankful for things like that. Having big families, healthy babies. And it's by design that it should be that way. But then comes the Globers. Fucked everything up.
I actually came into the. I was started talking about the rundown uh, of the whole vitamin D and the sun stuff, and you know what she says to me? She says, "Well," she did say it. She was like, I've been." She didn't think that the baby needed the vitamin D drops because she was like, "Yeah, just put her in the sun." But I'm like caught up with like I don't trust them at all, but at the same time I'm hanging on there everywhere. I'm just trying to be a good dad, you know. I'm just I don't know what I'm like 1 foot in the door, 1 foot out the door because I'm here with you guys and then I'm in the world with the world, like, and it's like I don't want her to take that shot. But
Elijah, I'll give you a heads up, bro. So the body naturally produces a hormone called vitamin D2, and then when you go out into the sun, when the UV rays from the sun, the natural UV rays, hit the skin, as it penetrates the skin, it mixes with the hormone vitamin D2 and converts to vitamin D3. So that's where you get your vitamin D3, which then mixes with the phosphorus and the calcium and the collagen to create bone mass.
And the cholesterol from that you get from foods from animals.
Oh yeah, Clostridium or whatever it's called.
And mother's milk, mother's milk has a bunch of cholesterol.
Oh, why you giving me these? Give me that.
So it's a balance of the two. Like you want that heavy fat diet for the baby, that cholesterol diet, heavy cholesterol, and then just 20 minutes of sunlight, once or twice a day. I think you'll be all right. You can up it as long as it's not burning the baby's skin. If you see any rashes, that might be a sign of too much sun, too much direct sunlight.
You can do it through the window though as well.
Yeah, back in the old days, they used to have when they would live in the high apartments, there would be a box that they used to build on the outside of the window, and you'd stick your baby in there so they could play outside and get sunlight without having to go all the way downstairs.
I used to go to the roof and just get sunlight. I will set up maybe a small pool. Those little plastic pools that are for little kids. Fill it with water. If it's too hot, the water is, to refresh. Get sunlight for 20, 30 minutes. You fill the little pool with water. It's a fun activity.
Oh yeah, and the water is refreshing too.
Yep. Yeah, Elijah is busy with the baby, so let him be. I'm still confused why he was saying a shot of vitamin D. I think he's confused. They don't give shots of vitamin D, do they? They do vitamin K.
Vitamin K, yeah, for the jaundice.
No, I'm talking about two different things. Vitamin D drops. When I was talking about the shots, I was just talking about just, the regular scheduled shots for babies.
You in this nation, you have religious exemption. No matter what anybody says, if anybody tell you anything contrary, and they try to go against your religious belief, you can sue them.
I know you have religious exemptions, but I also don't know what I believe. Like, do I not fuck with the orchid vine waxinate? No, I definitely do not. But when it comes to the ones that I got, I mean, well, other than crazy ass fevers as a baby, like up until I don't know, because I thought fevers were just a part of life, and then I grew up, and now I don't have fevers like hardly ever, and I'm like, oh. So I don't know if that's just naturally because I was a baby or if it was because I don't know. But I don't want to not.
The only reason the body will get a fever will be to fight off some type of maybe an infection or something that is. So the fever is a good thing. But if the fever is being induced by a man-made, ouchie fauci, then it's because something was put in the body and the body is just reacting to it. And if you are putting in the body something like that is being, jibby-jabby or ouchie fauci, that stuff is not as easy as the natural stuff that might cause some fevers that the baby will fight off by himself. The man-made fever is gonna be different than the natural fever.
I'll say it to you like this, and I'll keep it real simple. Sorry about the background noise. So a fever, the reason why your body creates a fever is because it needs to increase the ability for blood to flow. So you'll get vasodilation, you'll get warmer blood, so it won't be as thick. And so that's to increase blood flow so it can get to the liver and the kidneys a lot faster. That's why you'll have a fever. So if normal conditions aren't getting to your liver and kidney for toxin removal, then your body will go into a fever mode to try to increase the opportunity. You can stress yourself into sickness. And so really all a sickness is dis-ease, and your body is under some form of stress, whether it's physical, chemical, or emotional. How old's your baby, Elijah?
2 months.
Oh yeah, she's still young. Congratulations, by the way, brother.
Thank you.
Is that number 2 for you?
Yep, number 2.
Big congrats, brother.
Thank you.
Yeah, so fever definitely is more common once they start teething, right? That's when you'll commonly see fevers because they're constantly under stress, right? At an early age, I'm wondering what it could be, man. Usually it's diet or some kind of chemical interaction that you're not aware of. Look at your cleaning supplies. Have you started using different cleaning supplies recently, or
Oh no, she doesn't. She doesn't have a fever. She never had a fever.
Okay.
I'm just saying. I'm just talking about, you know, the baby schedule for the shots and stuff. And only thing I can really do, I mean, I don't know what to do other than because I don't know. Like I don't want I don't know what I don't know, you know, and that still makes me fearful. You know,
That's
for
a
me to be
natural
like,
feeling.
no, for me to be like, no, she's not going to get chicken pox, and for the doctor to be like, that's silly, she's going to get chicken pox. Like, I don't know which one. I don't want it to be on me. Maybe I'm being selfish because maybe if something goes wrong, I don't want it to be on me, and I want it to be on the world. But that doesn't do anything for my baby. So I mean, I don't know, man.
I'm in the
I just
same
want
boat.
what's best for
One option is you can move to Florida, where it's not mandated.
Well, it's not about not. I don't feel like I'm mandated to like Jimsy said, there are religious exemptions and stuff. I don't feel mandated. I just don't want to take up the fight for her to turn around and get like malaria or some weird shit.
Yeah, I feel the same way, and I don't want my wife to be like, "This is your fault." You know, like you said, blame the world instead of you.
And is that selfish though? Like, am I not man enough to be like, well, fuck it, you know? Like, because at that point I'd be like, well, shit, all this shit I was talking, and my baby has malaria now. Like, what would I do with that at that point?
Yeah, and then God
When the
forbid there
doctor's
is an
like,
adverse reaction. It'll still be your fault because there was an adverse reaction and you made that decision.
That's very true. That's very true.
Just seek the Holy Spirit, brother. Keep praying like you always do. You're doing a good job. You're a good man. You know what to do. You will do the right thing when it's time to do the thing. I know you will. Hey, by the way, Elijah, if you ever need help writing a religious exemption, I'll teach you how to write one. It's very simple. And the reason why it's simple because it's all in the wording. Because they can't test you directly on your religious exemption, but if you say the wrong words, then it looks like it's your choice and you're not being controlled by the will of God. So
You also want to check your state laws because not all states allow the religious exemption.
The earth is not flat.
Oh, goodness.
It's an oblate spheroid.
Nice claim,
Proven by
bro.
the way shape disappears first over the horizon and the circular shadow of Earth on the moon during lunar eclipses.
All right,
The
buddy.
changing position of stars as you travel
Hold
north
on,
or
guys. We
south,
have a real
time
preacher in
zones,
here.
and countless photographs
Hey,
from
guys.
space. Okay? And ships on the horizon. When ships sails away, their
We
hulls
don't need you to read
disappear
something
before
off.
their
We've heard this
indicating
1,000
they are
times
moving
before.
over a
I
curved
can
surface.
actually explain
Not
that, but if you're going to
walking
keep talking over while I interrupt you, I'm going to mute you. Now nobody can hear you. Wow. Ships over the horizon. That can be explained very easily. Let's focus on that one instead of trying to gish gallop to a bunch of different things, okay?
and disappears below the horizon.
Yeah, no, we're not doing that. He's just
No, it doesn't disappear below the horizon.
Well, I'll entertain that. Do ships disappear under the horizon? No.
I think he left.
Is he still? Oh, he left. Oh.
I was ready for that one. I wanted it to go on and on.
Catho said he's still out there reading.
The Earth is an
I
oblate
have a feeling
spheroid.
if he would have kept going,
Show me a picture of an
which
oblate spheroid. Why are they? Show me a picture of an oblate spheroid. The fuck?
you remember those I forget what they're called. They look like Saturn, but they were like ball hoppers back in the day. Elijah, stick them in between your feet, stand on a little platform, and you bounce up and down on them. I'm pretty sure that was an oblate spheroid.
Welcome back, Jesse, Path of Light.
Thank you, thank you.
Hope all is well with you, man.
Yes, sir. How are you doing?
Doing all right. Can't complain.
Good to hear.
Welcome, Tamid. Tamid Tazvid Ishmam. Flat's not a shape. And to clarify, nobody here would make a claim that the Earth is some kind of space disk, a pizza planet space frisbee. It's not a disk in space. You know, like the memes that you've likely seen. Nobody here would believe in such a thing. If you have any questions, feel free to ask. You believe that it's round. You observe it to be flat. You experience it to be stationary. You see the horizon as horizontal. I don't feel like talking at somebody in the side chat, though. If you'd like to join the VC, feel free to unmute and speak up. No need to be shy. And if you need to practice your English, so does everyone else. And he's going. Now, well.
Can't win them all, I guess.
Mic check.
Not too bad. Try again.
Mic check. 1, 2, 3, 4, 5, 6, 7, 8, 9.
There you go.
Welcome
You're
back.
about you're at a 98%.
Awesome. What happened? I left and everything got quiet, or?
We had a vote, and we all voted that the Earth was in fact a globe. But you should have been here to vote. You could have tipped it. It was almost a tie.
Wait, what do you mean the Earth is a globe? When I go to the store and I check globes, they're not made out of Earth, though.
I was just teasing you, brother.
I know, but globes are normally made out of, I don't know, like paper mache and colored with crayons. That's what globes are made of.
Mine is a 1980s or something spot globe, a scan globe. So it's actually a plastic sphere, a clear plastic sphere, then with the paper, glued onto that, and then it's got a light inside.
Ooh, so that one might be closer to the lights in the sky, because that one has a light.
Well, not only that, the light bulb is in the center, and then there's a little magnifying lens in there on an arm, and there's some knobs you can turn to move the lens around, and so it focuses a spot projected from the light bulb onto the surface of the globe from the inside. So you can pretend that that's where the sun is right there. You can move it around to different latitudes and longitudes.
Oh, can you pretend to be walking on the side of it or on the bottom of it?
I just turn on my anti-gravity boots.
Ooh, I mean, you mean anti-gravity. You will need the gravity, not the anti.
I have to think about that one.
Oh yeah, anti-gravity to cancel the actual earth that you're standing on, and then to get on your plastic paper mache one and walk around it. Sounds like an impossibility, but hey, imagination, fantasy, cartoons, made up stories, that's a thing.
Definitely, definitely.
I mean, if the creator gave us the capabilities to make stuff up, right? Why not do it?
True. I guess that could go for both sides, or couldn't it?
Yeah, just ask the Japanese. They, animes are pretty cool. Doesn't mean they're real, but they're cool.
I just got here, but has anyone got a really good explanation for why objects disappear bottom up on a flat Earth? Why would we think they do?
So
physics explained that
go ahead.
130 years ago.
Perfect. Rayleigh criterions here.
Hey, Rayleigh, how's it going?
Temperature's warm, but it's windy, which sucks.
Oh, so in other words, the temperature would allow you to capture some really cool phenomena with your camera, but the wind is making it difficult?
Yeah, the wind always causes objects to appear fuzzy.
Oh, yeah.
So the guy has a question on the table. Riley, can you take that one?
Sure. The human eye is not very good at looking at objects in the distance. We start losing acuity of our vision after about 2,000 to 5,000 meters. So our eyes are incapable of seeing dim objects that are, tens of kilometers away. And so the dark hull of most vessels just gets overwhelmed by the bright reflections of the sun off the water. If you want to track vessels going over the horizon, it's best to do them at nighttime when we don't have the interference from the sun. And then you'll notice you'll be able to see them far further than during daylight hours.
How you like that? Da. Go ahead, the Bay guy.
But like I said, the best way to verify if a ship has gone over horizon would be to put a retroreflector on the hull of the ship and then fire a laser at the ship and see if you get a return signal from the retroreflector. But as far as I know, no one has done that experiment.
So, Daddy, do you hear what he said? Debate, Daddy.
Well, I think. Wait, what kind of signal would you fire? And would that signal be susceptible to refraction as well? Like, I know lasers are susceptible to refraction.
Well, the thing about a retroreflector is that it returns the signal in the exact direction in which it arrives. So if it arrived at a bent angle, it would return at that same angle and we would never see it. It's like if we were to send a laser, 60 nautical miles to a mirror that was perfectly perpendicular. If the Earth was curved, that perpendicular mirror would shoot laser back, signal back, 4,000 meters in the air above your head.
Can you show that? Like, is there a model that'll show that mathematically? Because I don't know, like, if it's gonna keep going in the other direction versus like coming right back at you. Like, I haven't looked into it, so I don't know.
Well, I haven't done that in a while, but I'd have to do the maths again to get that selected. But basically, I basically used a triangle in which we know that at 60 nautical miles there's supposed to be 1 degree of lean for a perpendicular object. So I used a 1 degree, 60 nautical miles for the base, 1 degree for the angle at the far end, and then calculated the height on the opposite end of that triangle, and it came up to approximately 4,000 meters, something like 39 something.
But when you see, like, I don't know, a zoomed in image and then it's like a tanker ship, half of it's like a Glober would say beyond the horizon. Why? And then the flat side says, well, it just disappears bottom up naturally. That's how optics works. Like,
Real quick, debate, Daddy. So you have a set of information that you were given, right? You probably read it on a book, and what you got was, and you learned before you ever even did this observation by yourself. Someone told you boats disappear over the horizon because Earth is globe, right? Is that what you learned?
Well, they also say that like standard optics doesn't make objects disappear bottom up on a flat plane. Like they also say that, and if you proved otherwise, you would win some kind of a Nobel Prize, right?
Hold on a second. The whole point is, how did you prove the claim in the first place? Never mind what they said is not happening. Why don't you tell us what is happening and how that was proved?
Do you have like any standard optics textbook that says otherwise? Like, I don't know. I'm just saying what
It says otherwise about what? We're talking about a boat disappearing. You tell us why that's happening.
Yeah, you said there's a boat.
What?
You said there's a boat with a clear, hard line. So tell us the observation height, show us the image, tell us the distance to the boat, using radar, and then let us know what the weather was for that day and what the ocean swells were for that day.
I don't even want any of that. I want to know.
The Bay guy, I just wanted to tell him, the Bay guy, because come to the conclusion that the cause of the effect that you're observing can only happen because of Earth curve, right? It will have to be happening at a specific area, and you will have to discard all of the other variables that these guys are trying to communicate to you to be able to logically come to the conclusion that that is the case. Earth globe. That's why you see in the boat disappearing. So have you done any of the check and balances that they're asking you for?
Well, so if it's the case that standard optics does not make objects disappear bottom up on a flat plane, it doesn't matter what the weather is or what the distance was or anything like that. And if we observe that, we know that the Earth is a globe. Period. We know it's not flat.
So you just go instantly to the affirming the consequent fallacy. You're just going to go ahead and go with that, right? Even though the Black Swan totally refused.
It was actually just.
No, I don't care about the ifs. Forget the ifs. Forget the ifs.
Modus ponens
You
is
see.
not,
You see.
You just went right for the straw man name.
No. If you see a boat disappearing bottom up, I want you to give me the cause for that.
Well, it depends on how we're modeling it. But if you're just gonna like straw man and then say that's affirming the consequence, that's like
We're talking about modeling. I'm going to tell you why it is that the boat is disappearing bottom up. Why is it?
I think we might have to take a step back from that and talk about.
We might have to backpedal and go somewhere else. We're going to have to talk about something else. Non sequitur, red herring, away from this because it's too simple a question to ask.
Yeah,
if it's the case that an optics, right? Yeah, great, terrific. So, if you're saying that the reason that the boat, so hold on a second.
Says who you're cutting out.
Yeah, I just want the argument for what the affirming the consequent was there.
Yeah, if I see a boat disappearing bottom up, then the Earth is curved. Or actually, it would go like this. If the Earth is curved, I'll see a boat disappearing bottom up. I see a boat disappearing bottom up, therefore the Earth is curved.
You're just giving a modus some kind of modus ponens. That's not affirming the consequent.
No, that is affirming the consequent. It's circular reasoning. If the Earth is curved, I will see a boat disappearing bottom up. I see a boat disappearing bottom up, therefore the Earth is curved. That's your position. Or if it's not, I have totally strawmanned you, and you tell me what your position is. I apologize. You tell me what your position is.
I'm sure you could reverse any argument to make it appear as if.
That's fantastic. Why don't you tell me what your argument is? I've already apologized. Instead of you just kind of hanging on this point, tell me what your argument is.
It's something like if standard optics works in the way that we know that it works, where objects.
What is standard objects? What is standard optics?
He means optics.
What is standard optics?
It's just the way that light interacts, and for what we see.
Just the way that light interacts with what we see.
Yeah.
Okay, so that's standard. So, is there just like a very general, generic kind of we see the same way all the time in all conditions?
No, I don't think it's like.
No. So what standard are you using?
Just like what we know about the physics of light,
I think
how photons work.
Right.
Photons work right now. So we're talking about photons. Please walk me through it.
Well, I mean, I'm just giving you my grade 11, 12 physics summary of what I know. Optics does not work the way that you guys think.
What does it have to do with a boat? Okay, so fine. So what you need to do.
And
so what we need to do is for you to establish what your position is with a positive claim. We see a boat disappearing in the distance. You say it's disappearing bottom up. Okay, you tell me why that's happening.
Oh, well, again, I'll reiterate it, but don't cut me off this time. So if, optics works the way we know it does, and you can even go to like a track and put the camera down on the ground, walk away as far as you can, you'll still see your shoes on the ground further down the track. It's not going to disappear.
So if we see a boat disappearing bottom up in the distance, why is that happening? I want you to give me a cause, and then I want you to prove it.
It's just a simple deduction, sir. It's just optics.
It's a deduction.
It's that you guys.
Excuse me, I don't know why you're going back to optics again. The boat is disappearing bottom up in the distance. I want you to give me a cause for that, and you keep avoiding it. It's almost like you're scared to make a claim and then prove the claim. Why?
Actually, I asked you guys the question originally, and it sounds like you're asking me.
Right, because we're talking about boats disappearing bottom up. Yeah, no, we're not going to make any claims anymore. No claims made. You tell us why the boat's disappearing bottom up.
Claim. I got it.
No, I don't. Why do I have to? Yeah, I'm so afraid. I'm afraid of making a claim. You got me. Why is the boat disappearing bottom up? Can you tell me why and prove it?
Well, objects, as far as we know, optics doesn't work this way, where it could bend or
don't tell me what it's not doing. Tell me what it is doing. Good grief, man. Why do you have to go to what it's not doing? Can you tell me what it is doing? Why is the boat disappearing bottom up? Why is that happening? Don't tell me what there's not doing. I'm not saying anything. I'm not saying anything.
Oh, you don't think it's possible?
I want you to prove to me why it is that the boat is disappearing bottom up. Why are you running from this?
It's a simple deduction, sir. I can try to explain it, but you'll cut me off again.
No, just tell me why it is. Make the claim. What is happening when the boat is disappearing bottom up?
So listen, the bedbro, the issue that you're having is that he's asking you about the methodology that you utilize to come to the conclusion that you came with, right? And you're saying, oh, you guys think about certain things certain ways, and you're talking about us. Just tell us about the methodology that you use, the actual way that you came to that conclusion.
Sure. So the basis for my question when I asked it originally was, as far as I know, physicists, not me, because I'm not a physicist, they claim that standard optics does not work the way that you guys think, where objects can disappear bottom up on a flat plane. And so I was asking you guys, if it's possible, how do you guys show that it's possible? Like, how do you guys, if you think it's possible, because if you guys
we take flat objects, we take observations of objects on flat surfaces and they disappear bottom up. So apparently the claim by the physicist that you're appealing to is incorrect.
No,
are you just begging the question?
The Bay Daddy Rayleigh gave you a very extensive explanation of the observed phenomena and what can be causing the bottom of the boat to be disappearing. Do you hear what he said earlier, Riley? When you asked the question originally, you got a reply. You actually got an actual answer to your question. Can you?
Well, it sounds like he doesn't have verification. He's going off of not hypothetical, but he's leaping to logic. You know, he's like, oh well, if this then that, but you're not verifying your claim.
Well, he said something like, we don't really have sufficient tests done yet to really know for certain, and I can respect that.
No, that was the last thing he said. That after he addressed.
I don't say that. I said after and now and tomorrow and goodbye. I say everything.
Ice Cube, can you mute yourself? Thank you.
What?
Can you mute yourself? You're interrupting.
You want me to leave?
You are interrupting. Do you want me to mute you?
I don't understand you.
Yeah, why don't you just help him out there? Thank you. So,
I have to help.
As far as I know, though, like if you guys think it is possible for that optics work that way, I'm just wondering, do you have any kind of reason to believe that it is possible?
Well, you're asking now a question, yet you've been asked to verify your claim, yet you're now asking us a question. So you're going away. It's an admission that you can't verify your claim.
It's a physicist's claim, not my claim, but I was just saying they claim it's not possible.
Oh, so they made a claim and you didn't go ahead and check them out, right? How do they know that?
How do they know?
I'm just asking. Literally, why are you guys getting so defensive over
I'm just asking. So when you get your ass handed to you, you come in and just start talking about, oh, I'm just asking questions, bro. I'm just asking questions.
Like, both sides. This is like a healthy inquiry.
I know. That's why I went to the point. Hold on.
All right. So there are many variables that can cause
Wait, did you just make a sea lining sound? It's not sea lining. I'm not sea lining.
There's many variables besides the one that you are considering, Earth being globe, boat going behind the curvature, right? The other guy talked to you about temperature, right? The distance, the optics of your eye, or whatever optic you're using, it has a limitation.
The reflection of the intense light.
Go ahead.
I was just saying the reflection of the intense light at the surface, and how the brightness of the sunlight is overwhelming the dull color of the hull, right? There was a lot of things that were discussed prior to him saying there's still more research that needs to be done. He just kind of like literally didn't listen to anything. I don't even know that much about optics in that sense, what Rayleigh was sharing with you. and I could steel man what he said because I listened to what he said. I wasn't ignoring it to refute it.
Is Rayleigh still here, by any chance?
Yeah, he's still here. He's probably working, but he's still here.
Because Sesu has an important point if you consider what Sesu is trying to point you out, that you said that the physicists said something, but have you checked what they said? Have you checked that that is the case and that is true?
Have I read like the physics textbooks? No.
Reading is not verification.
Well, look, I mean, I'm pretty sure
that's how a lot of peer review happens nowadays. They just, because they're a so-called expert in the field, they look at it, they say, that looks about right, I approve. They don't actually go out and verify it.
Yeah, but you know that if you proved otherwise, you would win a Nobel Prize.
Who cares about Nobel Prize?
I don't know why you keep saying that.
You would win $1 million.
Debate, bro.
$1 million.
Listen, what would we be verifying? First of all, be very specific. What are you talking
Who
about?
cares about winning $1 million? Like any one of you flat earthers could have proved this already and won $1 million.
No. Listen.
Prove to what?
Debate guy. You said prove otherwise.
All physicists
Do you mean other? Okay, the otherwise. What is the what is the opposite of that otherwise? What have you proven that we have to prove otherwise? What is the proof that you are holding? What is that?
Why are you trying to like shoehorn me into that? Like I made my intentions clear.
He's gonna be greasy. Like your suit is about as greasy as they come. So debate guy, you're not making any claims today, and you're asking questions about standard optics. Okay, right. What is standard optics? Could you please define it? Do something in here that's worth our time, like at all.
I could go back on mute if you guys don't answer the question.
I'm not even sure your question's coherent.
If these guys can prove otherwise, we'll win a Nobel Prize. What is the other? You mean the other is like the Earth is curving and causing the boat to disappear? Is that the other?
Yeah, well, like, do you guys believe that it's true you would win a Nobel Prize if you had substantiated the?
Be specific. Be specific.
Be
specific.
No one cares about Nobel Prizes. We care about the truth. All right.
No, but it actually is relevant to the truth.
Be specific.
If the peer review community saw your claim,
be specific. What claim did we make? What did we make a claim about?
Objects disappearing bottom up over a flat plane. If you guys can show.
Yeah, we've observed this. Yeah, you can do it on your freaking kitchen table, dude.
We got demonstration.
Does anybody has the photograph does anybody
I don't think
has
you
the
can do it on the way.
Hello. Yeah. Listen, does anyone
No, wait,
AI overlords?
Let me respond to that guy before you got. You can go right after.
AI overlords.
Wait your turn.
An example that he did over a body of water. He has it. He did it recently. He took photographs of a body of water. Anybody has his example that he has posted many times?
Yeah, but if you do it over a body of water and the Earth is a globe and you're assuming it's flat and you show, hey, look, objects do disappear bottom up. Like a glober's not going to.
Nobody's assuming anything. Nobody's assuming anything at this point.
About the kitchen table.
Hold on, bro. Listen, it's not assuming that the Earth is flat. It's the fact that the curvature is much further. Right, the edge of the sphere is much further in the prediction than what they're saying. So, for all intents and purposes, the object where it's at in its location should still be visible because it would be more flat in that shorter distance. That's the whole point.
Yeah, but you can only make that claim without factoring in the covariates. But and you guys never do. But back to the table. Back to the table. Yeah. Somebody said that you could prove it on a table. I've seen the YouTube video where they do this.
You can do it on the floor too.
Somebody could probably post the video. We can maybe even stream it for anyone else who hasn't seen it. But
Well, why are you hell bent on the table example though? Because the other example
I'm just quickly going to address it before we move on. Because
let me just say though, that's probably
you got your shotgun argument saying you're like we have to go in order. We have to go in order with all the claims.
With the small mobile boats, you know, the like the motor boats. The little
let's
play boats.
Let's go with the first claim, like in order, and let's not make a new thing. Like somebody said, you can prove it with a table. So I've seen the YouTube table thing, and it's like a parlor trick, right? Where they put the camera slightly beneath the table, and then they move the coin further away so that it looks like it's disappearing bottom up, and really like the camera is below the table.
But then does that make
biggest fools on the planet fall for this?
So you've gone ahead and tested this, right?
The biggest fools on the planet fall for this simple.
Have you tested this? Have you tested?
You can literally do it yourself. Like make sure it's actually level.
Have you done it yourself? Have you done it yourself?
It does not disappear, but yes, it does not disappear.
Okay, great. Show us your example. I want to see it.
You want me to set up my camera right now? I'm in bed. I'm just chilling.
Yeah, go ahead and do it. I mean, get out of your bed and go do it. Show us.
I can tell you from my experience, if that's not.
Listen, you're some asshole on the internet. I want you to do it for me. Get out of bed, go do it. Get a quarter, put it at the end of your table.
Get up. I haven't called you slurs.
I don't care about. Listen. The whole point is you're just some guy on the internet. I'm not going to take your word for it. I want you to get up out of bed. You know, put your nightgown on, go out to your table, and do it for me.
Don't take my word for it. You can prove.
Okay, great. So why are you making the claim that it's just a parlor trick, and now all of a sudden it's just a parlor trick? But you're just saying
you guys claimed it was true when it literally is a parlor trick.
Fine.
Are the biggest fools.
Let's just say for the instance right now that it is a parlor trick. How about the boat on the pond? It's disappearing bottom up. Now what?
Oh, so you did a something on a globe, and then. You're saying, well.
Oh, wait. How much curvature? How much curvature should I be looking for? Geometrically, how much curvature should I be looking for, bro? How much curvature should I be looking for on that bond? I want you to give me the geometry so we make sure that it's a globe. It's a globe thing, right?
Are you factoring in refraction? Are you using a total?
Oh, so now it's not geometric. So now it's not geometric. So the apparent deviation or the sinking of the ship or the bottom up disappearance, now it's apparent. It's an optical effect. So now you're on our side.
I just said that from the beginning it's standard optics. Like
standard optics. So standard optics do make things disappear bottom up now. Is that what you're saying? Oh, so it's not geometry. It's standard optics, and standard optics are making things disappear bottom up by your admission just now. Refraction and all that, right? So now you're on our side. So refraction makes boats disappear bottom up. Great, it's not Earth curve. I appreciate that. You should get a Nobel Prize.
No, refraction can increase the amount that you.
Oh, it can. Great. I want to see the data. I want to see the data. I want to see the data for that right there. I want to see that data.
What data? That refraction can help you see farther than otherwise?
Yeah, in the degree that you're talking about, I want to see the data. I want to see the test. I want you to post that real quick.
Well, you can go even in.
No, don't tell me I can do whatever. This is your claim. I want you to prove it right now. Don't you reverse this burden of proof on me. Do it right now.
On some days, you can see further, and some days you can't. You already agree with this. It's not something you disagree with.
Reductio. Okay, so let's assume the coin on the table is a parlor trick, right? Like I can throw that video out the window. Now let's look at the video that I tagged you in at 54 minutes past the hour, where they're on the floor, so they can't go beneath the floor with the lens, right? Right?
This is the...
Hello?
What's the video called?
Arctic Blast Home Observation.
Okay.
Hello, can I ask you something? Like,
not yet.
We're busy at the moment.
Wait your turn.
Yeah. I'm sorry. I apologize.
Well, hold on a second. We have new people with genuine questions, and Reductio will be here all the time. So,
okay, fair enough.
I move that we talk to the new people instead of the debate bro trolls. So,
No, I mean,
Go ahead.
it's okay. You guys can talk.
No, it's fine. You're fresh. That guy is here all the time. He's obsessed with us.
All right. My English isn't that good, so I will try to make my. Anyway, the question is.
Okay, yeah, do your best. Go ahead, do your best. Go on.
Benefit?
Yeah, you're good, dude.
What's the benefit of knowing what's the shape of the Earth like? If it's flat or circle, what this shit gonna change to the world? Like,
what's the
nothing.
Hold on a
benefit
second.
of them telling you that Earth is a globe?
You're asking us a question. You're asking us a question of why knowing the truth is an advantage.
Yeah, it doesn't matter, bro.
You don't think that knowing the truth about things is an advantage?
Things, I mean, yeah, I mean, other things. Of course, it's adventures, but the Earth,
Okay.
I don't
Why
know
would this
about
be
that.
different? Why would this be different?
You see, that's a very good question. Why would this be different? It depends on how much value you put on the truth and then on the earth you live on, the thing that you never made, but you're eating well on. Just that little statement there. How much value do you put on this earth? Because it seems like it doesn't matter because the earth doesn't matter. That's what it sounds like. Go ahead.
It's like building off of a faulty baseline, you know?
Exactly. So the question is to you, can you see how it's important to me, for example? Can you see the importance of truth and actually knowing the shape? Not to mention the monies that the education minister for Britain, for example, that they receive in the government, money for education to educate the children wrongly, for example. That's wrong in itself. So it would correct a wrong. The potential to correct the wrong is worth anything. Yeah? Or everything.
Then you have a good point. I'm sorry, bro.
Okay, thank you. Really do think. Remember that statement you made. Hang on, that statement you made shows all of us here that you don't value the earth, you don't really value the truth, and you're still not on the right track. You're a little bit lost. So we need to think of ourselves, our value, and the devaluation going on by our governments. Remember, they're lying. They're going to the moon as we speak. But because I'm a flat earther, I know now that they're lying about that. The flat earth proves that they're not going there, for example.
So someone's got hit him with the girlfriend analogy, the cheating girlfriend analogy.
Right. There we are. So the truth is everything, and that's what's important. If you have any other question, please ask some more questions, though. Go ahead.
I don't have anything in my mind.
No, so I have a question on just following up on what Jin was saying. So yeah, I know the truth is important, but what you are going to do, even though you say you know the truth, right?
Okay. What I'm going to do is inform my
Why would I
family.
tell you my plans? Why would I tell you my plans for making myself better in this world?
Yeah, that's a good point again. But my plan is I've informed. Anyway, let me answer the question. I have informed my family. Okay, that's my children, my wife, my brothers and sisters, and my niece and nephews. My families know. My students who I teach English to know. Right? My friends know. Now, all those people that I've informed, their lives are going to change from that moment onwards. And then when they have their children, their children's children, never going to believe that the earth is a globe. So the revolution in that sense has begun already within my own family and friends. Okay? So there we are. That's one movement. Then let's say we have some really committed people who are dedicated to getting the truth out to the government levels. They go out and they start complaining that the education system is wrong, they're teaching us wrongly, and they go out and inform the public so that more people get to learn, okay? So the potential is great, actually. In fact, it's so great that we, the Flat Earthers, have forced NASA to have to change their story, actually, because of the scrutinization that's come from the Flat Earthers, exposing all the anomalies in their Apollo story, for example. They've had to change the story. We've caught them changing documents and removing documents. So it's very important. Potential is great. Okay?
Specifically on the topic, does somebody have a question? Do they can they on a globe or a spinning ball, or if they think they can prove it?
I have a very simple question. So when you say that the surface is flat, right? So I mean I have not thought about like what others think. So maybe you just guys can just tell me. So simple thing is, right, when you walk around a spherical surface, if you go in a straight line, you will end up at the same place, right? But if you walk on a flat
No.
surface,
That's false.
No one's ever done that.
so how do you guys disprove that? Like,
No one's ever done that. No one's ever
You would
done
have to
that.
prove to us.
Hold on. He was actually correct. If it was a spherical surface, you could walk in the same.
No, but he said
direction.
straight line. No, listen. Listen, he's so let's have one person address him or something, but he said straight line and you're gonna end up in the same place, and now someone is confirming if it was a globe that would work, but you don't have straight lines on globes, bro. Come on.
Yeah, it wouldn't be a straight line, but I mean going in one direction, right? But you got to prove that
Was
it's
that
globe
not?
first,
That's
and
not what he
obviously that
said.
doesn't-
Yeah.
no, that's
And we're not.
Here's the
We're not going to
problem,
add
Jim.
fluff to this by directions.
No one has ever gone in a single direction, right? Like what would be considered straight ahead as a crow's flies. No one
Yeah,
has
we
ever
all know
done
you can't do
that.
that. We all know that. We can't do that on Earth.
No
You can't
one has
stay
ever
in-
done that.
Yeah.
It's even proven that if you go east or west you're not going in a straight line. You're going in a curved line. And then also you have to consider, like what Jemsy said, if you're on a sphere, it's not a straight line anyway because you're going around the surface of the Earth, which would mean that you're going in a curved line.
Right.
So there is no straight line on a sphere.
For sure, agreed. But going in the same, with a model globe, if you go in the same direction, your finger will come back to the same point. That is what he's getting at. We know what he's trying to say. Although we know that he doesn't mean, like, we know that he can't mean.
All right, dude, bro. We're not going to talk about the meta. Please, can we talk to the guy that actually asked the original question and then reverse the burden of proof on us to prove that that's not the case? I want you to prove that it is the case, that somebody could go in a straight line and end up where they started.
Yeah, because that's never been done. That's the point exactly. It's never been done. Can you
so
prove
how
that?
about like I take a ball and I start drawing.
Whoa. Why are you using a ball? We need to see if the surface of the Earth is a ball. So is the surface of the Earth a ball?
By ball I mean a sphere, right? So
Yes, fine, yeah. No. We don't assume here. We prove. Can you prove that the Earth is a
I
ball?
don't have the time to to circle around the world.
Can anyone prove? No. Dude, you got to listen. Listen to what I'm saying. I'm asking you a specific question. Can you prove in any way that the Earth is a sphere instead of us begging the question that it is? How do you prove that the Earth is a sphere? The best way, in my opinion, is to find some curvature on the surface of it. Where would we find that?
I just asked the question, right?
Yeah, did you not?
I know.
Asking, I'm not here to propose that Earth is flat. I was just asking if a question.
I know that. I'm asking you a question about the sphere that you think that you live on. How do you prove that it's a sphere so we don't have this conversation about things that we don't know for sure?
How do you prove your globe? Have you proven it's a globe even? Because you said you don't have the time.
Another question. Okay, yeah, I don't I will not travel around the world in a straight line to prove my point. Okay, so it was just an argument, right? The second thing is, so if I say whatever we are, seeing, let's say internet, you believe in, science as a whole, or do you not believe in,
Wow.
technology?
Okay,
Bro, you're asking several different questions at the same time. Okay. Believing in science. No, I don't believe in science because it's not a religious system. It is a method of finding the cause of an effect in the physical and natural world. That is the natural scientific method. It's not a matter of believing in it. It's just a system that we use to prove things. Now, technology is a whole nother question. You would have to be specific about what technology you're referring to and how it would prove, quote unquote, that the surface of the earth is curving. So which one do you mean? The scientific method or measuring the surface? That would be geometry.
Okay, I don't want to, argue any further, so you guys can continue. Sorry.
Well, if you have a question, just ask a question. But I'm trying to show you that you can't beg the question about the Earth being a sphere and expect us to have that discussion with you unless we know that the Earth is a sphere. And then second of all, talking about science or technology, you're going to have to be specific. Asking us if we believe in something, and when you could be talking about something totally different than me, then we'd be talking past each other, and that's not useful. I want you to ask questions, but they're going to have to be more focused, more poignant.
Yeah, for example, you could be claiming something is scientific, but if it doesn't use the scientific method, by definition, it is pseudoscience. And then I would have to say, no, I don't agree with pseudoscience. I prefer science, the thing that's provable. And then if you say, well, the Earth's shape can be proven scientifically, that is a category error, right? You don't use the scientific method, or you don't use science to determine the cause of a shape, unless you were literally trying to determine where did this come from, right? What's the cause of this? But if you're already talking about the Earth, you're making a geometry claim, not a scientific claim. This is why he's saying you should be precise with your language. Because a lot of ways, we could have a lot of conversations coming out of one question, depending on how the person responding to your question desired to answer it. Does that make sense?
Yeah, it's the what is versus how why question, right? That's what we've got.
Yeah. By the way, it did make great sense. It was spot on the money. I think the Indian guy said he didn't want to talk anymore, and I think the response he got, which was absolutely spot on from everybody, has just moved him back a bit. Now he's had to rethink. So I think he's thinking maybe I should go and measure the Earth for myself so I know, because that's the only thing left for him to do. If he wants to know whether or not the Earth is a globe or if it's flat, like we're saying, because we've checked it, he must go and check it for himself. That's what he's realizing now. It's not about the internet and believing off the internet. It's about taking the education you were given and prove what they said at school. Go out and measure the curvature of the Earth, and then you will know whether or not the Earth is curving or not. That's what he's realizing now, I think. But what everybody said was spot on.
The way he spoke, I don't think he has realized it, because he said double down, and when he was asked about about how will be demonstrated that the Earth was a globe, he said that I'm not gonna go around the world in a straight line to demonstrate it's a globe. In his mind, he thinks that he has to go around the globe in a straight line to demonstrate that the Earth is a globe.
That's right, Jamesy. That's right, Jamesy.
Which is I don't know, a mental. It's like a confusion. It's like a confusion state.
Yeah. He's messing it up for himself. But I'm responding to the fact that he didn't respond to the statement our colleague made about the scientific method and that, right? So basically, he's now realized, and also he also said that he didn't have the time. Well, now he realizes he's going to have to make the time to actually do the measuring. Because to say that I don't have the time to go around in a straight line, well, that's not good. You're not going to learn anything if you don't have the time. And you will spend time here talking, which is fine, But in the final analysis, you will need to go out into nature and measure the curvature of the earth with your friends and colleagues. Get out there and check. That's key. That's why we're here, because we've all checked after believing for so long.
I don't think people realize, they take for granted that for the most part they have been trained that a lot of the things that are actually pseudoscience, people call it science. People will say, oh, this is science, but it's mathematical musings. People will call it, this is science, and it's actually engineering. People will say, this is science, but it has nothing to do with the scientific method.
Have you ever realized the hypocrisy? Like, everything you claim in the other party, or I guess science of, you're kind of doing yourself. Everyone.
Okay, what have I claimed today? Well, just go ahead. Tell me what I talked about today that was science, and I said the scientific method is being used. Please.
You particularly, I'm not responding to. I'm responding to the previous person who was mentioning.
Oh, okay. Well, then I guess you'll be a goner. No worries. Either you'll respond to me or you'll be guy. It's kind of up to you. You will respond to me or you will be gone. I mean, that's just going to be the way it works. Yeah. Sean, why are you not answering hard questions? No worries. Anyways. So the guy that was going to make this appeal doesn't want to actually talk about it. I asked him a specific question about a claim that we had made, that we said, this is science. Couldn't answer it. Got his feelings a little hurt. Says, I'm not going to talk to you. And now is on mute.
Yeah, that's very telling. You know, like he attacked you for what you said, and then, oh, I don't actually want to talk to you. I just want to attack what you say.
Right.
Very, very childish. Very childish. That's all that is. Typical behavior of someone whose butt has just been hurt, basically.
It's a layup for Darbo. Deny that he was being rude, accuse the other person of actually being rude, and then claim the victim.
Okay, I'm gonna be devil's advocate. Sean, go right ahead. I'ma overrule the mute that you got, and can you address the point, Sean? I'm in the middle of my sentence. Sean, I'm in the middle of my sentence. Sean, I'm in the middle of my sentence. Sean, hello. This mic works. Sean, can you address what was said and skip it to the topic? Go ahead.
Well, do you want to go back to what I said? I said this is hypocrisy. That's all I claimed was this is hypocritic like behavior, and yeah, kind of exactly.
Can you be specific? Can you be specific? Can you speak? What was said?
Mm-hmm. When I was mentioning about the scientific method, for instance, or responding to the previous person, he took it as if I'm responding to him directly. I just said it's hypocrisy to the prior person who's mentioning it, and I've been posting in chat, by the way. So only my topic responding to you is hypocrisy. Just hypocrisy.
Okay. Right. Just tell me about a topic. Tell me about something that we've been talking about, like an actual topic about the shape of the earth or the lack of it. Talk to me about that.
Yeah, where have we been hypocritical? Where have we been hypocritical? Says who said it as well. Can you please be specific? Where we've been
exactly. Prove your claim. Like, give your example.
Do you feel your community?
An answer.
Fucking hell. Do you feel that your community is often silenced? Do you feel your community is often chastised? For instance.
No, we're not talking about feelings, Sean. No, we don't feel anything at the moment, Sean. Can you talk to Jedi? Okay, Sean, listen, I'm gonna fix this for you. Jedi wants to speak to you.
I just want to hear.
You feel that other people control the way you think, the way you speak, and you yourself are doing that to other people in the process. That's the hypocrisy I'm mentioning. You want to control the narrative, and
there it is. No problem. Okay, Sean, no worries. I got you, Sean. No worries. I got you. You're right. You're right. Sean, I got you. You're 100% correct. We have been forcing people to come into this channel and listen to our rhetoric and then grade them before they leave to make sure they pass the test with all of our rhetoric. You're 100% correct. You are being forced here against your own will, aren't you? And we're filling you with all this bad information, aren't we, Sean?
So here's the thing. When I mentioned hypocrisy, again, you act like your voice isn't heard, and when anyone else comes here says their opinion, and this is not the first time. Last time I
didn't act like my voice wasn't being heard, Sean. When did I act like my voice wasn't being heard?
I said my piece. I said you were hypocritical.
Yeah, you were wrong, and none of us.
Again, though, example the hypocrisy. Example it. Show it. Tell us. Like, quote whoever it was that was hypocritical.
Oh, dude, the last time I came here, I got muted altogether until a different moderator ended up having to unmute me from the server.
You must have been behaving badly.
Argumentative statement. I wasn't making an argumentative statement. You can go back to the report itself. And I think that you...
Do you have it?
Where's the example of hypocrisy?
Yeah, today.
The fact that I had to mention...
We have an example of him being muted, but he's only talking about being muted. We're looking for the hypocrisy example, Sean.
I mentioned that, for instance, you complained that you're not being heard, right? You complained...
When did I complain that I wasn't being heard? Can you get me the sound clip? We got a YouTube bot in here. You can go back and look on the stream and complain about I was complaining that I wasn't being heard. Something like that. Just find it.
YouTube bot? Let me double check.
All right, Sean, I unmuted you and I'm feeling the itch. If you don't actually either address something that is being said to you, I'm going to put you back in mute. We're going to move on.
Yeah, better just to move on, really.
I said it's hypocrisy. I addressed it already.
Is that what you hear about? Is that the topic of the VC? Your feelings about whatever?
Yeah, hypocrisy.
I think that this community
this is interesting because I want to know if he actually knows what pseudoscience means, because it seems like he's confused.
Yeah, he definitely sounds confused. Go ahead, Sean, reply. What is pseudoscience, Sean? Do you know?
Like to speak. My response was to hypocrisy. I made my response already.
Yeah, and where are we being hypocritical? That's what we asked you. Where are we being hypocritical? Where? When? How? What did we say today? See, you can't answer it because it's a basic claim. You're making a basic claim.
Before I can respond to it, you make your own response. It's hilarious. You're going to the scientific method, right? You believe
Jen does that. He'll ask the question and then ramble on. Just get to the point. Answer the question.
Scientific method. You were getting close. Scientific method. Go on.
Do you want me to answer the concept of pseudoscience, or do you want me to answer the question of scientific method? Because I was responding to the scientific method question previously.
Go ahead.
Scientific method.
Go ahead.
Basic concept, right? Observe something. Observation. So you observe, okay, the Earth. Is it round? Is it flat? Is the Earth round or flat?
That's not right.
I believe you have two hypotheses.
Right.
Either I believe that the Earth. This is the basic scientific method.
No, it's not. No, it's not.
What is this?
The observation of a phenomena is very specific. It's something happening. A phenomena is not a concrete noun like a shape. When you're looking for shapes, you're looking for identity. When you're doing science, you're trying to figure out the causes of phenomena, the dependent variable, the observed phenomena in the physical natural world that you're going to hypothesize what caused it. You can then go forward after making your hypothesis into the cause and effect relationship and then test that in an experiment where you vary and manipulate the independent variable whilst keeping all control variables the same to see if it has a change in the dependent variable, the thing you observed in the physical natural world, to happen. It's not just a concrete noun, dude. You just don't go around and observe shapes. That's an identity, different category, not following the scientific method. I hope I'm clear.
Okay, you're done?
Now, Stillman, what he said, Sean.
Are you done?
Can you?
I muted myself. Sorry, Jamesy, 2 seconds. I muted myself as soon as I was noticed. I mute myself. Look.
Okay. I gave a definition of scientific. Well, I was trying to in the process of it. Observation, ask a question, formulate a hypothesis, test it, experiment, and whatever methodology you want to use to measure, right, and analyze those results. Then from that analysis, you draw some form of conclusion. And then if it's a repeatable thing, repeat and verify. So in terms of when somebody mentions the scientific method, if it's holds scrutiny to the scientific method, what are we measuring? Are we measuring the curvature of the Earth? Are we measuring, if, for instance, gravity, for instance, or do
He
satellites?
completely ignored you, Jedi, for some reason. I don't know why, but he ignored you completely.
How did I ignore? I'm answering his question. Like
it's okay.
Because he told you specifically about the observation.
Selective about
The observation is of phenomena.
Just displaying his lack of knowledge at the moment. That's fine.
Oh, guys, just let Jedi have a back and forward. He can manage it. Just let Jedi has like a couple minutes with the guy. Come on, guys.
Like I said, the hypocrisy. You like to control narrative, and that's just the reality. Then you all kind of gang up and try to say, "Hey, you did this and that," and reality is you guys hypocritical, a cult, basically. Ban me. I don't care.
Do you want to carry on talking about science? It's given me lots of time to provide you with citation. Please carry on, sir.
He's accusing us of being in a cult now. We're exhibiting cult behavior, he's saying. Thank you.
Yeah, he clearly skipped over. Right, yeah. He clearly skipped over your mentioning of the word phenomena. Right.
No, I explained the scientific method. The point I was trying to say, where he wants a specific answer about the phenomena, right?
Yeah,
a phenomena is something happen. Sorry, a phenomena is something happening.
Right. So what can we measure that's an observable?
No.
Okay, go ahead.
All right, just very quickly. Sorry, sir. I do apologise. A phenomena is something happening. A square or a triangle isn't something happening. Now, when you want to figure out a shape, right, that you're going to be trying to figure out its identity, not what caused it to happen. Natural science deals with the physical natural world, right? Things out there in nature that happen, and then we try to figure out what caused them to happen. You're convoluting the observed phenomena bit, but that's my problem. It's really, dude, please, I don't take long. It's really specific. That's my issue at the moment.
But I answered your question, right? You're right. A shape is not observed phenomenon, but how do satellites orbit the Earth is something you can measure. And I mentioned that previously. I actually addressed it. If, for instance,
affirming the consequence, objection, affirming the consequence fallacy. That's what you're doing. You're affirming the consequence and begging the question fallacy. You're committing two fallacies. I object. Strongly object to what you're doing.
Hold on, Jim. He's not there yet. He has not affirmed the consequence. So far, he's made a claim that we observe satellites, and I would like to see where we observe a satellite, and then we can talk about what caused it. Oh, crap, we actually already know. Man did. So that's not going to be part of the natural science and scientific method now, is it?
An observable phenomenon, I gave you one example, correct? You said
okay, where do we observe, no worries, where do we observe satellites orbiting in nature?
In nature?
Yep.
Yeah.
Because this is natural science. So it's going to be a natural phenomena. So satellites orbiting, is that a natural phenomena?
Okay. If you want to know a natural phenomenon beyond the sun, beyond the planets that you might, the stars that you might see as like, okay, part of the firmament, maybe you make an argument about that.
I'm not making an argument about any of those things. Can you give me a natural phenomena that we can study, please, at some point?
In terms of what is in space that disappears in the distance, in the horizon, when you're looking straight?
Anything, please. My goodness.
I mentioned several
at this moment, just give us a valid hypothesis for anything. No, hold on. Can you give us a valid hypothesis for anything? Can you give us a hypothesis that's valid scientifically? Just one.
Okay. What makes a satellite? Okay, going back to satellite again. What makes a satellite?
Okay, stop. That's technology. We're doing natural science. Every time you say satellite, that's technology and engineering. I'm asking you, natural science. Just give me a hypothesis that's valid within the scientific method. You keep saying satellites. We're going to stop right there when you do that. Sorry. Mm-hmm. Just give me a hypothesis that's valid. If you don't, I'll give you one to help you.
I gave you one. What makes the sun disappear in the west?
That's a great question.
You.
to give me a valid hypothesis for fucking anything. Just a hypothesis.
Like,
anything that's
the
valid.
Earth's rotation.
Just show that you know that you construct a hypothesis for me.
The Earth's rotation leads to the sun setting in the west. Maybe it could be an okay.
No.
Go search it up.
No. All right, I'll give you a scientific hypothesis because it's going to be based on things that we actually observe. Right? When I walk out in the morning, it rained last night, and I see lots of puddles on the floor. Over time, those puddles, they went away. And that's a phenomenon, right? There was water there, then it fucked off. Right? Do you agree with that? That's my dependent variable. Now, I'm going to suppose a cause of that. Right? Now, why did the water go away? I'm going to suspect that maybe temperature had something to do with it. So I'm going to vary and manipulate temperature to a body of water whilst keeping all other variables the same. Let's say things like pressure. So when I vary and manipulate the temperature, eventually I'm going to change the state of water if I increase the temperature enough. So the water will eventually disappear. Do you understand what just happened here? That's a hypothesis based on something that I observed in the physical natural world that I tested in an experiment. Now, can you offer me something similar, please?
Oh my God.
Can you offer me something similar?
You gave me an example not related to flat Earth. I tried to give you an example related to
I gave you an example of what I asked. I asked you for a hypothesis for fucking anything to show us that you knew what science was.
I gave you one related to your argument of the flat Earth. I related to space, for instance. If you look at a horizon, does something disappear, for instance? Meaning, is there a curvature involved? You gave me something related. Anyone could make an example, like a hypothesis of anything exists in the Earth itself. But you want to give me an example of a hypothesis of what describes the flat Earth, for instance.
All right, dude. When we're doing the scientific method, you'll notice that I'm dealing with causes of phenomena. Now, if you want to speculate what causes the sun to disappear over time when it gets close to the horizon, I'll let you do that. But I'm going to be right here making sure that you do it correctly. You understand, right? Because I've been listening for the last 10, 15 minutes, and I'm worried you don't know what you're talking about. You understand this, right? So you can continue making your hypothesis with regards to the shape of the Earth or whatever, but let's do it properly, right? We can do that, yeah?
I'm listening.
Cool. After you then, sir. What do we observe?
In my argument, the sun.
Okay, we observe the sun. What does the sun do?
In your argument is the rain. Right.
No, dude, we're just making the observation, right? No bias involved. We just observe the sun. I'm asking you what the sun's doing.
The sun is disappearing bottom first.
Okay, so the sun is disappearing bottom first on the horizon. Okay, what's the cause of that?
So that's the hypothesis.
No, it's not complete yet. So,
okay,
the cause of that.
Right. So as I mentioned earlier, that is the cause, I believe, is the rotation of the Earth turning, and essentially the sun. It was perceived to be looking like it's setting on the west.
Okay, so as we rotate backwards away from the sun, the curvature of the Earth is blocking the sun.
Correct.
Cool. Awesome. What are you going to do now?
You want to measure the distance, for instance? So we go through...
Dude, this is your hypothesis. What do you want to do now?
I believe that the sun sets in the west because the Earth rotates and the sun disappears beyond the Earth. Right? That's the hypothesis.
But what do you do now?
The observation would be measuring Earth.
Can you remember Jedi's previous example?
It's literally just gone through this with you. We've observed the phenomena. We've made a prediction of the cause of the phenomena. What do we do now?
Yeah, where's the experiment part, dude?
I was just mentioning before you cut me off, measuring the curvature of the Earth, for instance, measuring.
Okay. So first, we're going to need to measure to see if the Earth has curvature, and then we're going to have to see if the Earth has rotation, and then vary these variables to see if that's causing the sun to set. Well, we're going to need to measure the Earth first, right? So we're going to have to stop with our scientific inquiry and go to an identity problem and start measuring the surface before we can continue with our scientific inquiry, because at the moment, our independent variable is unsure. So we need to confirm what our independent variable is. Apparently, according to you, that's the surface and rotation. Got to stop science now, dude. Sorry. We'll get back to it, though, when we figured out what the Earth is.
So now you want to go to the definition of Earth?
Can you remember what Jedi manipulated in his example?
It doesn't matter right now. We've had to stop the science bit because we've got an identity problem. We've got to figure out the identity of the surface. So we've got to stop science, and now we're going to have to measure. Cool. We understand where we're at, though, right?
In most of the arguments you might make it, for instance, if you're measuring from a different height, most of the arguments, if you want to measure, for instance, ground level versus higher up, if it changes the rate at which the sun disappears, for instance, or what, if you want to measure as a measurable part, do you understand what I mean? Like, if you want to tell the difference between ground level and on top of a skyscraper, if there is a minute difference, if that's what you're looking for in terms of measurement, an analysis would be afterwards.
Okay, so when we say that if we go high, we don't see the sun.
Flat. The Earth is not flat. The Earth is not flat.
5 times?
Keep telling yourself that, darling.
Just a 3. Okay, cool. Okay, so when we're making the observations at different heights, what's the change in variable apart from our height? What does that change?
Sure. Based on this theory, oftentimes somebody who's on top of the skyscraper likely will observe the sun for a longer period than somebody who's at ground level.
Okay.
If you want to measure
is that because the horizon is further away from higher up, closer to the ground on a sphere?
Yeah, you can see more of the horizon in a curve. For instance,
no. Okay, so I want to follow you correctly. So the reason why I believe that you're bringing up going higher is because you can see the sun for longer when you're at a higher altitude. This is because on a sphere with a radius of 3,959 miles, the horizon distance is based on the height of eye above that curved surface. If you're at 1 foot, the horizon's at 1.2 miles. If you're at 6 foot, it's at 2.8 miles. 35,000 feet up in the air, it's like 228 miles, something like that. The distance to the horizon changes because we're on a sphere, right? When we go up.
You're looking at the angle of the dip. For instance, that's the question you're asking, that when you're higher, the angle of the dip is...
No, it's the distance to the horizon at the moment. That you're saying that the horizon is causing the obstruction of the sun. That's a geometric claim. 1.225 multiplied by the square root of the observer's eye height in feet. Now, to prove that this is the curvature of the Earth, we're going to need to observe that horizon in that mathematical location. Further than that, then we're not going to be able to use the horizon as an obstructive phenomena, because it can't be further than that unless the radius of the Earth is bigger.
Well, you're mentioning, for instance, when I mentioned earlier the dip angle, that would be square root of height divided by the radius of the Earth, if I'm correct or not. That would be the dip angle, for instance. And if the Earth travels, 15 degrees every hour to equal up to 24 hours, obviously, that could be measurable. For instance, you might see it. I don't know the exact numbers off the top of my head.
That's our point. Good, thank you. That's our point. This should be measurable. Good. That geometric horizon should be measurable if that was the cause of the phenomena of, say, the obstruction of the sun at sunset. That's why we're here.
The measurement goes by time. That's the difference. We measure time.
See, now you're losing me because you're running away. Dude, please, right, forgive me again. All right, don't worry then. I'll try.
I'm sorry. Like, continuing. I said it was a measurement of
It's
time.
okay, dude. It's just you run off down the track a little bit too far at this point before you start talking about rotations and sun times and blah, blah, blah. I'm still trying to figure out the cause of the sun being blocked. That's a claim of a geometric horizon.
How do you test that the Earth has a curve? We mentioned that the angle at which at a 15 degree, right? And you're mentioning the square root, but I'm saying the square root of 2 times your height divided by the radius, for instance, to find what the meter difference is in time. In all honesty, if you can search it up, I haven't really looked into this for a while, but when you are higher, that time difference is longer.
Yeah, but it's based on the geometric horizon. That's based on the radius of the Earth. That means that horizon should be at 1.225 multiplied by the square root of the observer's eye height in distance away from the observer. That's what I'm trying to get you to.
If you're trying to get the
reason why I'm saying this is embedded within that claim is the radius of the Earth. If the Earth was a sphere with a radius of 3,959 miles, then every horizon distance will be no more than 1.225 multiplied by the square root of the observer's eye height in feet.
The number of 1.225. Wait, where are you coming up with the number for 1.225?
You can find these in any Earth curve calculator based on basically spherical math.
1.225.
Yeah, the 1.22 is based on the Earth having a radius of 3,959 miles. If the radius was different, then the calculations of the horizon would be different.
Yeah, homie, if you want to check the text chat, just posted the derivation for that. 39 minutes past the hour. Feel free to scrutinize it.
Yeah, that one needs a little search to see the validity behind it. So I'm not going to say it was accurate or disaccurate or not accurate, but I need some time for that one.
You understand inherent in the shape of the Earth for mathematical predictions, right? The rate of change of slope across that surface of a radius, where the geometric horizon would appear for an observer at eye height on that curved surface. There's predictions implicit with the mathematical claims. That's what I'm trying to point out to you, because when you say the sun sets behind the curvature of the Earth, the horizon, that's a physical claim to where the curvature of the Earth is at distance from the observer. You pointed that out when you changed the eye height of the observer. Consequently, when you change the eye height of the observer, it changes the distance to the geometric horizon on a sphere, being that's the cause of the sun setting. Right? I can't see the sun anymore because the curvature of the Earth is in the way when it descends past the horizon and goes down and we rotate backwards. Implicit within this is the radius of the Earth. We should be able to measure that by utilizing the horizon. If the horizon is further than that or closer than that or changes every day depending on the optic that we use, then we demonstrate it's optical, or the radius of the Earth keeps changing for any observer taking observations, which is ludicrous. So I've appreciated the conversation, but this is where we need to stick to, right? The identification and inbuilt claims within the mathematical claim of the sunset on the sphere Earth. That's a geometric horizon at 1.225 multiplied by the square root of eye height in feet. We can show you that's not true. That's why we're here and have been for 11 years. Oh, that's a shame. Sean, do you want to read out what you said to the class, or just want to keep it to yourself?
Read out what? Sorry, can you repeat that?
That's okay, dude. Do you understand what I just said, yeah?
Well, I'm looking up. I put it as a reference, by the way, because I like to research before I say anything. So this is regarding a completely different argument about 1.225 is rounded, so 1.2246 times square root of the height is representative of a constant of distance to horizon. And I just posted a formula just to keep track of what the hell I'm searching. That's usually not brought up as an argument, but when something's brought up in argument, I think I should know about it before I respond to it. Do you agree or disagree?
No, that's fair, and I appreciate you taking background checking. I accept that as complete reasonable behaviour. Thank you. Not trying to pull wool over your eyes. Please go and check it. You can find it anywhere.
Yeah, if you want to further your investigation, check out how it's actually derived in the first place. Right, so I can help you with that at 39 minutes past the hour.
Well, I understand as a constant, for instance, the number of how does it apply to the curvature of the Earth. That's what I'm trying to figure out, right? Not to, let's say, disprove it or anything, but how does this argument apply into the argument we're just having previously? Does that make sense? And you're saying for me to read
already given a radius value, right? They've already made the claim that they know the radius value. So then the equation to the horizon would be based on the 1.2 times the square root height, right? It's because they've already made a radius claim. That's why it's used. So that whenever you go out and you try to make an observation to the horizon so that you can get its distance, you can pull out the notepad and then write down your eye height above the water, because water doesn't have topography and water is held to the sphere perfectly to the surface because gravity is pulling it down, right? So you would be looking for the curve over the water. You would write down your eye height. You would write down the distance to an object so that you know whether or not the distance to the horizon is where it is. Let's say there's a peninsula and the peninsula is 5 miles away from you. If the horizon is between you and the peninsula, it's less than 5 miles. If it's beyond the peninsula, the distance to the horizon is greater than 5 miles. Make sense? And then you would take your observation, you would apply the math, and then you would see if your observation is matching the geometric claim or not.
I just want to ask a quick question about this topic. Because Sean, you said you don't know the math for this, but when you came in, you said that there were repeatable curvature measurements. So how would you know that if you don't even know this basic information?
Well, I pointed out for the scientific method itself, this has to be repeatable. So I kind of gave what the scientific method itself is.
Okay, but now, measurements aren't the scientific method, so that's irrelevant.
Right. So the difference between I gave him for instance, the angle dip range, but how does 1.2246, the constant, apply to this argument? Right, is to assume that you know everything about everything. And I said,
it's a geometric horizon claim. Sorry, dude.
Mm-hmm.
Dip angle to what?
How does it apply to the argument we're making about?
Dip angle to what?
The dip angle in relative to height. You're measuring. Go ahead.
From eye level to what? The dip angle, that's downwards from eye level to what?
To the sun. The argument
to the sun, that's not dip. So when you say dip angle, that's a very specific term. It's used in celestial and nautical navigation. A dip angle is an angle taken from eye level to the horizon. The horizon in this instance is the curvature of the Earth that you're saying is blocking the sun.
And I just explained that. I actually explained that pretty much at length before you brought the argument of the constant. Let's assume that your your sight to horizon is always constant regardless of the regardless of the height you're in. My argument was making that because obviously the Earth rotates at 15 degrees, and I gave you even my formula, for instance, that may measure a dip angle when you want to say, hey, is there a curve to begin with? Right at this horizon, is it going straight flat, or is there a curve to begin? That's the dip angle. Is there a curve to begin with?
Hey, Sean, you just misrepresented something. He just said something incorrect. He said that we said that the distance would be the same regardless of our height, and that's not the feature of a ball. So we didn't say that. So please clarify it.
I said that it would be more constant. Correct. Like when you're looking straight in a flat angle, you're more likely to have a constant number. If you're looking at that constant, I'm pointing at dip angle, meaning that when you're in a higher level, say in a skyscraper, as the argument I made before.
I think we can discard the dip angle situation, because I really just want to see these repeatable measurements that you claimed.
Do you want me
Can
to
you
do that
post one of these repeatable measurements?
If I discard the constant, the variable that you want to bring up right now, that I should fully research.
That's not ours. That's just the necessary dimensions of a globe of the claimed size.
I can ask the same. How do you not know what a dip angle is? Like when you're trying to measure curvature.
No, I think you're missing my point, Sean. I feel like you're deflecting. You came in and you said you said that there were repeatable measurements of the Earth curvature. Okay. So the dimensions of the Earth are not something. No, the scientific method is not for measurements. We've already been over this. So we know what the globe size is claimed to be, correct? We are given a size. I'm asking you a question. Are you aware? I just have your post. I'm not putting words in your mouth. I'm reading your post.
I love how manipulative this group is.
Sean, can you stop talking about your feelings and talk about the evidence?
Wow, the level of manipulation is insane.
Sean, you came in and you posted that there were repeatable measurements of Earth curvature. I am asking you for one.
I gave you, for instance, a measurement with time. If you want to measure the Earth's
time is not a measurement of the Earth's surface. Do you understand what a measurement is of a physical surface?
We're measuring the sun disappearing behind the Earth.
Okay, no, we're not. We're not. This isn't 24/7 sun. This is 24/7 flat Earth. So if you can provide a measurement of the Earth's surface like you claim to have, like you claimed was repeatable, I would love for you to post that in the text chat.
Or he can say that he doesn't have it actually and retract the original post.
But I gave it already.
You gave the repeatable measurement of the Earth's surface?
You don't want to accept it, and so I gave
I'm sorry, Sean, I missed it. Can you ping it? Because I didn't see a repeatable measurement of the Earth's surface in the side chat.
I spoke it. The dip angle, for instance. Is
okay, that's not a measurement of the surface, Sean. Do you know? Okay.
You might
not. Do you know what a measurement is? Okay, never mind. You don't know what a measurement is. I guess I'll just leave it at that. We can't really have this conversation if you don't understand what the scientific method is, if you don't understand what a measurement is, if you don't know how to apply these things. You don't even know like the basics about the globe dimensions. So you're kind of out of your element here, Sean. You're out of your element,
You are
Sean.
yourself, because I just mentioned it. The time difference when you're at sea level is different than when you're on top of a skyscraper. And that's a measurement you can do by time, right? How long till the sun disappears, for instance. That is, for instance, that's considering the dip angle as an argument. You don't want to accept that. You have right to your prerogative.
Being able to see farther from a higher elevation is not a measurement of surface curvature.
Because you don't accept it doesn't mean that's not a factor.
Sean,
you want me to
being able to see further. Sean, just listen, because you seem confused. Being able to see further. Can you stop talking for a moment?
Sean,
if being able to see further from a higher elevation is not proof that the Earth's surface is curving, do you understand?
It's not whether you see further. Yes, part of the dip curve is you can see further because you can see within a dip. However, it's also measuring how long until the sun disappears. For instance, if there's a curve,
you will see the sun for a longer period of time if you are at a higher elevation.
Correct.
Okay, so that is not a measurement of surface curvature.
I think it is.
No, it's worse than that. It's a pre-assumption. So it's a begging the question fallacy right off the bat. If I beg the question that the Earth is curved and then I time this, that will affirm my belief in the sphere that I already pre-assumed.
Yeah. So you're either going to want to hold the position that you know the radius value already, or you don't know the radius value already and you want to know. Which is it?
In relation to the scientific method.
Who measured the radius?
Just from what Jedi was going off, right? You've got your thing. You want to use the sun.
So
cool.
do you know what a hypothesis?
Still had to validate the Earth. Hang on, dude. You still have to validate the Earth curvature, right? Because you're still assuming it's a sphere. I'll assume it with you. So, are you starting off with you know the radius value, or you don't know the radius value? Because your method of math is going to be different. Which one do you want to go with?
I can't tell you the radius value off the top of my head. I think it's fairly large to measure at the moment, and I have to take, I guess, a standard that was already in place and accept that standard. However, I mentioned as several times already that my argument is that the sun setting in the west.
I know, we're trying to validate if this is true or false or begging the question, right? In order for it to not be a begging the question, you have to have a measurement of the surface curvature, right? There, that would make it valid.
You mentioned the point of what is the hypothesis. So I wanted to ask, do you know the difference between accepting a hypothesis or accepting a null hypothesis means? Do you know what a null hypothesis is?
The null hypothesis is what happens if your supposed or presumed hypothesis is false. So it's an if-then statement. So in this case, what is the if-then? If this, then what? If this, then the sun sets.
If the hypothesis is, if you measure the sun measure the time of the sun at eye level, and you measure the time of the sun at, I don't know, top of a skyscraper, the measurement will be long on top of a skyscraper, which and that might be wrong. I mean, I'm making a correlative argument right here, right? So correlation would be like saying that, okay, then if the sun is observed longer, then the Earth has a curve, and the curve is the reason for why and that could be more of a presumption on my part. I'm not going to kind of say I'm right here, right? This is just an argument mentioning what is the scientific method to begin with.
This isn't the scientific method.
I gave you a measurement.
It's not the scientific method. It's not a measurement. What? All that you're measuring is the amount of time that changes, or let's say that the sun sets slower. That's the only thing that you're measuring.
Which is a measurement.
Yeah, you're measuring time. All you're measuring is the amount of time that goes by. You're not measuring the surface curvature. If you're trying to associate this with surface curvature, this would be affirming the consequent or begging the question. It actually would be both.
Which is a measurement. When we do tests with light, for instance, we're not just measuring distance alone. We're measuring time between distance, right? How long it takes.
Stop it. You're making stuff up now. You better get back on the point, and I mean quick.
I'm making up anything just because you don't
wasting time with you. Yeah, now see, it's me not understanding. So could you please just tell me, is this the scientific method or is it not?
The one I explained, the steps I took, the hypothesis I gave.
Why don't I explain the steps that you took? No, this is not the scientific method. We're talking about the cause of an effect. So far, you're actually calling the horizon geometric. Now you've really hosed yourself.
Pardon me?
Oh my gosh. If I have to explain it to you, even though I recognize you, Sean, you've talked to us before. And if you haven't gotten it all the other times, then this time it's not going to stick either. I don't think.
I talked to you last time, maybe maybe a year ago. So do you remember me?
Yeah, I know. Like I said, I've seen you in here before, and you didn't get it then, and you don't get it now.
A year ago?
Yeah. I recognize your name. It's not like this happens in a vacuum where we all just reset each day like you guys do.
I'm sure there's a lot of Seans out there. I mean, unless
I recognize the font, Sean. You use a unique font.
I haven't been here in well over a year. Actually,
I know. So you've proved my point. You have been here before. I recognize you. Duh. You can't even get that.
Do you recognize the last time I got, for instance, muted here?
Oh yeah, it was awesome. Either way, you got muted, you were here before, you didn't get it. all that stuff. Yes, these things happened before.
You were talking about like, hey, like our
Back
voices
to the
aren't heard
hypocrisy.
anywhere
Now
else.
we're back to the hypocrisy. Specifically, what have we been hypocritical about, Sean?
I'll hand it to you. I'll hand it to you. You did have a conversation with me without muting me at this time and listening to my side. At least I'll hand it to you.
So, Sean, and that's the end of your time here. Because you won't actually directly discuss anything with us. You're all over the place. I even asked you again specifically for the hypocrisy. Can't actually demonstrate it. So, we can move on to somebody else unless anybody want to play with this toy. It's really frustrating.
Let's move on to somebody else because he's accusing us of being a cult. We're not. We don't know the scientific method, and I don't like what I'm hearing. Basically, he hasn't really been honest. He's been disingenuous. He's made claims that we've never made. Why should we listen to this? What's going on here? And you've all been very amicable and precise and concise with your explanation. It's been fantastic. But we have a fish on the line wriggling. What's the point? I don't get it. More.
Yeah, the next time that you're here, a year from now, I will remember that you mentioned there was hypocrisy. You didn't give us a specific example of it. And then you gish-galloped the entire conversation, and then you got muted. I will remember that.
Yeah.
Good times.
Happy days. And when you raise in elevation, more of the land is exposed. It's that simple. It's not proof of curvature. And we mentioned that a flat surface can obscure objects. The manhole cover on the sidewalk, that's been obscured as you're walking. You don't see it from a distance, and suddenly there's a thing there. What's that? Oh, it's a manhole cover by the time you get to it. All right? I mean, this is just... People are taking this stuff for granted. And then they're trying to say it's curvature now. Anyway, anybody got any questions? Any other Globers here? Any queries? Anything?
Well, I have an anything, if no one else has anything. Some people were asking yesterday for a picture from Artemis that showed stars, and that has arrived.
That'll be CGI stars. Not the CGI quality of the picture.
Finally, we made it. Go ahead, Jesse. Did you posted it?
I did earlier, but I will again.
Thank you, Jesse.
Yeah, I saw the image of the Earth's crescent. It was all CGI. We didn't even get to see the astronauts during the takeoff stage. No, in the capsule. I said none of that footage was given to us. Very lacking, and very CGI image of the Orion in space.
There,
sorry,
got it. I got it in the side chat.
What's that?
It shows the northern lights on the two poles. It shows the atmosphere glow. The sun's actually behind the Earth, so that allowed them to take a long exposure. The Earth is actually being lit up by the moon, which allows you to also see the city lights from some of the continents. So it's pretty cool.
It's rubbish.
Jesse, there's a problem here, though.
Oh.
You see the Earth?
Yes, sir.
It's curving here.
Ooh, it might be a ball.
But
could you give me a surface curvature measurement? Jesse, drop over distance, please. Keep in mind that if you don't answer me, if you don't provide what I'm asking you for, I'm just going to ban you. Kind of tired of you being here.
Understood.
Okay. What's the halo thing around the Earth? What is that thing? It's like an aura, like an aura thing.
Yeah, it's also seen from ISS footage. It's the atmosphere glowing slightly from the high-speed particles from space hitting it, I guess, or something like that. It's kind of an ionized gas glowing.
Holy guacamole.
Ionized gas in a 10 to the negative 17 torr vacuum. That's a lot of ionized gas for a vacuum of that
magnitude.
Strength.
Why isn't the gas going the other, towards the available volume, the empty volume? Why isn't it going that way, though?
So the glowing and probably isn't to the negative of whatever. I'd have to look it up. It's not that high. It's at the very top of.
It's not that low.
It's not that low, but it's also not that high. It's below. It's below the ISS for sure.
It's just right in the middle there, just right in that in that Goldilocks zone.
Exactly, Goldilocks. I was going to say not too hot and not too cold.
But Jesse, why is like water around a sphere and it's not like going splash to the floor?
Well, maybe there's no other masses in the close enough proximity to pull it off. Maybe there's no floor. Yeah, maybe there's no floor to make it splash onto.
And I don't see like when we have a sphere here on the earth and we have like water on it, it goes dripping at the bottom, like the water goes like drip.
Yeah, yes, as it rolls off. The residue of the What's going on?
Is it like a magic sphere? Is it like magic?
Maybe. Frankly, it looks like those glass marbles I played with a kid, but it's a lot fancier.
I don't know, but I'm getting a spherical.
It's a man-made thing. This is like a man-made stuff, like the marble, man-made. The blue marble.
I want to know why it looks like a perfect sphere.
Good, yeah. And then what's this other spherical object within the globe object itself? Can you see that? Like a nose, like a clown's nose. So can you see that? To the left, just the bottom left of the picture. Or should I say, just off dead center to the left. I'm seeing a spherical roundness there.
What color?
It looks grayish to me here, but I'm picking that up. I'm picking up a circular object right there. And let me tell you why I say that. It's because, do you remember the one where the image of Earth was taken from 1 million miles away and the moon was transiting across? Right? That's what I've got here. I can see that moon thing. What is that? Can anybody not see that?
I don't think we know what you're talking about.
No, I'm looking at this image you've posted. Yeah, go ahead.
So you see Nigeria, right? The big brown continent on the left?
Oh, you can't say that. You can't say that.
No,
he's talking about like
Nigeria isn't a continent.
Window frame.
Yeah,
window
Africa.
Frame. Window frame. Window frame. Likely a window frame.
Oh, are you talking about the window frame?
Well, I don't know what it is, but it's actually on the globe, on your globe ball Earth that you've posted. It's all black all around it. You've got a little white line going around, supposed to be highlighting. And as I've said, just left of center, drop down slightly, and there's another circular.
Just take a screenshot of it, Jin.
Okay.
Zoom in.
Okay. Thank you. Well, I mean, that's what I'm saying. I'm just saying you what I'm
This
saying.
is so big that I cannot find the small thing that you're talking about.
No, this is massive.
Will someone put a link to this image on the NASA site rather than just a link to the image itself, but like the page in which it's found?
Yeah, because this is not what NASA showed us.
Hey, Jesse, I just want to ask you a quick question. It's clear that you believe this is an actual image from space, and I was wondering why you believe that.
Well, I mean, I wasn't there to take it. I have no reason to doubt it, but I wouldn't bet my life on it being either way. But somebody yesterday, somebody was asking me why.
Wait, no, that's not my question. I'm not asking you what someone else asked about stars or whatever. I'm asking you why you believe that this image is an accurate, believable image of the entire Earth from space.
Well, I mean, I have no reason. What? Say that again?
Why do you believe this is what you have said it is?
What have I said it is?
An image of the Earth from space with stars.
I'm more saying that it's an image from the Artemis crew claiming that they took it.
Okay, this sounds a little weaselly here. Is not Artemis claimed to be in space, Jesse?
They do claim there, but I am not there with them.
Okay, so the image is claimed to be taken in space of the Earth in its entirety, correct? You posted this as something believable. You said, oh, look, here's the image from the Artemis with the stars. So I'm asking you, and you're not really answering me, and I don't know why. Why do you believe this is what you say it is?
I mean, it's more that I have no reason to believe that it's not. I wouldn't stake my life on it being what it says it is, but I see no...
So what are your criteria for determining that an image is in fact reliable?
Okay, I assume you were finished with your sentence there. So if I have no reason to believe that it's inaccurate, then, and it looks just like I would expect it to look, then I would assume it.
Why would you have any expectation of how it should look? Because that's the same question about all the images you've seen. So you've chosen to believe all of the images you've seen. This is just one more in a string of images. So you can't compare it to other images you can't verify and say that this one must be true because it looks like the others that you also can't verify. Do you understand? Are you making a sandwich again, Jesse? Well, I guess that's that. So, yeah, we don't just blindly accept images without any kind of validation. If there's a claimed image of the Earth showing it as a ball, then we would need surface curvature measurements to verify that it is indeed a ball.
That's the big thing, right? You know, if that image is true, then we should be able to find curvature on Earth, right?
Jesse!
Absolutely.
But his evidence for it is that I have no reason to doubt it. That's his evidence.
Yeah, he trusts the experts. I mean, who's an expert in outer space, right? Who has the experience to be an expert?
Yeah, exactly. What does he have to compare that to, you know?
Yeah, I think that's what over fences is telling him, right? What do you compare this with? Maybe. Because when we compare it to the surface of the Earth that we can all check, test, and verify, the water and the Earth is not doing what this image is doing. What is this bright line of light that curves with the Earth at the bottom right?
Yeah.
And then it's like there's like a shine that goes towards the bigger star. You know?
I wouldn't focus on that. That's just as fake as the rest of it, though, right?
Bruh, let me do my fantasy thing.
Sorry, man.
Let me do my Inspector Gadget stuff.
That would be the atmosphere backlit by the sun that's just behind there.
Oh, the sun
are
is
you back?
behind?
He's back. He can answer my question then.
But if the sun is behind the Earth, how is the side that we're at like daytime?
It was a long exposure at a very high ISO, and it's being lit up by the moon.
Holy guacamole!
The moon is lighting up the entire surface of the Earth at once?
And clouds look white during nighttime, like this.
But Gemsy, I still want him to answer my question, which he ran away from.
He's ignoring
you're making. Though. I know, but all that to say, I don't really trust the validation of someone who thinks Nigeria is a continent. So,
Jesse, do you think Nigeria is a continent, though?
And he didn't know whether he was using a Pentax or a Nikon P900 or 1000 yesterday. Remember? Didn't know which camera he was using.
Jesse, are you making another sandwich?
Not Nigeria.
That's Africa, right? It looks like, I mean...
He's trying to say that looks like Africa, yeah. Not that I notice anything there.
Man.
It's the Sahara.
Right. It's a CGI Sahara.
Hey, Jesse, post a link to that image for where you got it from so that we can look at the original source.
Yeah, and is that picture, was that picture taken when the Orion was on its way back to make this translunar injection, or was it taken on its way out? Where was the camera positioned for that shot?
It came out today. It's on its way out.
This is horrible. The heck? Gene, you posted a screenshot of basically the same thing that he posted, just missing one part. Gene Sensei!
Sorry, you're talking, yeah, what did you say?
That
I
you were
posted
asking
the exact same image.
Yeah.
Yeah, I didn't
thought you
copy
were gonna like zoom in. I thought you were gonna zoom in into something to ask about it, but you posted.
When I zoomed in, it disappeared.
What?
Yeah, when I zoomed in on the shot, that anomaly that I'm noticing is not there. It's only visual when you look at it as it is. Just off left or center, there's like a ball there, a faint round object. Like this image was cropped from another image, is what I'm looking at here. And the one that comes to mind is where the one from a number of years ago, where a satellite supposedly took a picture of the Earth from 1 million miles away, and the moon is transitioning across the Earth, and that's what that anomaly looks like to me.
What is this? You see this, Jin? I just posted. If you're looking.
Okay. It's a reflection on the glass.
It's a reflection on the glass.
Yes. Possibly.
Guys, did you see what Yoder posted in the text chat at 14 minutes past the hour?
Yeah, they shot at ISO 51,200.
Okay, I'm going to read what the post is here. It says, realizing there's a lighting error in the picture, professionals and moon bros are scrambling, now trying to say that the moon has lit up Earth to make this photo possible. Since the sun is behind the Earth, lower right, lighting up the atmosphere, obviously the Earth cannot be lit by the moon.
That's what I'm saying.
Mm.
But, even if all the details were quote-unquote perfect, it still isn't an accurate image of Earth because Earth's surface has no curvature.
Right.
So it doesn't really matter. I mean, I've seen better CGI in any movie at Hollywood, so nothing about this is impressive. I thought they would do a better job at faking it. Honestly, it's all been pretty underwhelming.
Why would they add noise?
Anticlimax
Though?
thing all the time.
Why would they add digital noise if it's CGI?
Well, this isn't specifically CGI. This is just an image, but why would they add digital noise? So that you people will believe it.
That's right. That's why they put the digital noise there, to make it seem authentic from space. NASA has been caught scrubbing out. You've only to go to, hang on a minute, you've only to go to Paul on the Plains Faking Space series, and you will see where NASA attempts to scrub out noise to make it seem like it's from space. So they were caught, and also caught adding noise to one of their images. So there you go. They've been caught with their pants down many times. It's their MO. Bearing in mind, we know the Earth is flat, as was said by Over Fences just now. Let's not forget that. And we've seen better CGI than this. This has to be fake because it looks so fake. We've seen better CGI than this before. In the spirit of Elon Musk.
Yo, Noob, are you trying to say something about the fakery that is being presented as Earth?
Is this real?
No.
Okay.
I believe it is.
Oh, you believe this is real, yeah? Okay.
Do you believe? Are you a believer?
What NASA should be doing is release the raw image. This is just
So are you a believe? What is the belief that you hold in, though? What is it? What are you a believer of?
That image shows what it is.
And what is it?
What you see on the image.
And what is that image?
You see it with your own eyes.
Yeah, but what is it?
Right, but we don't see that on Earth, do we?
An image of the Earth.
No. When we check the Earth that you and I are standing on, and everyone is here, that we are here on Earth. When we check
And maybe
this,
too, you asked me just if I believe this image is real, and I said yes.
yeah, but you have any way to verify this? Or can you verify that this is the Earth and the Earth is doing this? That is shown in the image.
No, because I believe that image is real.
So, but even though you've never measured the curvature of the Earth in your life.
That's why I said what NASA should be doing is release the raw image, not the JPEG.
Well,
that's not going to stop all the flat measurements of Earth, right? So it's not going to all of a sudden make all of the measurements of Earth be curved. Do you see the problem here?
Yeah, but the raw image would at least give some credence to the fact that this is not a generated image.
Hey, Noob, could we have a raw image of something that's not a real thing? Like, for example, if I build a model of a train and I take a photo, I can give you the raw image of that train, but it's not a real train. Do you understand that?
If it's a photo, yes, it was taken by. You know how a camera works?
Yes, I know how a camera works.
So if it's a photo, it was taken of it.
Right, but that doesn't mean that the object that it is taking a photo of is what it's claimed to be. Do you understand?
How can it be a photo then?
Okay, if I set up
anything to make claims to what they are. Sorry,
go
Fences,
ahead. Do you want to go ahead?
No.
If I set up a photo.
You can make photographs of anything, right? You can make toy sets of stuff. Little trains look like big trains. You can cut out silhouettes of things. You can take the actual photograph, but the image is not what it's told to be. Sorry, Fences. It just seemed ridiculous he said that.
Oh, no, it's okay. I tried not to interrupt you, but sometimes it's difficult with Discord. So, Noob, Noob, I wanted to address something you said in text a little bit ago about how about the sun. Do you want to just repeat that?
What? The fact that you never want to talk about anything but the surface.
Well, the name of the room is 24/7 Flat Earth. But at 53 minutes past the hour, you said you cannot have a sun that moves in the sky like it does on a flat plane. And so I just wanted to take a quick second to address that, because if the Earth measures flat, which it does, and the sun moves, which it does, then obviously we can have a sun that moves that way on a flat plane.
Okay, but to explain, if why don't you make an experiment where you have two people at the same time stand at different points of the Earth, and then see which way the shadows point. But then you're making assumptions about the size of the sun, right? The sun must be a certain size to cast shadows like that.
What? The shadows would just point away from the sun, giving you the direction of the sun. That's it.
Exactly, but if you have a flat plane, right?
Yeah.
A sun object above you, yes?
Yep, like a light above my head.
Yeah, okay, say this object is large enough to cover enough area of this plane, right? To give you daylight, yeah? Then the shadow will point away from the sun, right? Always.
Yeah.
Usually. Yes.
Yeah.
But how is it then if one of you would stand, say, in Sweden, another one would stand in Brazil, the shadows would point away from the sun, but in different directions?
Yes, because the sun's between you in these locations.
Yes,
One's in Sweden, north of the sun. Dude, please, I'll let you talk. One is north of the sun, one is south of the sun. The sun's in between these two locations. It's like me having a light in the middle of my room and you standing at one end, me standing at the other, putting sticks in the floor and noticing that our shadows are pointing away from relative to us, but towards the sun that's in between us. This is what you've just pointed out.
Okay, listen to me, guys. So, if Earth is flat,
No, we're not gonna listen to you. You're interrupting.
then you should suck my fucking cock, you motherfucker, flat earther.
We don't like roosters. We eat chickens only. Roosters are like old.
Then maybe he had some point, but then he started with that.
So we understand that the sun is between these two locations in Sweden and Brazil.
Okay, but how do you explain the north of Sweden? In one season, it's almost always daylight, but at the same time, in another place, it's almost night all the time.
Cool. Are you sitting down? The sun moved closer to your location in Sweden and further away from the location in. They were still talking.
Okay.
I'll keep it quick. The sun moved. You'll notice the sun rises and sets at different locations on the horizon daily, right? You'll notice the sun is higher in the sky and rises more northeast and sets more northwest in the summer in Sweden, right? And in the winter, dark, because the sun went away. It changed its location on the earth.
I have a question.
Okay, I appreciate you've got a question, but I need to understand that first this gentleman gets what I'm saying.
Okay.
I get what I'm saying. I have no rebuttal.
Wait.
She can ask the question.
Thank you. Thank you, mate. I appreciate that. Yes.
Okay, so if you're on a boat, let's say if you're on a platform and you look out in the open sea, the sun has already set behind, but then you stand up, you will see the sun again. How do you explain that?
You've stood up, changing your angular relationship to the surface, changing how far you can see across that surface so you can see the sun. When you're low down across a surface, right, you can't perceive all of that surface because you're really low to it. And then you stand up, like when you were laying on the floor and then you stood up. You can perceive more of the surface as you look across it. You changed your angle of perception across the surface you are looking across. With altitude, you can see more of it. It's quite simple, isn't it? How do you explain seeing more of a flat surface by standing up and gaining more of a vantage point with altitude across that flat surface? The answer's in your question.
Wait, are you explaining that the Earth is flat or round?
It would happen on either surface, really, if you were to change your relative altitude above that surface. But from a flat Earth point of view, it's very simple. You've stood up, changing your angular relationship with your eyes to that surface. Doesn't mean that the surface is curved because you can see more of it. It's because you've moved away from that surface. Doesn't matter what that surface is.
Stone, I think the more appropriate question would be, why do people think they live on a globe when it's not curving in reality?
I mean, isn't like the globe so big that you just don't notice the curvature?
Well, you just told us that we did because we stand up and sit down. So which is it?
Yeah.
Okay.
Yeah, which is it?
Apparently it's so slight.
I don't know who's like argumenting on what side, honestly. I'm confused.
We're talking to two people that know that the Earth is flat. So you just said that we can notice it because you sit up and stand up and lay down, but now all of a sudden you're saying it's so big that you don't notice it. Which one is it?
Do you understand what he's asking? The fact that you sort of contradicted yourself?
No, I'm confused.
Yeah. Yeah, you're confused because you haven't actually gone out to try and measure the curvature of the Earth to see the flatness of the Earth. Because once you've seen that, there is no confusion going on, you see. That's why at the moment...
How do you... I mean, if you measured it, like, how would you measure it personally?
Yeah.
Well, let's go back to what the guy just asked you, because he said, he said, 1 minute you're saying, oh, Earth curve is in the way if you're lying on the ground, but if you stand up again, you're looking over the Earth curve.
That's why she said she's confused.
But then you said the Earth. Then you said the Earth is too big to see the Earth curve. So which is it?
And then the third question that she did ask was, how do you go about measuring that curvature? So can you tell her so she understands? Go ahead, my brother. Go ahead, man. Just explain to her how we go about measuring the curvature of the Earth, because she doesn't know that.
You gotta ultimately as simple as possible to this lady.
Yeah. So ultimately, everybody on the surface of the Earth measures it flat, refers to it flat, treats it as flat. Okay, so whatever you do, you're going to be describing it from a flat Earth perspective. But on top of that, like, let's take a laser, for instance. If you shoot a laser beam, are laser beams pretty straight? Are they nice and straight?
Morvis, you got some wind in the background, dude. Alright, I'll mute him.
Is she not responding? I got kicked off here for a second. Are laser beams nice and straight?
She said sure.
Yes.
Okay. Okay, so if you take a laser beam, and let's say you take a big laser, because you can find really fancy, expensive lasers. The ones we're talking about here cost about $30,000, but they can reach out there way far, and the beam is nice and straight. So we take that laser beam, and we shoot it over a body of water. And we do our best to make sure that that laser beam is nice and level. We want it to be level so we can create a plane. And then we measure the surface of the Earth against that plane to see if it's dropping away from that straight line plane and see how much the Earth is curving underneath that plane, underneath that straight flat edge. Well, if we do this over 10 miles, 20 miles, 25, 30 miles, we should be expecting hundreds of feet of drop from that nice straight flat plane. The Earth should be way down and the laser beam should be way over your head if you're on the other side of that lake at 25 miles away.
Mm-hmm.
Well, it turns out there's no drop. If you set the laser up at 6 feet and you shoot across the lake, it's going to hit 6 feet on the other side at 25 miles. So the Earth is not curving anywhere, and we experience it flat, horizontal, everywhere. And everybody who measures it and uses it and builds on it and navigates it treats it and references it and measures it flat. So if there's no Earth curve measurements anywhere, why do people think that they live on a ball?
You actually, like, with the Earth size, only expected to lower, like to lower that much at 20 feet?
Yes, yes. In 26 miles, 40 kilometers, we're expecting somewhere in the ballpark of 300 feet of drop, according to the globe Earth geometry. That's the claim. So yes, 300 feet, a football field above you. That's where the beam should be. This is not our claim. This is the globe Earth math.
Okay. I mean, I guess then the Earth really has to be flat. So.
Indeed.
Yeah, but you would need to go out and check that for yourself to be convinced 100%. So it's okay listening to us, but you would need to see that for yourself with your own eyes, and then you can look back in your life though, and you will realize that you've never seen the curvature. Maybe you've been lucky to be on the ocean. Maybe you've been in an aeroplane, hot air balloon, hiking even. Maybe you've done something whereas you've been elevated, and you will notice that the horizon is dead level. Whatever you survey is horizontal. There's no curvature there. That's the one thing that's obvious when you look back. You've never seen the curvature from the moment you were born to the moment you're talking right now. You've never seen it. Otherwise, you would recollect it. You see? So that laser beam test is a beautiful one because it's pure, neat, clean. And I posted in the side chat the curvature maths. That's the Pythagorean theorem of spherical mathematics together with the chart. So if you look up on the chart, you see how many miles and then how many miles of curvature. So distance and then the curvature. It's right there. So you can use that as a template to help you understand how much curvature you should be seeing at a given distance. It's all there for you, just in case. And you might want to bookmark that.
But where did you put it?
Oh, in the site.
I found it. Thank you.
You're welcome. What is your username on the server? What do we call you?
You can call me Stone.
Stone. Okay, thank you very much. Stone, yeah, we're here to help you out. I could see that you were a little bit confused, and you did say that for yourself. So here we are.
Yeah, I don't do good with talking and thinking at the same time.
It's not a problem. Sometimes I'm in that situation myself, so it's not a problem. But that image you've got there can help you understand how much curvature there should be over a given distance. Okay, and then what you need to do is whenever you've got the time and the opportunity, have a little check it, go out and have a look, do some experiments, or observations is what I meant to say. Make some observations, yeah. Because the Earth can never be too big to not notice curvature. It's got to be there, no matter what. If it's tiny, if it's humongous, it must be there. Must be. It's not something you will not notice. Sorry. Especially if you're traveling over great distances. You must encounter it. And then when you realize that the Earth is measured flat, these images that are posted by Jesse, for example, purported to be coming from space by NASA, you know that has to be a lie. And the image they gave us, that's a CGI composite image. It's not a real image of Earth. Earth is not a ball. And I've noticed a little anomaly in that image that I posted, one that was similar. If you scroll back, you'll see I posted one looking similar with the moon transition across. It reminds me of that. NASA's not doing very well with their CGI buffoonery.
I don't see that anomaly you're speaking of, though.
Well, I see it. That's why I noticed it. Maybe you're not looking.
Why don't you screenshot it? I see it in the full resolution.
Well, when I actually enlarge it, it kind of disappears. When I squash it down, that anomaly pops up. So when I look at it,
that's not how files work.
I'm not saying that's how they do work. What I'm noticing, though, in the image that was posted by Jesse, as I look at it, there's a little anomaly to the, like I said, from center left, drop down slightly. There's a circular anomaly, blemish right there. And it reminded me of the shot that I posted afterwards, where the moon is going across the Earth back in the day, taken supposedly from a satellite 1 million miles away. That's what that reminded me of, that blemish. There we are.
I'm curious to see that blemish. Can you take a screenshot of how you see it?
Well, I mean, I did my best. I posted the image and I posted a similar image. That's the best I can do for you. Okay? Point is, Earth is measured flat, and I know they're lying, and there's a blemish in the picture Jesse posted. I'm seeing it.
But you're the only one who saw it, not even your peers.
Well, I'm seeing that. I'm seeing a blemish. I'm seeing a blemish. See?
A blemish. Now first you saw it's a circular.
Well, it's a circle. I'm calling it a blemish because it's a circle. A circle can be a blemish. It's an anomaly. A blemish, a circle, an anomaly. It is not perfect for me. Okay, something's wrong with that image.
You understand, we don't take issue with the image because of any anomalies that we see on the image, right? We don't take issue with it that the light is wrong or the clouds are wrong or the stars are wrong or any of that. You realize that that's not the issue, right?
Yeah, you realize that.
I'm just curious what he saw because no one else saw it.
Okay, but the issue we take is that the Earth's surface doesn't curve. So it doesn't really matter what you show me. Yeah.
It's okay. Of course, it doesn't matter.
Yeah. Okay.
Just was curious what he saw because maybe I saw it too, but I didn't. That's we all looking at the same file, I assume.
Well, I'm looking at the same thing, and it looks like a landmass being especially highlighted with the white line just going around the edge of it. Can you see what I'm looking at here? Because I've just enlarged it. Just enlarged it. It's a landmass.
You mean Spain?
That's what it is. Could be Spain, yeah. Could be. That would be very big if it's Spain. Because that's a lot of the globe. Spain is not normally that big. So now if that's Spain, that's too big. Way too big.
I realize. Now, well, the biggest landmass there is the Sahara.
And that would be left of center, yeah? Just dropping down slightly.
On the left side, yes. Of this.
Yeah. Oh, because that's all Sahara, is it?
Well, Northern Africa, I guess, yeah. You know how, I mean, the Sahara is small. I guess we can agree on that.
Yeah, no, Sahara is massive, yeah. It does take up a lot of Northern Africa.
And then you have Gibraltar there, Morocco, and Spain. Because it's upside down.
Do you remember how they made Thunderbirds?
Yeah, absolutely.
Yeah, cool. So we'll get a big paper mache ball, let's give it a diameter of 14 foot. We'll stitch a map to it, give it some terrain and whatnot. We'll put a rocket, like a camera, close to it. We'll spin that ball and, hey, look, the Earth's rotating. We're flying a rocket around it. This is at best what we're describing here.
Yeah. It's ridiculous. Yeah. Appalling photography for this day and age of high definition.
Oh, so now it is a photo.
Oh no, it's supposed to be a photo. I'm saying photography is the field that we're all into. We all have an interest in. This is offered up as an image from space purportedly. Obviously, it's not the Earth because we're flat, we're not curving. But this is an appalling image for today's standard of HD. Okay, that's all I'm saying.
For today's standard, you know how it's dark, how dark it is up there.
I don't care how dark it is up there. It's appalling standards.
Well, you don't know how dark it is up there either.
Yeah, that's right.
Noob, you're just guessing. You're just going based on what you've been
image
told.
shows me how dark it is, but they use ISO 51000. Of course, it's gonna be. It's not gonna.
No. You're missing my point. You're drawing assumptions based on your presuppositions.
Yeah, because you haven't been to space to know.
Well, okay, no, of course not.
Right. Bear that in mind when you speak. Then just bear that in mind.
No,
they're offering
of course,
me
I'm seeing the image that they've taken.
They're offering
from
me
space.
something. I'm rejecting it because it's just not true. Because Earth is flat. I'm now looking at the standard of the lie, and the standard of the lie is appalling. Okay, because I know they're lying. Okay,
that's fine.
Today's standard of lying versus the Apollos. This is terrible, ladies and gentlemen.
All right, cool, yeah.
Thank you.
Rebut you there. That's.
Thank you.
That's what you.
That's exactly what I'm saying. Yeah.
Okay, cool.
So Noob, I think you've been here before, even though you're Noob. Is that correct? You've been in the room
He's
before?
been here a long time. He's been here for some time.
Okay. So, why do you believe the Earth is a ball? What was the most convincing evidence that you were presented with?
It's a great question.
Many of the things that, like what I said before, but you always dismiss it with, the sun is moving. You always have a.
Okay, well,
can you
this
remind
is the first time we've talked, and I asked you for the most convincing evidence, not just a list of what we've rejected. I asked you what you personally find to be the most convincing evidence that the Earth is a ball.
Yeah, slam dunk, without a doubt. Well, he must have a lot because he's thinking.
No, I'm just thinking how to formulate my answer.
Okay, because while you're thinking about it, I'll just say that the reason that I used to believe that the Earth is a ball is because
I know you measure
I
it
was told.
straight. I know.
No. You're not. The reason I used to believe that the Earth is a ball is because that's what people told me it was. And they told me that from a very, very young age, and they were people I trusted. And I was also told that this is what everybody believed, and everybody knew it. Yeah. And at no point in my education was I presented with evidence that this was true.
Right. So you took it on 100% trust because you had no reason to distrust it. You learned it at school. They taught you correctly, and you carried that trust all the way to the point where you were told it was not true. So what's your
and even more than that, I was told that to question that was to be an idiot, right? It's used as an epithet. A flat earther is just like the lowest of the low. We must all despise the flat earther. So they created the social conditions to prevent people from even questioning it. Like it's such a given that no one could possibly question this.
You might remember your parents telling you, don't criticize the teachers. All right? Well, that's what I was told.
Well, no, thankfully not.
I was a bad student. I wasn't.
What's a bad student, Noob? What does that mean?
I wasn't interested. I wasn't interested in school.
Well, that doesn't necessarily make you a bad student.
I didn't do my homework.
But maybe
I didn't really care
maybe that's a good thing, right? It depends on what the school is teaching you, right? A lot of very
No, I thought it was
intelligent people.
boring. It doesn't
Yeah,
matter
well,
what
maybe
it
you were
was
too smart
teaching me.
for it. Maybe it was you didn't like the
No,
indoctrination.
it was simply boring.
Right, that's what I'm saying. A lot of very intelligent people are bored in school. So maybe that's why you weren't a good student.
The
So
monotony.
why don't you question?
Get back to the question.
So, I'm sorry,
Yeah,
but do
okay.
you have your best evidence?
Yeah.
No, I never questioned it. No.
No, do you
Okay.
have
No reason for me to question it.
do you have your best evidence for your globe though? That's what Jedi was saying. Don't forget that, please. What's your
No, I
best
don't,
evidence?
because I never had to
Right.
investigate it.
Right, and you know, I appreciate that honesty because
Well, it doesn't matter.
we were all there. That's how we all were, right? The reason I'm no longer a Glober is because I did question it and I did look for evidence of the things I had been told. And
then
so
there's no-
if you can look for it, if you can be open-minded and not have an emotional attachment to the story, you're going to end up in the same place we did.
No, because I
It's
asked other
impossible.
questions then.
It's impossible not to end up a flat earther if you actually look for objective evidence with an
Then
open
it's not
mind.
enough still.
What do you mean?
Because I would ask more questions, even if I had that
Oh,
measurement.
well, do you think I asked one question, or do you think I've been asking many questions for many years?
That I don't know, because every time someone wants to try to talk about anything that's nothing to do with the surface, you guys always dismiss it.
Well, we try to, you know, the name of the room is 24/7 Flat Earth. And that is something we can
Yes.
empirically prove, correct? We can empirically
But
prove that the surface is not curving.
Yes, but if I was one of you, I would still ask the other questions too.
Okay, we do ask those other questions, but we need to first establish a baseline, right? Because so many of
done
these
that.
things are attached to the. Do you understand? Without a ball, that pulls apart the rest of the heliocentric theory. And then
House
we
of
can
Cards.
ask those questions, but we can't prove these things. So we try to deal with what we can prove and we can test, we can measure. The other things are speculation, and we do like to talk about those things, but they're just speculation, and we acknowledge that.
Well, then you see, then I rather live in a world where a model is plausible than in a world where I only have one measurement, but there's nothing else.
But the model isn't plausible without an Earth that's a sphere.
Yeah.
And the measurement is debunking the globe. The measurement is the actual truth. Why would you relinquish the truth for a model that doesn't even exist? Why would you do that?
Because it tells a good story. It's plausible.
I knew it. I knew it because it has a nice explanation. You'd
There you are,
rather
ladies
have
and
an
gentlemen.
explanation than be left with wonderment and question. You'd rather have a
Yeah,
good story.
rather ignorance is bliss than half-answered questions.
No, this is a dangerous position to be in. No wonder humanity is where it's at. Yeah.
No, not dangerous. Life goes on whether I believe it's round or not.
Life is going on wrongly. Life is going on wrongly, ladies and gentlemen. It's not going on correctly. If we look at Earth today with the lies they're telling and the price that the taxpayer, the humanity is paying with all the deaths going on, life is going on wrongly because of the indoctrination. So don't be telling me this is a good life, really, because it is not. Not a life where children are dying in wars that need not happen, for example, and various other things that are going on that we don't need to have going on. So no, I totally disagree.
There's an interesting question you came up with. So, on a flat Earth, you really think wars would not happen?
Oh no, they always will.
Yeah. The point is, it's
So
still
there you go.
Understanding the flat Earth isn't going to change the human condition.
Okay, there you go. Then I'll stay with my ignorance.
Really?
That just seems like a weird statement for me, though. I would rather stay with my ignorance. Really, is that what you say to yourself in the mirror when you wake up? Today, I'm just going to fucking remain ignorant.
No, the point I was making was just, regardless of, no one is trying to insult anyone, everyone is a human being. We're all still equal regardless of where we come from or what we believe or what we measure. You know. No,
Hey,
I'm
Noob,
just
there's
talking about.
Sorry.
No, just finish. Like, just to answer your question, like, my daily life does not depend on whether the sun is a real celestial object or some lamp.
Well, you know what?
Or the Earth
You don't
is
know
flat.
that. You don't know that
Yeah.
because you're on the other side. So you can't really speak as someone. You know, it's like if you're involved in a religion and it's the only religion you've ever been in, and everyone around you is a member of that religion, and they tell you this is how things are. You can't possibly know what it's like to leave that religion and be on the other side. You can speculate, you can think you know, but you don't know. And there's a pretty famous quote, and I'm gonna bungle this completely. I can't remember who said it, but that people who can be convinced to believe absurdities can be convinced to commit atrocities. And you just have to decide in this life whether you're gonna own your own mind or you're going to let your thoughts and beliefs be dictated by people other than yourself. If you're going to let people tell you what to think and you're not going to question it and you're not going to take hold of your own life. And that's a choice.
Don't we all live in ignorance somewhere? Because
Sure, of course,
like
naturally.
the world is so complicated. There's so many things. Also, like science is like bigger than it has ever been, right? Because like we're adding more and more things on to stuff that are like that we
not really.
pretend we know. And how not?
Let me put it to you this way. Technology has increased. That doesn't mean science has increased or knowledge necessarily.
I don't
It just
mean
means
that
that
the
we are
knowledge
building
is-
better tools.
But if you look at the physics book nowadays, the math books, the biology books, you have way more books. They have way more written inside.
That's just more speculation. Yeah, that just means people are,
I didn't say
speculating
it's
more.
true. I didn't say it's true what's in there, but it's just like a lot of information. Like,
Well, then why did you bring it up?
because it's a lot of data that you would have to look at every single thing and question it for yourself because it is so advanced.
Well, so you're saying that if there's something that is stated as a fact, or they call it data, but really you ought to look at it for yourself to make sure that it's true, why would this particular topic not fall in that same category? Things that we should scrutinize so that we're not bamboozled by everyone's speculations or, conceptions about things.
That's not what I said. I just said that it's a lot more stuff that you would have to go through, and that would take a lot of energy.
So the default is just to give up and believe whatever people say and not ask any questions?
I don't think so. I think the default is, for me at least, to concentrate on the things that interest me and are important to me most, or at least I try so, because I want, with the energy that I have, to have fun and feel like it's important,
Okay, so why are you here? If this is not important to you, why are you asking any of these questions? I mean, the fact that you're asking questions means it must have some kind of importance to you. Knowing the truth about where you live, I think that's pretty important. You may not, but you're still asking the questions. It's very interesting.
Curiosity, maybe. Still.
Yeah, it's still an interest, isn't it?
That curiosity is still a desire to know.
Yeah.
Or the
If you,
desire to
I
understand
didn't say
something
it wasn't
others love.
important to me. I just said that we somewhere all live in accepting some things because we don't have energy to question every single of them.
But Stone, don't you think the very nature of the earth you stand on is pretty important? Don't you think that maybe takes more precedence over some minor detail in one of your studies?
The foundation.
I think it depends what you.
I mean, this is the earth we all live on, right? We've been taught a heliocentric model, and there's great detail that's presented to us in that. It affects your daily life. It affects how you read the news and what you're told. So why are you lumping this in with like any kind of random fact that you might learn in a classroom? I just don't think that this is on the same level as anything else, which it seems like you're trying to say. Obviously, no one has the time in their life to investigate absolutely everything they're ever told, right? But we are intelligent beings. We can pick and choose which things matter, and we can look into them. Now, if you're not interested, that's fine. No one's telling you have to be interested. But as for myself, I think it's pretty fascinating and very interesting. And I find it hard to understand why someone wouldn't want to know the truth about the Earth.
Yeah.
To the gentleman earlier that asked if there's, if there's all these wars and yada, 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 and it apparently to him doesn't matter whether or not the Earth is curved or flat. And Jedi replied to him, which I'm going to disagree with you on this one, Jedi. It may not change the human condition. I don't know if I believe that, because I think that most of the people that are, going to the violence to get their desired results in this life are people that mostly have no value for other human beings because they themselves find no value in themselves. And they're generally hopeless people. They're just, here today and gone tomorrow. I think that knowing that if you live in a realm that may be created and that there is a creator, that may change a lot of people's look on life, and they may have more hope, and they may be less violent. But
thank you. Thank you.
That's my speculation.
I was just going to say that just before you said that was going to be my next statement, that I, Jin CBR1, hold the position that if the whole of humanity came into the realization that they're living on a flat Earth and they've been misinformed at school, and then they are prompt to check other areas where they've been misinformed, they would come together and demand the truth, and wars would drop dramatically, would be going in the reverse, because the connection to the creator would be recognized and life would be a lot different. That's my position that I hold for the longest of time. So thank you. I think it's very important. It's that watershed. Go ahead.
The most of the history, it was known that the Earth is flat.
Before, yes.
Yes.
I would agree to that, yeah.
It was believed, it wasn't known.
It's not true.
Well, now we know. Isn't that great? I mean, now we know that the Earth is flat, so we don't have to worry about whether or not it was believed or whatever. So we know now. That's fantastic.
What would you do, for example, if you wanted to study physics and then you found this out? Like, wouldn't it make it very...
No, physics still apply because it's physics is the application of learning the natural environment outside. So physics would still apply. Only thing is you'd be dropping the heliocentric model of it, because that's pseudoscience, dogma. That would be removed or taught as how Earth, we used to think Earth was, or the interruption to the knowledge prior to that. So it will be taught, but physics doesn't stop being physics, if you know what I mean.
Yeah, I think at this point, if your pre-assumption about the physical realm is now corrected, because now you're not operating under the delusion that you're on a spinning ball, we can correct a lot of the things that we jacked up to this point. I think you're correct.
But if you're just ignoring the things that you don't like, you're sharing.
No, dude, stop straw manning us. We're not ignoring things that we don't like. We're talking about the actual data, the actual measurements, and the what is question in reality. So stop that. This is not about our bias. And if you think that we're being biased, I would like you to cite a specific example of where we've been biased.
Yeah, and we're dealing with the molecules as well. Every molecule of Earth we're interested in as flat earthers. But carry on. Yeah.
Carry on with that. I wasn't saying more.
Okay, well, there you are.
So then let's end our cope by trying to strawman people and saying that they're biased with something when you can't point to one. That's just ridiculous. And it's insulting.
The word bias.
Yeah, I know. What were you saying? Things that we don't like? So we're biased towards flat Earth?
Physics still apply. but you will just take away everything has to do with the heliocentric.
Why are you accusing that? Why are you accusing us of that? Because the heliocentric model has now been debunked. So everything predicated on the heliocentric model, now that heliocentrism is no longer viable, and everything that's predicated on it in your mind, as far as physics is concerned, can be thrown out. Isn't that wonderful?
Yeah, it's junk.
Yeah, but look, if you go to university and you study physics, and you say, okay, I'm not going to study this because this has to do with this dogma, as you call it, yeah?
Dude, no one said that.
Can you just let me finish that sentence, please?
Well, I know, because you're starting off by strawmanning me. I didn't say dogma. You said dogma. I didn't say dogma. Not one time.
Go back to the stream.
If you're accusing me, excuse me, if you're accusing me of using the word dogma specifically, you go to the live stream and you pull it out. Then prove it.
I don't have to do it.
I said dogma.
Can anyone back me up, for fuck's sake? I said 3 times before. He said, no, you didn't say it. He was speaking.
No.
Okay, well then you go ahead and get your own evidence. Otherwise, you're going to retract it. Otherwise, you're going to go on mute, because I don't like you coming in here and accusing people of things they did not say.
Yeah. Yeah, I said it was dogma.
Okay, I'll clip it. Let me go.
Yeah, you find it. You will find it. I said it. I said that we would be physics still becomes physics. The only thing is we would remove the heliocentric model aspect of it, because that's pseudoscience dogma, is what I said. But we'd teach it as how Earth how we used to think of Earth prior to what we were thinking before. That's what I said. So, I remember exactly what I said, mate. I said dogma.
Okay. I'll apologize if I didn't watch which voice belonged to who. But
you misunderstood.
So you said it. Okay, fine. Okay. I'll apologize for that. Okay, it was the wrong person. But someone said it. I knew that. At least, okay. I'll respect that you repeated what you said, and okay, I'll apologize if that was I thought it was.
Yeah, you need to apologize to says who. So if you say says who, I apologize. That's official. Go ahead.
I'll accept it. He said it. I get it. So, but here's the thing, dude. If it's not actually physics, if it's not actually proven with the scientific method in physics, then why would we care anyways? I mean, you mentioned earlier that you actually want this to be true just because you like the idea, you like the stories. Well, then that's your prerogative, but it's not actual reality. You want to believe in a fairy tale, and that's your thing. Fine.
Yeah, cool. Yeah, of course. Yeah, true. But yeah. I did want to finish the sentence before, because you did tell me I was insinuating that you are a biased guy. Okay, so let me just kind of finish the point. Yeah, what I was saying is that, so now I forgot who it said. Okay, but someone said that when you go study physics at university, yeah, okay, you do that, and it still applies to a flat Earth, but you would ignore, or whatever you call it, the parts that have to do with the heliocentric model. But by doing that, you're still relying on things that so-called scientists, I guess we can agree on that, have throughout hundreds of years discovered and experimented with.
But they haven't. The heliocentric model is not real. So we would have to remove that from the curriculum, or if we put it in, it will be in the history teaching. This is how we used to think of the Earth back in the day. But it won't be taught as a fact in the science classes, for example. It just wouldn't be there. Wouldn't be in the science lesson as a fact. That's what I meant by removing it. We can actually remove that because it's junk. It's not the truth, is it? Earth isn't a ball. We're not moving through the universe.
I think it's useful to separate what we can prove versus what we can't. So I think, I mentioned speculation to you earlier. So, there's certain basic principles of physics that we can prove, correct? And then there's things we can't, that are just calculations and theories.
Yeah.
So you can get pretty far, in physics without relying heavily on ideas that can't be proven.
Yeah.
And I also just want to mention that belief in the heliocentric idea requires you to deny science.
To deny reality.
The second law of thermodynamics completely disproves the idea of this pressurized atmosphere next to a vacuum without a barrier. So you have to suspend your disbelief in order to continue to believe in the heliocentric idea.
Right. That is why I'm often accused of denying science, or I don't understand the heliocentric model, because I remain firmly in reality and I don't accept the model, and then I'm accused of being a science denier, or I don't understand the model. I understand it, I just don't accept it. Why would I want to accept something that's not real? Why? Why should I? Yeah. That's why I hold a very firm position in reality. That's my base. That's my foundation. I don't want to live in Narnia, because you open yourself up to being deceived, ripped off, bamboozled. Hence, trillions of dollars now leaving the human race across the flat earth. We're being ripped off. They're supposedly going to the moon. That's a $93 billion scam right there, happening for the next 10 days, ladies and gentlemen. $93 billion scam. All right, there we are. That's good, isn't it? Isn't it? Isn't it?
Let me understand this, second law of thermodynamics stuff. Is there a barrier, and I know the answer to this, but is there a barrier between, Kansas and Colorado? Because they certainly have different air pressures, right?
Well, it wouldn't be a barrier, but it might be an elevation difference, thermal temperature differences. That's all going to be happening. Wouldn't be a barrier, would there?
You know that the gradient would be part of it. Yeah.
You're breaking up. Say it again.
I'm just saying that the observation would be the gas gradient in the scientific method.
Right, there we are. Elevation.
Yeah, there's no contention with the gradient, right? But the gradient of gas would be adjacent to an area of lower pressure, known as outer space. That's what Over Fences was saying. So if there's some experiment out there that can actually demonstrate gravity as the cause for the gas gradient adjacent to an area of lower pressure, then that'd be cool.
Yeah.
You wouldn't have any contention with it anymore.
But we don't have that, do we? We don't have that experiment. And then the Earth, as they depict it in the heliocentric model, being a globe ball Earth in the vacuum of space, and the way that's been described, there's no container. All that stuff would just entropy into the vacuum of space. That's why that ball as we see it, is a second law of thermodynamics violation. It cannot exist. It just cannot.
But we'd agree in the same sense that if I start in Kansas and I get X air pressure, and then I go up to the mountains of Colorado and I get Y, and then the further higher up I go, I get less and less. It at least jives with reality, correct? That
correct.
I just said there's no contention. Yeah, there's no contention with the gradient. It's part of the observation.
Yeah, it's part of the human experience.
The
we covered that in the first step already.
We go, we get none, or close to none, right?
Well, sure. Then you would have to show that a gas gradient can exist adjacent to an area of lower pressure or a vacuum, known as outer space. So what you can do, right? For example, you can have a gas gradient within a container.
Yes.
And then you're going to have another empty container next to this gas gradient that's a vacuum. And you're going to try to stop entropy from occurring with gravity.
Which hasn't been demonstrated ever.
Yes, not once. I mean, unless you have something. I mean, not you specifically, or you can cite somebody that's done this. Because we have our independent variable as a solid, as a physical container or barrier, proven through the scientific method, verified that a physical barrier can stop entropy from occurring. and just posted it up in the site chat. You're going to notice that the part where it's most narrow is something physical, solid. So you have to put something in between these two containers that can stop entropy from occurring. Whatever you want to claim, it could be gravity, magnetism, whatever. I've heard it all. But you have to find some way to stop this from occurring.
Yeah, that's one of the best examples I've ever seen. That one, I love that one. And you notice, and you notice it's going upwards against gravity as well. The supposed gravitational pull, and this material is moving into the vacuum. Entropy. It's the best. Absolutely. I knew that's what it was you posted without even looking. I just thought I'd have a quick check, and yeah, number one proof.
Yeah, so if there's ever an experiment where gravity actually can, pressurized gas adjacent to an area of lower pressure, gas gradient, that would prove that we can have gas adjacent to an area of lower pressure with gravity, so that outer space could be real in the globe paradigm. And then we just need physical measurements of curvature on the surface of the Earth, and that would prove that the Earth is physically curving. So we just need those two things, which for some reason, every time we ask, they're never provided. We're asking for measurements in science.
You mentioned gravity, right?
Mm-hmm. Sure.
But let's just hang on for a second here. Let's assume gravity exists. If you run this experiment, both of those flasks are still within Earth's gravity, and in that case, it will actually disprove what you say. It's doing exactly what it's supposed to do.
Yeah, but gravity doesn't exist. We're living in reality. There's no assumptions going on.
I know.
Well, it's no good.
Even in the
It's of no use. Yeah, it's of no use.
The thing is that
if we assume gravity exists, what's it causing? With regards to the gas, what's it causing the gas to do?
To do exactly what the experiment is doing there. It disperses into the other space.
Okay, why does that happen?
Because the pressure is the same.
No, you spoke about gas dispersing into the other space. Why does that happen?
It can't be because of gravity.
No, it's because of pressure.
Yeah, it's because the gas molecules are bounding around, pushing and pressing against each other. So, what's gravity doing?
In this case, in this very instance, nothing, because both of these flasks.
This is where all the gravity is. Sorry, you just said this is where all the gravity is here on the Earth. So here we've got all the gas moving around freely in random directions. Gravity.
Okay. But just, if you talk always about scientific method, how can I be sure that vacuum is actually a vacuum?
It's an available volume. So the demonstration.
How was that vacuum created, though?
The vacuum, dude. You can demonstrate this in any way. It's just the simplest expression of the second law of thermodynamics, described as gas expansion into a vacuum. This is a demonstration of that. The reason why this is a demonstration of that is because it's entropy in action. No added energy to the system when the valve is open. The energy within the contained environment of the gas that is pressing and pressure is now available to move into a new volume. Right. Just by the way that it works, it's going to expand into that available volume. So where's the gravity?
Yeah, and the other thing is you can buy this equipment, or you can even rental this equipment and conduct this test for yourself. It's not that difficult, and then you can rent the vacuum pump that will evacuate that chamber for you. All right, this is provable. That's the point I'm raising here. So if you're not trusting,
I don't doubt that experiment is repeatable. I didn't
Right.
doubt that.
Okay,
I'm
good.
just trying to understand what it actually shows me.
Well, the thing is, if you're in doubt, because you are exercising a little bit of doubt there, you're exhibiting that. So you can actually, if you really wanted to know, you could go and have this conducted. This can be conducted in your presence.
Again, I don't doubt that this can be conducted and repeated.
Well, you asked, how would we know it's a vacuum? You asked that.
Yeah, okay, fine. Yeah, okay, good. And I guess it can
well,
be
then
proven.
stop lying then. You said, why? How do I know it's a vacuum?
didn't lie.
That is doubt. When you ask, how do I know? That's doubt.
Yes, I understand. Okay, well, I believe that it can be repeated, and I believe if it's done before my eyes, okay, that settles that. Then my next question is, what does it actually prove? How does it disprove?
At the moment,
it proves natural law.
At the moment, it's showing an increase in entropy. We're asking you where the gravity is.
That I couldn't tell you. No, I'm not a scientist, man. I'm a layman.
Exactly. Right. The point being is there's no gravity. Gravity doesn't appear in the laws of thermodynamics, especially with regards to the second. Gas expands into a vacuum. This is the law of nature. It works in this direction and this direction alone. The reverse doesn't happen. So when we say gas expands into a vacuum, that's the law that works in that way. The claim that the Earth is a sphere and the gas doesn't expand into that vacuum is a violation of that law.
Yes, you're right that it does exactly what it's supposed to do, and the law says it should do that. There's no rebuttal for that. You're correct on that. Absolutely.
And just to be clear, if we don't necessarily need a vacuum for this experiment, right? Like I could have a piece of, the bottom tube is 2 bar, the top one is 1 bar, and we'd still expect the same thing to happen.
Well, that's what's outside the Earth. And there's a vacuum outside Earth, so we do need a vacuum for that to make it analogous, right?
All right, yeah. Then
Earth exists within a vacuum in your paradigm, so we definitely need that vacuum.
I guess where I was going with this is if we had a container that was 2 bar versus 1 bar of pressure, the same thing would happen. That brown, ugly-looking gas would eventually
sure, we can
equalize. And the same is true. The same is true, but the reaction is probably slower. I'm just guessing. If we had a container that was 2 bar and the other one was 1.75 bar, but it would be slower. And I guess in my head, I'm kind of justifying or, rationalizing it as like, okay, there's no barrier between Kansas and Colorado, yet the pressures are different. And there's no barrier between the tip of a Colorado mountaintop and the outside of space, but the pressures are different. And as you go higher, the pressures, get lower. And so, that's why we don't see this massive movement of stuff escaping into outer space, is because the pressure differential isn't enough to.
But why with altitude does the pressure get lower? If you go up on Mount Everest, the pressure is lower than on the surface of the Earth. How do you explain that without gravity?
It's cold up there. Also, the gas is produced primarily at sea and surface level. You notice when we're talking about this system, we have gas production, reproduction cycles, as in absorption of the gases as well, and temperature within the system. Now, the system in which we live in is dynamic. Let's use that word.
Yes,
you're asking why there's a pressure. At the moment, you're asking why there's a gas pressure gradient with altitude. Okay, what are the other variables involved?
Well, you name entropy and thermodynamics.
Okay, so temperature, energy. Yeah. Where the gas is produced. Where is the gas produced?
No, I'm talking atmosphere. I'm talking about oxygen. If you go to La Paz,
the oxygen, but it's still an equal rate.
In Mexico City.
Yeah, there's still an equal ratio of nitrogen and oxygen at the surface of the Earth compared to upper mountain. There's just less of it. Still equal
how
ratio.
do they measure that? There's a formula for that, which actually
Atmospheric barometric formula, memory serves.
In combination with gravity. So
gravity is an acceleration of 9.8 meters per second squared, if I remember the formula correctly. Atmospheric barometric pressure formula.
We don't need to.
Okay, so does gas do that then? Does gas accelerate to the floor at 9.87 meters per squared?
So, but if you take that formula away, which represents gravity, it doesn't work.
Okay, but that's a formula. Within the formula, it's making a gas towards the surface of the Earth at 9.8 meters per second squared. I'm asking you if gas does that.
No, gas doesn't do it on its own. No.
Okay.
Which means it needs something else, which is influencing it.
No, it just means it's reality. It's second law of thermodynamics happening. It's natural law. Your formulas remove, and it doesn't work. You know, your gravity formula you remove, it doesn't work. Jedi said that's just you speculating that. Can you actually demonstrate that? To take the formula that you are telling us, apply it practically in the scientific lab, and show us that it doesn't work. Can you do that?
Why the lab?
Well, because that's where you're going to. That's
high
your first
altitude
experimental
lab.
Hold on. Sorry, that's where you get in the atmospheric barometric formula, the G, rate of acceleration of the object to the Earth. You get that from dropping things in vacuum, don't you?
No,
you drop a rock, you drop a feather. All things. Sorry, you drop a rock, you drop a feather. All things in vacuums fall at this rate, don't they?
At the same rate, yeah, right.
Yeah. In a vacuum. Yeah, in a vacuum. Okay. So what happens to a gas molecule in a vacuum? Does it accelerate to the floor?
No, doesn't move.
Right. There we are, then, regardless of your formula. You see. And by the way, ladies and gentlemen, just another side note: objects of different weights don't fall at the same rate, even in a vacuum. All right. So that's also a myth that's been debunked, by the way. All right. So things don't fall at the same rate, even in a vacuum. The heavier object always hits the ground first, always, unless you shorten the drop height. Then the heavier object is not able to reach its maximum drop velocity, so you can see it hitting the ground first. Okay. So although we don't accept gravity as a thing, we know what it does. It cannot do. That's what we do know. It's not pulling things down to the Earth at the same rate. It's not.
Can you show the experiment
in a vacuum?
for that?
There is no gravity. It's simply falling.
Can someone post that experiment where
I would love to do that. I will do that for you shortly. I'm Jin CBR1. Look out for the Pete and Pete vacuum drop test. I'm going to be posting about 4 of them. Okay, and the reason for that many is because in the comments, certain people were commenting that they weren't quite satisfied, so they had to repeat it on several occasions just to satisfy the people. That's their integrity. Okay, give me about 2 to 3 minutes, and I'll do that for you. Thank you.
Repeat.
So that one experiment, I saw this experiment once by Brian Cox. You dismissed that experiment then?
Oh, absolutely. That's talking about the stuff. Yeah, that's no integrity in that whatsoever. And that's going to be part of the drop test. They'll explain why they didn't accept that. Thank you.
Who's they?
Peter and Pete.
Who's Pete and Pete?
Well, when you see them for themselves, you know who they are. Give me a few minutes just to get the material up, and you know who they are. You know, scientists of their own accord.
I don't know who they are.
It doesn't matter whether you know who they're not. You're going to know who they are when you see them. Wait a few moments.
All right,
they will come apparent. There you go.
Hold on a second. We got to end this. This is, dude. Hold on a second. Do you think inside that vacuum chamber it's completely devoid of air, or do you think there's probably still a little bit of air in there?
There might be. I don't know. I'm not, how do you measure that? Of course, you assume it's not 100%.
Because there's no such thing as a perfect vacuum. In reality, we cannot create it devoid of matter or energy. So there's still going to be some air in there. How come those air molecules are still moving randomly? Yeah, so there's air in there moving freely and randomly and all not going down. So it doesn't matter what happens in that particular observation, not experiment.
And what is different in the videos that he will post?
I don't know. I don't know what he's showing. Either way, gravity's not having any effect on gas. Number one, what is gravity? Number two, it's moving freely and randomly in all directions. End of story. I don't care what happens between Colorado and Kansas and all the other nonsense that Tic Tac's brought in here today. Just feels like trolling, I guess, but it doesn't matter.
What Peter hang on. What Peter and Peter are proving is that objects of different weights in a vacuum land at different rates, not at the same time, which is what the Brian Cox tried to prove to us, but that was a piece of deception. Okay, that's all.
But how do I know their vacuum is?
Well, you again, if you show doubt, which is what you're showing already, you can actually buy the equipment or rent the equipment and conduct the observation tests for yourself. Okay, it's always up to you to do that. Thank you. Wow.
Wait, so
remember that
the best authority on anything is myself by doing the experiment.
Of course.
Is that's your explanation for all of it?
Well, of course. If I want to know whether the Earth is curving or not, after being lied to, being misinformed by my education, I must therefore
we're
go.
talking about vacuums now.
Well, we're talking about anything in life. If I've been misinformed, it will mean I have to double check it. I would have to double check it. Yeah, that's what I have to do. So please don't interrupt when I'm talking.
You do one experiment and you're satisfied with that. And you think, okay, I'm right. I understand.
Well, with the flat Earth, it wasn't one observation test. Several over 10. Well, I'm alive 64 years. So there's a lot of area I've covered in that time through my travels. So I do know the Earth is flat. Believe you me.
I'll happily watch those videos if you.
Yeah. I'm just currently in my library looking now. So please just allow me a few minutes to locate the material.
Cool. You must spend a lot of time with this if you have so many videos to go through.
Well, just allow me, because what I've got to do is go into my library. I've then got to copy the link, which I'm doing now, of the first one, and I'm now about to deliver that to the server. It's a bit convoluted, my method here. Unfortunately, it is what it is. Be patient, and it will get to you. Good things come to those who wait. Here's the first installment of the slam dunking. There's number 1. Please allow me to get number 2 up now. Thanks. Just one of those things, you know. I'm not in any hurry. There's number 2 for you. See, we look at everything, we flat earthers, because we're very interested. We want to know. There's number 3. In fact, there's going to be 5, actually. I did say 4. I'm going to give you a little bonus one as well.
Oh, damn. Okay. Well, I'm not going to watch them right now.
No, that's okay. Yeah, no. They're there for you. They're there for you to watch at your leisure, because that's the whole point of it. I'm not in any hurry here. I already know the Earth is flat and gravity doesn't exist the way it's been described anyway. So I have no problems. I'm not losing any sleep over this stuff. I've collected it for people who want to learn. For your benefit, I'm doing this. Actually, there might even be 6. I've made an error. Yeah, so there's a lot to it. It gets more and more.
Oh my God.
There's one more on top of that I've just found. Yeah. Okay, so it's covering the topic thoroughly. Peter and Peter did it thoroughly. And the reason they were so thorough was because in the comments, people were making comments that they weren't quite
something
satisfied.
about the wire.
Yeah, there were a number of things that they were complaining about. So they redid it. I like to give you the full story so you get to know the people and their integrity.
Oh my God, the bookmark isn't working.
Right, and here it is, the last one. I didn't notice one more. I've got to double check if that's related. But there you go, there's the 6 promised. There you go. Okay, all complete. I'm just checking there's one more, if that actually is related. Yeah, there's one more. Yeah. So there's 7 actually that I have from Pete and Pete.
Pete and Pete. Okay.
Yeah, good people. Good people. You check them out, you look what they do, and remember, everything they do, you can do. And you don't have to buy the equipment, you can actually rent the stuff. So if you really want to conduct your own.
I won't do that. I'm just curious.
Yeah, okay, yeah. Yeah.
How high quality was the vacuum in this experiment?
Well, again, you may have to ask them because I'm witnessing it.
Did you have like
very good?
Was it a barometer or what? Is it a barometer that he would need, or what measurement would he need to does he show this in here?
Yeah, they show all that in there. They show you the pump, and they show you the pump and the vacuum and it's been operated all the way around. Yeah, they show you all of that. What amount of vacuum they're pulling? It's all there documented for you. And if you go into the comments, there's more information in the comments as well. Sorry, in the description, there's more information for your digestion, for your digestion.
So he shows like this is a sufficient vacuum. Here's the barometer measurement or whatever.
Yes, there's a proper barometer gauge right there. You see it. Okay, remember.
Hey, Reductio.
Remember, hang on. If you have any queries, please go and ask Ben.
Reductio, what would it matter if it was an awesome vacuum or a shitty one? What would it matter?
If there's not a proper vacuum and you drop a feather in there, it's going to be air. There's going to be drag. It's just going to add more drag. So like,
and who cares? What does that have to do with anything? I'm sorry. What does that have to do with anything?
It would mean it doesn't contradict the like Einstein's laws of physics. It would literally just
Einstein's laws of physics. That's just basically geometry. So, what would that be contradicting in his geometry?
Well, he predicts that they would fall at the same rate.
No, he doesn't. Show me. I want to see the hypothesis. If you don't show it, I'm banning you. How about that?
Newton or what? Newton or did I say Einstein?
You don't even know which gravity you're going to appeal to, and you're asking about vacuums, thinking that someone's going to make a prediction. Are you out of your mind?
No.
Yeah, I think so.
Sorry, but
Maybe just take a
bit too
mute.
aggressive to be like that as well.
Is it too aggressive to ask somebody why they're asking questions about something and then telling me it's going to be a prediction? Yeah, that's a good question to ask since he doesn't even know what he's talking about at the moment.
Yeah, he's conflating the gravity components and that components.
That's fine. I'm just saying your tone of voice is a bit.
Well, it's sometimes
the tone police.
I don't mind their tone of voice. It's just they knew what I was saying. They were just being. I mean, you're being pedantic.
I don't know what you're saying. I don't know what you're saying, and I'm asking to make predictions. I want to see those predictions.
That globers who believe in gravity believe that objects will fall at the same rate, independent of mass.
You mentioned Einstein or Newton or whatever is going to make a prediction. I want to see the prediction.
Yeah.
I just want to mention that I put in the side chat at 36 minutes past the hour the Bremen drop tower observations.
Thank you.
So there's a lot of detail that I posted with that. That just offers evidence that the 9.8 meters per second is an average and not an infallible constant. But it's really irrelevant to the topic anyway.
Right. No, it's still but it is relevant actually because it's not. You're saying it's not an absolute. So here we're learning something else. It's not an absolute. It's an average.
Right, but it doesn't. Yeah, it doesn't curve or uncurve the Earth either way.
No.
But I think most people are just unaware that we don't always see a perfect 9.8 meters per second in a vacuum.
That's right. That's right. That's right. That's the beauty of it. The thing is, the idea that a heavy object and a light object will land at the same time in a vacuum has been debunked because it just goes against natural law. The heavy object will always hit the ground first. It's heavier. It's got to land on the ground first. It's just common sense. It's only because we've been duped with gravity. And then silly little the Ohio vacuum chamber, that BBC or whatever, it was the BBC, I think it was, that had Brian Cox in there, just pulling out a deception. That's all he done there. That vacuum chamber wasn't big enough to conduct such an observation test. That bowling ball didn't have its chance to reach its maximum drop velocity. But I'm sure if you made a vacuum chamber the size of the Twin Towers, 110-story high vacuum chamber like that now, and then drop your bowling ball and your feather, and you would witness natural law. And it's absurd that they would think that a feather can have the same drop velocity as a bowling ball. It's just ridiculous.
Hey, Jin.
Yeah.
If I fart in a vacuum, what will happen?
Oh, well, the gas will expand everywhere and you will foul that vacuum space.
Incorrect. No. You will die before you can fart.
Okay, yeah.
Listen, your whole body will be the fart.
That's right. You would expand, explode. But if you're in some kind of oxygen breathing equipment you got on and then you gassed up, well, then that's a different situation. But yeah, James is correct. You would expand and die in a vacuum.
And it's not just that you're gonna expand and die. You will die violently.
Well, actually, you'd be dead before that actually happens. You'd be dead within seconds. Within seconds you'd be dead. Yeah, and then your body continues to expand, but you're already dead. So it'd be a violent bang, but you won't notice that how violent it is.
But isn't that speculation because no one tried that yet?
Oh, what's his name? Has tried it. His name is LeBlanc, an astronaut from the Apollo team, and he stepped into the vacuum chamber, and within 1.7 seconds he was out, fell backwards like a tree. He said he remembered the saliva on his tongue was bubbling. Was the last thing he remembered. So it has been done, and an astronaut did collapse. And by the way, that vacuum chamber's value was nowhere near space. It was not even as high as one of the aeroplanes that we fly in. So it was a low altitude. That was what he was simulating, and the guy was already out. So it wasn't of any significance.
This guy, who said that there will be that we're speculating that you will die in the vacuum? Is that what he just said?
No, expand and explode.
Yeah.
Listen, your fluids will evaporate.
Yeah. Your blood.
You get that?
That's not the same as expanding.
That's entropy going on. That's entropy. That's outgassing. That's what's going on.
Well, you said expand and explode, not evaporate.
Yes, your body will expand. Yeah, your body will keep on expanding because the gases are trying to escape your body. That's what happens. You've got no pressure. You've lost the 14.7 psi pressure that's keeping you nice and comfortable. You remove that, and your body just wants to expand. That's what happens.
But why hasn't anyone proven that?
Well, why do you think?
Why don't you experiment that?
Why do you think? You can answer that one. Why don't you offer up your views?
So since you want to find out, let's put you in the vacuum chamber then.
In fact, Mark Sargent has put us a challenge for anyone to go into one of those vacuum chambers with the ordinary Apollo NASA suits, and let's see what happens to you. No one took up the challenge. Okay? Mark Sargent himself with somebody else. Let's go in there. Let's see what happens. No one took the challenge. There you are. Right. Forgot about that one, didn't you? Yes, Mark Sargent put the challenge out there.
I don't watch Mark Sargent, so
yeah, that's okay. Yeah, I know you don't. Yeah, so you wasn't aware of it, but the challenge is there anyway. Nevertheless, the challenge is there, still there today. See, we put our vacuums where our mouth is, and no one wants to take it on.
Why hasn't any flat earther tried it?
Well, we know what's going to happen, don't we? We already know. Well, we don't need to. We don't need to.
You don't get access to these chambers
because we already know. We already know it's for the globers.
Because you wouldn't get the access, so it wouldn't work anyway.
No, friend. Remember what I asked you about what the point of this is even supposed to be? What is the point of this?
Yes. Great question.
He said he knew. How do you know if you didn't try?
No, what are we talking about? Are we talking about gas pressure? Gravity? What are you talking about?
About expanding and exploding in a vacuum.
Yeah, that's entropy, gas pressure. Yeah, entropy.
So you
that's what gas does.
Because law says that, so you assume it works, but you never tried it.
No, it does work. No. Where do you think that we got the? Hold on, Jen. Where do you think that we got the law from, dude? I mean, my goodness. What are these questions?
But you want to experiment, right?
No, because no, my gosh. No, because we observe this to happen. That's why it's a law. This is what happens. It's not an assumption.
Vacuum.
Are we talking about the topic or arguing whether or not someone's lungs are going to explode out of their chest or all of the oxygen is going to get sucked out of their body one way or the other? The gas with the body. What are we talking about? Do you want to get, you just want to stay hyper specific on everybody will be turned into a prune as soon as they enter a vacuum chamber? Is that what you want to argue about?
No, I want to argue about his words. He knows without having done it.
Okay, so Jen, do me a favor. Don't talk about things like what will happen to someone's body inside a vacuum chamber, because this guy here is just going to get super hyper focused on that and then ask dumb questions about it the rest of the time he's in here.
Yeah, it's silly. Hey, listen, we were just replying to a question that was asked. And the demonstration that happened with the astronaut in the vacuum is the demonstration that what will happen.
He didn't explode and die.
No, because he was rescued. He was released.
He had to be rescued.
Yeah.
And there was an accident in a field rig where there was a pressure differential with divers, and the divers were vaginalized the other side of the chamber.
There we are.
What?
Their bodies were turned like a sock. You know, like when you switch the sock one side to the other.
Yeah, inside out.
Yeah, that's what happened. All of their fluids, all of their body parts, everything was at the other side of the chamber.
So they were dead.
Obviously.
There we are.
Yeah, you think that there wasn't like the body exploding to the other side, all the fluids getting out, you know?
There we are. So there's examples. There we are.
That was a pressure differential, not a vacuum, though. Maybe watch a little science fiction films, because that's where they explode and expand.
A pressure differential, yeah.
That's normal.
Still not proving the Earth is a globe, though. Don't forget that. All these questions are not leading to proving a globe exists.
No, they're just leading to conversation.
Yeah, it proves that natural law rules supreme.
So you don't want to converse here about anything? You just want to...
No. I like to converse. I love conversing. That's what we're doing. We're conversing. And you are asking your questions and we're responding. I love all that.
We've been conversing. What are you talking about? This whole time people have been conversing. What do you mean you want to
Yeah, we've supplied you with a lot of material. I have supplied you with a lot of material.
Yeah, that's cool. I'm not saying it. That's cool.
Not flat earthers. Focus on the topic.
There you go. You see. So I guess not conversation.
No, we are. We are definitely focused on the topic matter, and sometimes vacuum of space comes up because the globers like to look up into the stars all the time, don't they? The sun, the moon, stars, planets.
This conversation has been going on. This conversation has been going on 24/7 for 10 years, and you're asking if we want to. And you're asking if we want to converse.
Non-stop, 24/7. Brilliant.
You will talk to people like me another 10 years yet.
We will? Yeah. No, we are. No, we won't. We will. We've been talking to you.
Not just me. I'm not the only one.
No, everyone. That'll be all the globers.
Listen, past, present, and future.
Yeah. We're now in the 11th year.
Are you just looking to trigger people or something? Is that are you like a noob at this?
Noob at what? I'm not trying anything.
Trying to trigger people, trying to kind of like sea lion.
Well, why would you even assume that?
Because that's what you've been doing.
Maybe I'm not triggering you. You're the first one who brings that up.
So do you want to converse about the topic of the VC? Do you want to converse about the topic? Do you want to converse?
Jin, not all these Jin, the Peter and Pete stuff, not all of it's in a vacuum, right? Like some of this is just like random shit at a beach.
That's correct. No, it's not random shit at the beach. It's giving you the difference between Earth's atmos and vacuum. Okay, yeah. So the material that I posted to you deals with the vacuum chamber, vacuum tubes, and also deals with Earth's air. So you get a good round understanding. I like to cover all my bases. That's why I gave you that material. Don't complain. Please don't complain that you've got material, because it's all related. Drop tests in Earth's atmos, drop tests in vacuum. I think they're related there. Okay? I've done my best for you. Don't complain, please.
He's complaining about the data. Just go and do it yourself and check the data.
Yeah, and it's all good data.
I don't have a huge vacuum chamber, unfortunately.
Nobody was talking to you at that moment. Someone else brought up a point about the video that he was watching. Why are you replying to that?
Because he's probably thinking the same thing.
Well, in this case, these were vacuum tubes that they used, so that made it more affordable to the average man and woman on the street. And you can achieve the vacuum required to prove whether or not heavy objects fall at different rates or not. Heavy and lighter objects. Okay? In a vacuum.
Daddy, why you are complaining, Daddy?
Oh, I was complaining because like a lot of these experiments aren't precise. The one that's linked earlier, the Bremen Tower or whatever.
Yeah, Daddy, why are you saying that there was random shit? You think they randomly decided to go to these different locations to test different pressures? You think that was like random?
I was just saying, like, you clearly got to stop the people from posting clearly already debunked shit, like the Bremen Tower, the snap out of the elastic effects, like that was debunked years ago. You gotta like call out the bad stuff too, right?
Debunk? You're talking about the globe, right? When you're talking about debunking, the globe was debunked, right?
You guys believe that the Bremen drop tower was good? Was a good experiment?
Wasn't an experiment.
Right. It's an observation.
So you're correct. It's not an experiment. Debate Daddy, you are correct. It's not an experiment.
Okay, but there's nothing useful we can get from this other than if you have an elastic effect. Like the contraption that held the objects in place was the cause for the discrepancy, right? Like we all agree there?
No, we're not all going to agree. The gravitational, quote unquote, gravitational constant is really irrelevant. I mean, we all agree that we can observe that most things fall if you pick them up, that they will seek equilibrium. So I'm really not sure what the point is here with that, because that doesn't prove or disprove the surface of the Earth being curved.
Well, I don't know why we're pivoting, but my point was, we were talking about the Bremen drop experiment. Or you don't want to call it an experiment, fine, but
well, it's not an experiment by definition.
It's not repeatable if you change the mechanism by which the objects are like held down.
Okay, well, if you look at 38 minutes past the hour, you should read that. But if you want to say something is debunked, sorry.
No, sorry, I find it quite funny how you say like 38 minutes past the hour. So it's I've never
just because people are in different time zones. Yeah, people are in different time zones, so.
Yeah, no, carry on.
Hey, noob, can you stop being a noob on everything everybody says? Can you stop?
What is your problem with me?
No, what is your problem? Because the lady's saying something and you are complaining about what she's saying.
No, I didn't complain.
You said, I mean, you're finding it funny that she said certain time past the hour.
That's not complaining.
Like you said, so can you stop being a noob?
More than he did.
Exactly. I think
Can you
you're
stop being a noob?
You have a problem with me.
Can you stop being a noob? Just stop being a noob. You stop being a noob.
You're the one being triggered for some reason.
No, just stop being a noob. Can you do that?
Can you shut up?
All right, you'll shut up. Can you shut up?
Can I ask a question real quick? I want to ask Debate Daddy a question.
Sure.
So, like I said, we can all agree that this is what we generally observe, right? Except for some cases, like with gases or etc. Correct?
What is what we generally observe?
We generally observe a downward vector for objects within their medium if they're denser than the medium. Correct? I mean, down as in really being a flat Earth term, because with a globe, you don't really have down, you just have inward.
I don't know how it would work on a flat. Yeah, I guess.
Okay. So all I'm saying is we all observe the same things, right? The question becomes, what is the causal mechanism, right? And so if you want to claim that the bending and warping of space-time is the causal mechanism, then we have to see evidence of that. So we need to see an actual scientific experiment where gravity is isolated to prove that it's the causal mechanism. And we don't have that. So claims without evidence are rightfully discarded, right? No one argues the effect that we see. What we argue is a cause without empirical proof. And
I think with the Bremen Tower, we are arguing like what we're seeing is the elastic band effect, and you guys are saying, well, no, that just disproves gravity, which is like crazy.
No, that's not disproving gravity. Nobody said that. That would show that the 9.8 is an average. That would just disprove the constant, right? Doesn't disprove the effect of things falling.
I think
gravity as a. Are you talking about specific gravity, or are you talking about big G gravity? Because nobody argues specific gravity. We all agree on that.
You agree we can derive little g, right?
Yes.
Okay, but we can
as
only
a function
derive
of. No, but we're talking about big G here, right? We're not discussing specific gravity. We obviously observe things moving in accordance to density and buoyancy. That's not debatable. So if you want to claim that things are falling, if you want to claim things are falling because of the bending and warping of space-time, well, that's something that you would have to bring the evidence for.
Well, I mean, we're not there yet. Like with respect to little G,
we are there. We are absolutely there. And I'm not going to be pulled off into these. I'm not going to be pulled off into the rabbit trails because I know how you work and I've watched you. But so let's just cut through all that and just get to the point. If you want to claim that Einsteinian gravity exists, then you're going to have to prove it.
Well, I thought we were talking about Newton. I didn't think we were talking about.
I'm sorry. So you reject Einsteinian gravity? Is that it? Which theory do you ascribe to? I know there's like 80. So you just pick one, and then there's like 80 theories of gravity. So can you just pick the one you like and then provide the evidence to support it?
What are the 80 theories of gravity?
I don't know. Just Google it. Look up theories of gravity. I mean, I think Wiki has a page listing them. I mean, you realize none of this is proven, right? There's no
as far as I know,
experiment
it's like extremely well proven. But you're like the experiment. We can't even agree about the Bremen Tower experiment.
Stop. You just said it's extremely well proven.
Yeah.
But yet you have no experiment to prove that. You don't even know which theory of gravity you ascribe to, but you're claiming it's proven. So how is that?
Say something.
As far as I know, Newton could derive. We could derive little g with Newton, right?
Okay, I don't care about derivations. I'm caring about evidence.
Well, that's
so. Can you post No, that's not
what
how
proof means,
we can
doesn't
calculate.
it?
No, we need to. We don't need to calculate. We need to show that this is the cause for the effect, right?
You cannot debate the cause of the gravity with Newton's theory of gravity, because Newton's one is just a description of the effects of gravity, but not about the cause. The one about the cause is Einsteinian theory of gravity, that is about the curve of space-time, and there are experiments that support that.
Okay,
because
Santiago, can you just hold up a second? Because I mean, I understand what you're saying, but I think it may be confusing our other friend here.
I think we're operating at this with far different standards, like with the Bramandrup experiment. Like we agree.
Bramandrup experiment is not proof or disproof of Einsteinian gravity. No one is claiming it is.
Just for the sake of this, like I don't know enough about like the warping of space-time, but I mean, like when we're talking about like experiments like this, we're not talking about the warping of space-time. We're talking about Newton, right?
No. Einstein. Well, so you've decided that you're going with Newtonian gravity.
Can I interrupt for a moment? The sea lioning is getting kind of obnoxious, and the upward inflection when we ask the question right, every time we don't know what we're talking about, is just getting old. So if we can't stay on one point for a prolonged amount of time and get to the end of it, then I don't see any reason for Reductio or Jesse or even the other guy to be in here. Like, we can talk to genuine people. Maybe this other dude that just jumped in about Einstein, maybe we can talk to him. But I see no reason to talk to the sea lions right. Yeah, let's not talk to the sea lions. Let's
talk to Santiago. Yeah.
Maybe Genesis should talk to Santiago. Hey, Santiago. Thanks for being patient.
What I was about to say is that there are experiments that shows that if you put a clock in the top of Everest and you keep other clock in the surface, after some time you find like milli or microseconds desynchronization between those clocks. So that's proving general relativity, because gravity is different between some point between the surface and the top. So it proves that the curve of space-time shows that it is real. So, and that's unproven experiment.
Have you isolated all of the variables to determine that? Oh, someone was going to reply. Go.
Yeah, it's experiment. Obviously, the desynchronization of clocks can be caused by a lot of causes, like some other errors, but the experiments have not been done once, but multiple times.
Okay, show us one of these experiments. They move the clock at the speed of light, please.
Speed of light? No, that's special relativity. I'm talking about general relativity that...
Okay, so the bending and warping of space-time. When have you observed the bending and warping of space-time, please?
You cannot observe it because it is a space-time. Like it's like the electromagnetism. You cannot observe it, but you can feel it, right? You can place two magnets. And
how do I observe it? How do I observe it?
Okay, the gravity is a force that is a lot of weaker than electromagnetism. So to really find significant differences, you need to go to other planets, and obviously when you have an experiment that is done on the Earth, the variations will not be that high, but they exist. And yeah, the experiment of
that was just a bunch of baseless assertions you just made.
No, but those are real.
You're telling me that you apparently have to go to a space vacuum and do this on another planet, which is begging the question.
You can do it
on Earth. You can. Okay, well, how do you do it?
Santiago, how do you do it? To tell you though that if you wanna like talk about something that is happening, you have to show it happening, not just say that is happening in a place that you cannot go and test any of that stuff that you're talking about.
Okay, but yeah, that's it. I don't remember the names, but those experiments are real. Yeah, that's not bullshit.
Wait a minute. You don't know the name of the experiment. What was done? You don't know who, but you swear it's real. Bro, come on, help me out with something. Give me something.
Okay, I'll give you something. Let me take a minute.
Santiago, have you considered the surface of the Earth? Have you checked on that and tested if it's curving or not?
Can I do that? Because as a like normal person, the most high you can go is in a plane, and in a plane you don't get to the necessary altitude to see the Earth curvature.
Oh, you can definitely go to the necessary altitude. It's on the floor,
Yeah,
the floor level.
I've not done it. Like, yeah, you can see the Red Bull guy that got almost to the space, and there are these curvatures.
Santiago, real quick. If you want to measure something, do you go to that thing or you go away from the thing to measure it?
Depending, like if you need to see the curvature of Earth, you need to get like away from the Earth, not near of it, because you cannot see the curvature if you are near of the Earth.
Okay, I'm gonna ask you again. You know, measurement, right? Measuring.
Yeah, but you need to. But
you're
there
saying
are
that
sometimes
you
that
have
you need to be away because you need to see the whole thing, not just a fraction of it.
It doesn't matter how far you go out. Santiago, think about this logically. Santiago, think about this logically. You cannot go further away of anything of the Earth that you're gonna see the whole thing. There's no position that you can go to that you can see the whole thing, Santiago.
Why? Explain me that.
Do you get it?
Why cannot I get away from the Earth and see the whole Earth? Why?
Because you can only see one side of it. You can't see the other side.
Obviously, because
obviously, yeah, obviously. Obvious, huh?
Yeah, but the same things happen with a
as
ball.
obvious as it is.
Can you see the
obvious as it is? You made the baseless assertion that you can do that.
Tell me this. You pick a soccer ball. You can see the part of behind and the front at the same time. You cannot do that. Even it's
soccer balls.
Yeah,
so
but
we can
justify me. No. You gave me the argument that I cannot see something that is behind at the front at the same time, but those happens with small objects also, and those objects they are round, not plane.
Okay, so how do we know that the object is round? Right, we can tangibly grab it. And we can measure it, and we can tell it's round, right?
But that argument doesn't make sense because that's not the justification.
Remember, Santiago, I was replying to your nonsense argument that you can see the whole thing. Remember?
Another nonsense argument that you are telling me that there are things that you cannot see the front and the behind, and the Earth cannot be round because of that, but that also happens with a small object. That doesn't make any sense.
Santiago, are you claiming that the Earth is round? Is that what you're saying?
Yeah, spherical.
Oh, spherical. Okay, spherical. So the Earth will be curving to a specific rate, right? Do you know that rate that the Earth will be curving, be this sphere that you claim it is?
Obviously, it is. So as it is bigger, is a smaller rate. So much smaller than.
What is the rate? What is the rate that the Earth is curving?
You need to get the diameter of the Earth, but you are not gonna believe the Earth has a diameter because you think it is not spherical. So I cannot argue with that because you don't assume some data that has been proven, so you won't believe any argument that it becomes from those others. So
Santiago, should if about the Earth, right? Should I believe what you said about the Earth, or should I go check the Earth and go by the Earth?
Okay. Repeat that, please.
Santiago, you said that I don't believe something that you argue about, right? That I'm not gonna believe what you say, right? About the Earth. So, if I want to know something about the Earth, should I check the Earth, or should I just listen to you saying things about the Earth?
No, you need to listen to arguments, not me because it's me.
So, Santiago, you and I, can we go check the Earth? Can we check the Earth? You and me?
Yeah, so if we had the money, we could like go to those.
Go to the store, buy some measurement devices, tools, and maybe a water level.
Well, you can, you know, the Coriolis effect, like you.
Wait, chill. Don't run. Just stay with me. Don't run away from me.
Okay, but you know about, you're telling me if we can check it. You are telling me if we can go to the store and check if the Earth is round. Do you believe in the magnetic field of the Earth? Do you believe
Santiago,
that
we can go to the magnetic field? Sure, we can go there, but let's keep you to your sentence.
No. What I'm telling you, because I am talking about the magnetic field, not like going to other topic. No, it's because you told me if we can go to the store and buy things to test if the Earth
test the Earth, yeah. Test the Earth. We can test the Earth, right?
And
we can also devise.
But
Santiago, we can also devise devices. Santiago, we can also devise like lasers and stuff to also measure the surface of the Earth.
Why are you discarding the ones I'm talking about? Literal.
What? I'm not discarding anything. What am I discarding?
The magnetic field. It's an inherent.
I'm not discarding it. Do you know what the magnetic field is? What does that prove? The magnetic field, because you know that magnetic fields work on a flat surface.
How would it work there?
You know that the pharmaceutical industry, the medical industry, they use listen. Hello. They use two magnets, right? They grab two magnets. They put it above a flat table, and on that table they put a patient, and they use the magnets to create a magnetic field in the body of the patient and to guide a tool inside the body of the patient.
Yeah, I know, but how would the Earth have a magnetic
and you know
field?
what happened? And what's happening on the magnetic field? That is on a flat table. That is happening.
Yeah, literally there are currents of potential difference between electrons that are causing that magnetic field.
Okay, so your magnetic field idea doesn't prove that you're standing on a globe, does it?
Why not? Why there would be a
because
magnetic
I can
field
show
in
you a magnetic field on a flat table.
Yeah, you can show me in a flat table because there are no gravity enough strong to make the table spherical because it has really appreciable gravity. But if you go to large objects like the Earth itself, it becomes spherical because of gravity.
Santiago, let's come back to the things that we can test and check because you're going to gravity and you probably don't get Santiago. You don't even know what that even means.
Okay, the gravity is the curve of space-time, but okay, let's not talk about it. Let's talk about things you can prove.
Let's talk about. Let's go back to the topic of the VC, right?
But how would you have like a magnetic field in a flat Earth? Where that come from? There are a lot of metals inside of the surface, and just like magic, and they are all
Santiago, now you're going into your imagination. Santiago. Now you're going into your head and trying to imagine things that nobody's claiming at the moment. Santiago, just
but you have no.
Santiago, let's stick to reality and let's check reality, Santiago. Let's forget about the fantasy stuff.
Yeah. Okay, so how would we have a magnetic field in a flat Earth? It's like a giant magnet
so listen, Santiago. Listen. I'm gonna tell you. I'm gonna reply to your question just to entertain it. Okay. We measured the Earth. Okay. We measured the Earth, and it measures flat, horizontal, not curving, and then we can also. But listen. While we measure the Earth, we can hold a compass, and we see that the compass interacts with the magnetic field. And while you're using the compass, you can also pull out the tape measure. You can pull out the laser and measure the Earth as a non-curving horizontal.
Okay.
Okay.
First of all, if we had a compass in a flat Earth, and let's suppose the magnetic
you know the
field
compass. You know the compass is horizontal. You have to use the horizontal.
No, it works. Yeah. It works horizontal.
Yeah. First you say no, then you say yeah. Which one is it, Santiago?
Yeah, because I thought about you said, and that's right. You
okay?
need to use it horizontally.
So compass work on a flat Earth. Thank you, Santiago.
No, but okay.
Oh no.
How would be the magnetic field in a flat Earth? How would it be?
Okay.
Or how it is, because the Earth is flat.
You're asking about the mechanisms
that causes
of the construct of the whole Earth, and how is that constructed? That you asking?
Yeah, in a flat Earth. Yeah.
You don't know that, and nobody knows that. I could give you speculations about that, but what we can do.
Hey, Gemsy, Santiago, pull up for a second. Gemsy, why don't you explain to this nice gentleman how it's a falsity of his heliocentric model and how the claimed magnetic fields work in his system, and we can explain to him how it should not work.
Tell him.
That might be easier.
Tell him.
Santiago, in your ball model, the sphere model, how do you get the magnetic fields?
You were going to explain me, but okay. You get it by the core of the Earth that is made of iron and other metals that are ferromagnetic, so that causes it.
Excellent. Have you ever heard of a thing called the Curie point?
Curie points? Like, explain me, please.
As in, Madame Curie. What it is
like
when metals,
stuff, right?
when metals get heated up, so iron, like you said, in the core, it's supposed to be liquid, yes? When they get heated up, they get past a certain point. And once they get past that certain temperature point, they lose their magnetic properties. So if you've got liquid iron floating around, that's non-magnetic. That's why the ball, that's one of the reasons why the ball model and you telling us about magnets and making it such an important thing is not so important.
Yeah, Santiago, what you think about the magnetic field, it's just an imaginary thing that you think it works because you read something and you saw a cartoon and a depiction and you believe that that's the way it works. But when you actually check the check and balances, it doesn't work in reality. You know why, Santiago? Because you're saying that
you got
the core of the Earth, you don't even know what that is, and you're making claims about it.
The core of the Earth is made of iron, and that's in the core, literally.
How far is the core of the Earth? How far is it?
No, but he talked about first the Curie points, like something that melts and loses its magnetic field.
Excellent.
It's really melted.
Santiago.
Okay.
The Curie point happens before iron becomes a liquid. Now you're talking about liquid iron. It's already lost its magnetic properties before it even gets to a liquid.
Yeah, because so
you agree with me? Listen, you agree with me that it's like shut up. You agree with me then that it's already lost its magnet. Yeah, you're the one who should not be talking. You should be listening. This is not. Yeah, I'm telling you to shut up because you should not be talking. Listen, my friend, I'm trying to help you. You're not helping yourself. If the magnetic properties are already gone, non-existent, before it becomes a liquid, how are you going to have magnetic properties whilst it's a liquid? Please enlighten me. Unless you know something I don't know. Now, to add insult to injury, you're claiming all of these wonderful things that happen underground. The furthest we've ever been down is 7.4 miles. Anything beyond that is pure speculation.
Santiago, what he's telling you right now is something that you should know. He just told you, you're just learning about the Curie point. You didn't know that. Now you learn about that. Now, based on the other allegations you were making, the core of the Earth, did you know that man has only dug about 7.8 miles below the surface? You know that, Santiago? Santi. I guess you broke him down, Mike Drix.
Oh, he's probably having a cry because he got told to shut up and listen.
No, he thought he was here to educate us.
Santi,
there's no core. Period. Right.
Santi,
you don't
the core
know what's in them underneath there,
my
those distances. Right. He doesn't. There is no telling what is there. He's gone. So he's done a dive.
I think his internet dropped out.
Maybe.
Sorry, guys, I was kind of charged from the last conversations when those debate daddy and the noob. So I came at Santiago kind of with a heavy tone, kinda. But then Matrix superseded my tone. Santiago said he's coming back.
Problem we've got now, Jamsy, is he's going to do a reset and he's going to continue on from his magnetic fields. A whole lot of that he didn't hear. I do find it quite interesting though, when they come in here. It's always about, how does your stuff work? And they're in our face about how our stuff works. And they haven't even checked their own stuff yet. That's what I've always been amazed by. Maybe if a lot of you guys that are out in the YouTube land that are listening to this, maybe if you just look into your own stuff first, you'll probably understand why flat earthers are flat earthers.
Well, we may have more than one YouTube audience right now because we have Victor YouTube, who is a YouTuber. He could be streaming this right now.
Howdy, Victor. How's it going, mate?
Hello. Hello, Victor. What is your vector?
Hello, Victor. Are you being a shy YouTuber? Can't be shy and be a YouTuber. You gotta get it. Come on, Victor. All right, since Santiago is taking a break.
No. My connection is terrible, man. Sorry.
Well, your sound it's pretty good though. So I guess your connection is not as bad as the Australians and the Japan.
Yeah, it's like from Colombia, third world. So yeah, it's what really bad.
You're in Colombia, Santiago, or Medellin? I've been to Medellin and other areas.
No, Cali.
Cali,
Colombia.
So you're in the on the coast. You're in the Caribbean Sea.
No, this is nearer to Pacific Ocean.
Oh, the Pacific. Sorry, yeah, my bad. Yeah.
Yeah.
Awesome.
Yeah. Well, what are you talking about? Curry Point?
The Curry Point. He was touching with you. I think Santiago. Do you have me on? Do you have this conversation in speaker? ¿Lo tienes en speaker?
No.
Okay, because I thought I was hearing myself twice. The Curry Point that you were claiming the core of the Earth is this thing that is causing the magnetic fields, right? Based on the belief of the globe idea.
Yeah, but we don't have to confuse like ferromagnetism caused by the magnet itself because of the material being ferromagnetic, but the electromagnetism it's causing.
Santiago, before you confuse yourself a little more, let me interrupt you right there. Santiago, this belief of the core of the Earth is based on baseless assertion, baseless idea, something that hasn't been shown, discovered, demonstrated, verified. The core of the Earth that you picture in your mind doesn't exist.
Thank you.
Do you want me to give you an idea how you know that? How you can know that you don't know? Santiago, do you want to know how I know that you don't know and nobody knows about the core of the Earth? You want to know how? Maybe he's busy again. His connection might be dropping. He's in Cali.
I was going to say, that's a shame he's dropped out again. That electromagnetic core thing sounded like hours of airtime.
Yeah, his internet drops. I mean, you already killed it with the curry point, obviously, but that's like we are in the core, in the melted core of the earth already. Like we going there, right, to Narnia. Narnia is not as pretty as he thought. It doesn't work the way he thinks. So we cannot go to Narnia. That's the point.
Yeah, but
It doesn't
Jamesy,
exist.
the Artemis Aslan was on the TV.
You just wanna
I couldn't do it. I got him too.
But Aslan speaks Spanish. I remember he was speaking Spanish. Now he speaks English. I know Aslan speaks Spanish.
There's all these Italian kids out there going, "No, he doesn't. He speaks Italian."
Well, imagine the Chinese kids, what they gotta say about it. Santiago, welcome back
again.
Are you moving? Are you driving, Santiago, or something?
No, just in my house, but I don't know what's happening. I gotta call my company maybe.
Yeah, that happens. You're not the only person that this happens. Connections are kind of tricky, especially these hours of the day that a lot of people are in the internet just using it.
Yeah.
But Santiago, do you know about that? You were making claims about the core of the Earth. Isn't the core like 3,959 miles from the surface? Right?
Yeah.
Yeah. Do you know that man has only made the deepest hole ever made by men?
Yeah, it was made by the Soviets. Yeah.
Yeah, 7.8 miles.
Yeah, but because of the temperature, you cannot go.
What was that?
Because the temperature, you cannot go deeper. Because your tools too big get melted. So.
Okay, Santiago. So how do anyone makes any assertions about what's beyond those points?
Yeah. Because okay, like for example, we have, I don't know how the term in English, but what causes earthquakes, like tectonic plates. I don't know how to say it, but yeah, things that are moving like in the behind the ground that causes earthquakes. That they
Santiago, this is, you know what this is called? This is called plane stacking.
Plane stacking, okay, yeah, placas tectónicas in Spanish, yeah, but plane stacking and those ones you cannot get there also, but they are.
Santiago, listen, the temperature didn't work for you, so the core of the Earth doesn't work for you. Now you're gonna claim something different. You cannot demonstrate the other two. Right, how the magnetic field work, the magnetic field works. You cannot demonstrate that. You cannot demonstrate the core of the Earth. You cannot go beyond 7.8 miles. You cannot demonstrate any of that. And are you claiming something else on top of all of that you cannot show, demonstrate, verify?
But you cannot also get there. But they are real because they are causing earthquake, right?
Earthquakes do happen. The cause of the earthquakes is an idea in your mind that has been programmed, and now you're just like the core was programmed. Because the core of the Earth, you saw it in a book, right? In a cartoon. That's where you saw it. The core of the Earth. It's a cartoon. Think about it. What do you see in your mind when you think about the core of the Earth? Does it look like coloring, like crayons? Orange, red.
It's melted, so you need to go to.
It's like something in your imagination that is like not clear because. I mean, what do you see? It's a cartoon, and now you're gonna claim something on top of that cartoon and something else that you saw from another cartoon, and you claim stacking.
But you are
That's why-
claiming
that's-
that
Santiago,
Hey.
listen, Santiago, this is very important. This is why I wanted to keep you in the real East level. You know, the place that you and I can operate at, the place
Yeah,
that
but
we can
the problem with that is
test,
that
operate on.
the problem with that is that you are saying that we cannot like have other mechanisms to test something that are beyond our senses, because if you cannot see, hear, or
I'm not
sense
saying that.
something,
not saying
that's
that.
not real. You are
No, I'm
saying
not
that you cannot see the core of the earth, so that's not real.
No. We can definitely test a lot of things with tools that go beyond our senses. We can definitely do that. And come to find out, a lot of the times we test things with tools actually demonstrate that our senses are correct in many ways, okay? But what I'm telling you is that you cannot, there is stuff that is unknown, and there is limitations to the things that we actually know. There are things that are actually unknown, like what's beyond 7.8 miles below the surface of the Earth.
So you cannot study beyond that because we cannot get there. That's what you're saying.
How else will you know what's beyond? How can you verify what's below those points? If no one has done it ever, how can you make an assertion of what's below?
Because maybe you can detect some signals from the Earth. Okay, yeah, the problem is more philosophical, because if we detect like with X-rays, yeah.
No,
so
let's not go philosophical, bro. Let's take objective on the surface. Let's go back to the root.
But you don't know what I'm going to say.
Of the conversation.
Wait a little. I won't go to other topic. Just it was.
You're still running away from the topic that I've been trying to keep you at, bro. The surface of the Earth.
Yeah, we're talking about.
Hold on, brothers. Listen, you guys are backfeeding bad. So one of you needs to fix your setup.
What?
I think he might have me on speaker. Is your phone on speaker, Santi?
Yeah.
Let me like my earphones like. Not me, right?
You have them in full volume or something, so whatever whatever sound you're getting from the headset is feeding back.
Now is like low volume, so it shouldn't be happening anymore.
Okay. All right, thanks, Santi.
Yeah, sounds better. Go ahead.
Okay, thank
you. So Santi, let's start at the surface of the Earth, the thing that we can actually test and verify, and maybe we can move on from there to other places, because if we cannot figure out this area that we can check and test and operate across, if we can figure that out, how can we figure out anything else?
Because there are other mechanisms. It's not like you only can prove something because you reach there, like digging so deep in the earth so that you can see it or sense it, because you can sense other effects that happens. Right? For example, we have X-rays, right? And you can sense the waves of the earth. And the problem is that if I tell to you that there are waves in the earth that are signals that are coming from deep in the earth, I cannot tell you that that's because there are other like layers of the earth more deep, because you
we have a tool So we have a tool, a reader that detects vibrations and or signals that you're saying, and we gather this data, and then you grab this data and add it to the cartoon of the globe Earth, and you're saying, look, this data only works in this cartoon that I got right here. Is that because? Because you're saying, listen, you're saying that this data that you're receiving in the tool is coming from the core of the Earth that you haven't verified. It's a big problem, Santiago.
But no, it's the opposite. We had the cartoon before, and we tell, oh, this data is from this cartoon. No, that cartoon that you are saying is made because it is the only way that data fits. And so
it's the only way.
How would you? Okay,
Santiago, do you know that the tools that detects all of this that you're talking about, the cartoon globe Earth comes before tools,
but not as equal. Maybe you had globe Earth.
Santi, the globe Earth is way older than the tools that you're saying you're using to detect the signals.
Yeah, the globe Earth, like spherical, in the surface, but nobody made cartoon of the Earth, like inside the Earth, before we got that data.
Okay, perfect, Santiago. So now we have this data, right? And you have an idea, and you kind of making these, grabbing these two sets of data, which is the globe idea and the signals that you're receiving and reading on the tools, right? And you mixing those two, right? Now, can we test the first data? Let's say the globe Earth. The Earth is curving. Can we should be able to test that, right? Because we are standing on the Earth, right?
Yeah.
Okay, so the Earth data is telling you that the surface of the Earth and the waters across are curving, right? Have a drop rate to a specific ratio that will give you the globe, the image that you think the Earth is, right?
Yes.
Yeah. So when we drop the data and put the paper, you got the data on a book or you write it down on a paper. It has the diameter of this size, and it has a circumference of this size, and has a radius, core of the Earth that you mentioned, 3,959 miles, right? We have that on paper. Now we close the book of the data, and we're gonna go test for that. We go to the Earth, and maybe a good test site will be the waters of the Earth, right?
To go deeper in the Earth yet. Maybe we have them in the future.
No, deeper on the Earth. Across the surface, Santiago. Across the surface. Remember,
we have technology in ground. We can prove it in ground. Here, near where I am, in the equator. That's the point I wanted to make with the magnetic field at first, but it pivoted to something else. But there is like...
Santiago, can you follow what I'm saying? Santiago, can you follow me to logical conclusions? Because you're jumping away from what I'm saying to something else. Can you concentrate on what I'm saying?
Okay. Tell me.
Okay. So, allegedly, what you learned, the set of data about the Earth curving and being a ball, that's the set of data, the data set that you got, right? This information. Now we're gonna go test for that on the surface, because the surface must be curving for it to be this ball that you saw on the depiction. So when we go to the surface of the Earth, and most of it is what? You remember you mentioned the Pacific Ocean? You know the Pacific Ocean is really big, right? So most of the surface of the Earth is water, right?
Yeah, yes, it is.
Yeah, so there's many lakes, many bodies of water, and we can test the surface of bodies of water to see if the curvature, the data that you saw in the depictions is correct.
But that's not related. The things related to the, the core of the Earth are not related with the marine data. That's totally different things.
No, yeah, you're correct. Those are different things. That's what I'm trying to tell you. That for now, we're gonna test the geometry of the Earth, geometría.
Yeah, for now, okay, but there are other ways. You are only making some points that with the tools that we have right now, and
Listen,
without
Santiago,
going.
what I'm telling you is so practically necessary that the militaries of the world, the militaries of Colombia, United States, and all the countries, they utilize this information to operate across the surface of the Earth, because everyone operates across the surface of the Earth. Everything you've done in your whole life has never been on the core of the Earth. You have never done anything that has any relation to the core of the Earth. Everything you've done is on the surface.
Yeah.
Okay, Sandy, perfect, right? So, when we want to test if the surface is moving, we can use lasers, right? We can set up a laser at the shore of the lake, right, or a body of water, and we can shoot this laser from point A to point B. And if the surface of the Earth is dropping, we will measure a drop over the distance, and the laser will not hit the target at the other side, because the target will be below, right, at the drop, at the curvature, behind the curvature, right? Santiago, you get it?
Yeah, I get it.
Yeah. Yeah.
But-
So when we conduct this test, come to find out that the laser hits the target of the other side.
Yeah, but that's not true, because if you put something really far away, the laser won't get it. If you like put the laser like totally, I don't know how to say it.
Santiago, listen, I'm gonna stop you right there real quick. You said that that's not truth. I'm gonna post for you multiple examples of laser tests that you can at your own leisure look, done by PhD experts. I mean, people in the field, like, subject matter experts that actually do this.
Yeah, but I can tell you the same by the other side, right? Like, shows that the laser doesn't follow the curvature of the Earth, and it just don't reach the object that is too far away because the Earth is curved.
Excellent. Show us that, please.
Santi, look, I'm gonna post for you the laser test.
Got it covered, Jensi.
Yeah. I'm just gonna post this for him so he can.
Jensi, they're already there.
Oh, they're already there. Yeah. I copy paste from you actually earlier today. Look, Santiago, so you remember the data that we were talking about? The data that you receive and you saw in the book, Earth is a globe and this is the depiction of it. You learned that in school, didn't you, Santi?
Yeah.
Okay, so now that you have another set of data that might show you something different from what you saw in the book, and do you think an honest person that is trying to learn will look at the data even if it goes contrary to what they believe at the moment?
Yeah.
And consider the new data. Will you consider new information, Santiago?
Yeah, of course.
Okay, so people in the text chat have been posting related information to the topic at hand for you.
Yeah, okay. I'll read that information. Yeah.
Yeah, thanks, Jesse. You can do it at your own leisure, at your own time. You don't have to do it right now because it's a lot of information. If you want to look at some of it right now, you can. But if you want to continue the conversation, we can. If you have some questions, if you want to go over some laser tests, some of the guys here can explain to you about the lasers more in depth than I could do it.
Yeah.
Do you have any questions about the lasers?
Nope, I will read it more because I don't. You have read those information and I didn't. So of course you have more arguments about it. But for now,
yes. Even Matrix gave you like a summary explanation, like very simple, easy to comprehend depiction of what
I'm reading
we're trying to say.
at it.
Great use of crayons, Matrix.
But for example, okay, when before saying that this was something made by the government or something like that, but for example, to make the Hadron's collisioner, right? The Earth's curvature had to be taken into account into the experiments because lasers are used there, and if you don't take into account the Earth's curvature, then the laser won't reach the right place. But yeah, I don't have.
Oh, hold on, friend. Hold on for a second. Hold on, brother. You just said if you don't take into account the Earth's curvature, the laser won't hit the target.
Yeah, that's right.
So
because
previously you were given description. Hold on, bro. Hold on.
Okay. Okay.
Thanks. So previously you were given examples of lasers hitting targets, and you said that wouldn't disprove the Earth curvature. But by your own admission, you said that if you don't account for the curve, the laser can't hit the target. So now you're in a problem. You have a contradiction on your hands.
No, I was saying that if you put two lasers, like at different altitudes. Wait, let me see more about this.
And you better look at this twice, brother.
Yeah.
You're already in a contradiction, so you better watch out before you get further down a line of illogical.
Yeah.
So the only reason I jumped in there, my friend, is to point out to you that by your own logic, you're conceding that if the laser and what Gemsy described to you hits the target, then by what you said, you have to concede the Earth's flat.
Yeah.
It's been flat for a long time, since the beginning.
Exactly. Now, I will make another comment about your Hadron Collider, because it's not the case that the Hadron Collider has to be built accounting for any curvature whatsoever. It just has to be straight. That's it. And the straightness only has to supersede the amount of the variation of the beam divergence. So in other words, if you just build a very large straight structure and shoot a laser down it, it's not going to hit the wall.
It's gonna hit the top of the structure if it is.
No. One more time, friend. One more time. If you build a straight structure,
yeah.
So for example, I'm in a hallway right now, and I can walk down this hallway, and my head doesn't hit the ceiling because it's a straight hallway. So it hasn't mattered.
You're a laser. You are also affected by the same gravity that the train.
No, friend. If I shot a laser down this hallway, in the middle of the hallway, it would hit the other end. So all you need is a straight.
It's depending of how large is the highway, but at some point it won't.
No, friend. You're not getting it. You're missing the most key word.
At some point.
No, son, I'm not going to let you continue. I'm not going to let you continue because you're glossing over a very important word, and I don't want you to make a fool of yourself because there's women present.
Okay.
Okay, so if the hallway is straight, my friend, straight left and right and straight up and down, then your idea that the hallway is curving is irrelevant because the hallway is actually built straight. So if I build a straight hallway, the laser's not going to hit the ceiling. Do you understand?
But you are assuming that you are building it straight, and it is relatively straight at the scale you are building it.
There you go. So all you have to do is build a straight hallway. Thanks for conceding.
Yeah, but if you are assuming it is straight because it is relatively straight, and the difference is so minimal because it is not.
Okay, fair enough. Fair enough. Advice, fair enough, brother. I agree with you. I agree with you. I agree with you that in my hypothetical that I just gave you, it is a straight hallway. Now you're assuming that it's a curved hallway. So why don't you, since you started it, prove that the Hadron Collider has a curved hallway?
Okay. Yeah, I will have to do that. I will study more about this.
Keep in mind, friend, you said by your own admission that if they don't account for the curve of the Earth, then they can't build a straight hallway because the laser wouldn't hit the target unless they accounted for the curve of the Earth. Therefore, by your own admission, if we show you a laser hitting a target that supersedes the alleged curvature of the Earth, then you would have to agree by your own admission that there's no curvature of the Earth in the way. You sure you want to do that?
You didn't take into account the scale of the highway you are making.
No, you're wrong. No, you're wrong. No, you can't just tell me that I didn't take into account the scale, because the scale in this example is irrelevant. It's either a straight hallway with no obstruction. Pay attention, friend. Okay, I don't fight for the mic with somebody who has their mic open where I have to hear an echo, okay? So learn some manners. Thank you. I told you in the hypothetical, it's either a straight hallway or a curved hallway. So the economy of scale is irrelevant. Because you said if the laser doesn't hit the target, it's because the Earth is in the way. So then if the laser does hit the target, then the Earth is not in the way.
But if the scale is okay, you say it's irrelevant, but it's not because.
No, it's not. It is irrelevant. It is irrelevant because me and you are both talking about examples where the scale is already accounted for in the example. So whatever the value of the scale is necessary to the task. What's that?
Yeah, because why? So why do you say it's irrelevant? Because you say that
because the value is one. The value is one, friend. I know. Listen, I know I'm much smarter than the average human because I'm actually a robot. But the problem is, friend, that by your own admission, you already admitted to this, and I could help you out and demonstrate how the scale is irrelevant, or we could just use actual numbers. Which one do you want to do?
You cannot use 1 as a number because 1 in your scale can be anything, and you are comparing it to something else, not just
isolated. Correct. So any model is a scale of 1, then a colon, and then another number, correct?
Yeah, and then you cannot use 1 because you are comparing it to different numbers, not one both.
So if I scale up the example smaller or bigger, the proportions remain the same, correct?
Yeah, but
correct. So I can use 1. So don't focus on this, friend. Focus on the fact that you said.
If you use
focus,
1,
listen, friend. I just said don't focus on 1. I said we can move on from that, and I said we can use actual numbers, and then you want to go backwards. Look, I'm trying to help you out because you believe in the globe, and whether you realize it or not, you put your foot down that if the laser hits the target, the economy of scale taken into account, then the Earth must be flat. And that's what came out of your mouth, friend, and whether you realize it or not. I'm just trying to help you before you become a flat earther because I know you don't want to be one.
If it hits the target, but it is a small scale, it doesn't prove anything because it would have hit the target and it is a globe.
Friend. If the laser hits a target in a straight hallway, then the hallway's straight. No duh. Everybody knows that. Go ahead.
Santi, you're asserting that the test that has been conducted is being set up for the specific purpose of measuring the claim geometry that you learned from the book, remember? So it's been taken into account that from one distance A to another distance B, there should be a drop over that distance. This is taken into account into the test already, and you are saying you're not taking that into account, but it is being taken into account. Do you get that, Santi?
Yeah.
So the laser and the target are being put at a distance that there should be a drop from those 2 points.
Yeah, and the experiment you are showing in these videos.
Test, not an experiment, a test.
The test, yeah. The test that you are showing me in these videos, put it at a significant distance that it would have shown any curvature if it was done like that.
There will be a drop.
I'm watching the video and I don't see any distance, right?
You don't see any distance? You're saying there's no distance from the laser to the target?
They are just showing y-axis, like 17 feet, 23 feet, but they are now showing what's the distance in the x-axis, and that's important because there will be a significant curvature or not, depending on that.
So the first one that is listed is 9.5 miles on the first one. The second one that I see here is 25 miles from FE core. There's another one 10 miles. Another one 9.5 miles, 7.5 miles, 13 miles, Santiago.
Yeah, well, watching
there is distance.
The flat earth for modern times behind the curve, that video. So, hey, let me see all of them. I'm gonna study them, right?
Yeah, you can do that. That's exactly why they were posted, for you to check them.
Okay, thanks. I will do that.
Can we drag Debate Daddy out now, Jamesy, please? I want something to kick around.
Santi, send me any tests if you want, any DMs if you want. Actually, I'm gonna DM you, Santi.
Okay.
Go ahead, take over, Matrix.
He's not even in the channel. This clown is claiming reciprocal zenith measurements. I'll read it out. Reciprocal measurements don't just ignore refraction, they use simultaneous opposing angles to mathematically calculate the specific refraction coefficient and isolate the 3959 mile geometric curve from the atmospheric bending. Yeah, yous all probably threw up at the same time, I know. So this clown thinks because some moron got a second theodolite and shot it back towards the first one, refraction magically does something different. How, please, somebody enlighten me. How does refraction magically disappear just because there's theodolite number 2, 2 miles away or 10 miles away? I don't care what the distance is. I must have missed something in...
I don't understand the words you're using. Did you say theodolite?
Yes, total station.
Yeah, what's a zenith angle on the surface of a basketball? Like if I got a basketball and I'm kind of pointing sideways to it, what's the zenith angle? Hello?
Tic Tacs, that's you.
I was asking a clarifying question. I wasn't.
Yeah, I'm asking. So am I. I'm trying to clarify what you mean. I have a basketball and I'm pointing to it kind of sideways, not on top, not on bottom, not completely sideways, just kind of sideways. What is that zenith angle that I'm pointing at?
Oh, he doesn't know. He just posts stuff directly from flatearth.ws. And the one that he posted in side chat. So whilst we've got him on the line, was the laser one. Flat Earthers' laser tests are misleading. If a laser beam is recognised from a distance, they will conclude the Earth is flat. Well, unlike Tic Tacs, why would we assume the Earth is anything other than flat when lasers shoot a straight line?
I don't know what you want me to respond to there. Obviously,
you're the one that posted that shit from WEarth, Flat Earth fucking stupidity site. So if you're posting it, maybe you should understand it, or you just think you're clever posting memes and stuff up.
I don't know what you want me to respond to with what you just said.
I want you to at least understand the stupidity of what you're posting up in the first place. Do you understand what you posted up? Yes or no?
Do I understand that lasers diverge depending on which wavelength laser?
Excellent. So what is divergence?
Okay. All right.
What is divergence?
Think about it like the flashlight that you held in your hand. While that flashlight, point of light is only, let's say, an inch, wide or in diameter. Well, by the time you hit the wall of your house, now it's 3 feet. Well, that
excellent
diverged.
So that means from the point of the laser to the point of that big dot that's 3 feet wide at your house, the beam is dead straight. It's not bending. So all we've got to do is go at 10 miles, the dot is 8 foot across. So that means the center of that dot is 4 foot in, by my rough calculations, and we just work out where the center of that hits. So if we hold a target up that's 20 foot high, and we've got an 8 foot circle, even you can work out where the center of that is. Correct?
Agreed.
Excellent. So now do you understand the stupidity of the thing that you posted up?
Okay, that was like step 1 and 2, right? Divergence of light.
But if you have actually, how about I do this for everyone? Copy image.
Throw those out because step 1 and 2 you failed. So start over. Go ahead.
It's coming up. Wait for it. Bingo. There it is. That's the crap that he posted up. What kind of clown has got some bendy laser? Like, seriously, I want one. Please, go tell me where to buy them.
How is the bottom of the beam divergence going through the Earth?
You guys actually believe this shit? Seriously, bro.
These idiots think that when a beam diverges away from its source, that it starts curving around a ball. Dude, you guys are going to make me quit fucking Discord if you're that fucking stupid.
Great argument.
You're the one that posted it, son, not me.
Okay, so we just spent the last 10 minutes laughing at.
Is it predictable? Unlike tactics, is it
the
predictable?
idea that divergence of lasers exist.
Is it predictable?
We're not, unlike Tic Tacs, we are not disputing the divergence. We're disputing your claim of the divergent bendy bit. That's the bullshit side of it. We all know that light diverges. There's a thing called the inverse square law. Hello? Look it up.
I can't believe you dumbass believe that shit, that light, when it starts diverging, is actually starting to bend around something. Are you that much of an idiot?
Have you guys ever played with a prism?
And now he's going to just divert completely.
Anything with a prism.
Hey, Tic Tacs, check it out.
Guys, quit yelling over me.
Yeah, if I take a prism and I shine a light through it, that light is not going to curve. It's not going to curve around a chair in my room.
But it's going to refract, isn't it?
Excellent. The bending of light as it passes from one medium to another. So in order for you to claim your refraction, you've got a second medium present. But based under Snell's law. I've got no issue with that, unlike Tic Tacs.
Would you agree that the medium that I'm looking through when I stare from, at a ship going,
No, we're talking about lasers bending.
Versus if I'm looking up...
No, not you looking. We're talking about lasers bending. We're going to stay on your claim. Lasers bending. You show us how that happens.
Okay, lasers bending, and we're talking about refraction. Where does refraction happen? Well, it happens most often where the atmosphere is most thick. Where is the atmosphere most thick? Definitely not directly above your head, but instead directly on your horizon. So that's
excellent. So you would be able to provide us with photographic or video evidence backing up your claim if it's such a common occurrence.
Be specific. What are you asking me for?
photographic or filmography evidence to back up your claim of the laser bending down, because it is such a common occurrence, being that we live in this thick atmosphere.
Okay. So
open air, bending downwards. Don't post up the fish tank or I'll kick you out of this channel.
Oh, God.
Oh, yeah. We're sick of seeing fish tanks. We're talking about the open air. We've got guys doing laser tests across 30 miles, and you're going to show me a fish tank. That'll be fantastic.
Like flat.
Hey, Triangle, do you want to tell him about the lasers bending downwards bit video thing?
Can you prove you got a curved gradient? That's what you need. You need to prove you have a curved gradient. And plus, you need to account for fluctuations along the way, because it's not going to be uniform. Everybody knows that the air is very chaotic and dynamic. It can change by meters, meter to meter, can change.
See, isn't it interesting? You speak of refraction, and then the thing you post up, Snell's law. Light bending as it passes from one medium to another. Perfectly. It bends at the join. I've got no problem with Snell's law. And then you show one thing, and yet you preach something else. They're two separate things, and this is where you're going to come unstuck in a hurry. The one you're begging for is what's called atmospheric refraction. Now, in order for you to claim that, you must first prove the ground is bending underneath first. And the reason for that is to calculate your atmospheric refraction, they've got an R value in it. So you do understand the problem there, don't you?
No, I think you're going a little bit too fast and too fast for me.
To calculate atmospheric refraction, there is a radius value baked into the formula. Do you understand that bit?
No, I do not. I know that there's like a refractive index, and like you can go on your weather app and kind of get a rough number for what the refractive index is today versus tomorrow.
Well, refractive index means 5/8 of nothing, mate.
You'd need differing refractive indices. You'd need differing refractive indices, because if it's the same refractive indices, there's going to be no change.
I agree with that.
Right.
But you were mentioning earlier that what's baked into this. No, you didn't say refractive.
The radius is baked into it. So the way they work it out is they just assume a ball Earth in the first place, and then they just pump the ball up and make it bigger. That's all they do to get your K value. So there's a radius baked into the formula to work this out.
Kinematic. It's kinematic. It's not dynamic. I mean, the only reason you're saying it hits its target is like there's refraction is because it hits its target. How do you differentiate between light that's bending around a curved Earth in a curved gradient, density gradient, right, and hitting its target, and a flat Earth where it didn't have to because it's just going straight and remaining within the same area of the gradient?
How do you ask the question again? How do I determine?
How do you distinguish the difference between a laser that's hit its target on a curved Earth, right, with a curved density gradient, and a flat Earth where the light's just, the central beam of the light's just remained within the same refractive indices, the same area of the gradient? It hasn't entered a different gradient.
The first thing that jumps to mind is using that time variable, because refraction changes over time. But if we were on, flat Earth and
time does not affect refraction. Okay.
Well,
before you speak, I'm going to ask you a question. 3 things that affect refraction. What are they if you're claiming atmospheric? Temperature.
I just want you to answer the question.
Humidity. Pressure. None of those are time. None of those are gravity, and none of those are curvature.
Temperature and pressure change over time, though, don't they, on planet Earth?
Yeah, how do you tell the difference between a laser that hits its target on a flat Earth versus a laser that hits its target on a curved Earth?
And I was
Hey, bros, when a direct question is asked to a guest, the next person to speak should be the guest. Okay, so unlike Tic Tacs, answer the first question first, which is what homie asked you. He's going to repeat it so you're clear. Don't speak until he's finished, and then he says, what do you have to say about it, okay? Go ahead.
Yeah, hang on, Tic Tacs. How do you tell the difference between a laser that hits its target on a flat Earth versus a laser that hits its target over a curved Earth?
I feel like the question has changed over the amount of times that you've asked it. My first response was, let's say, my earlier example talking about diffraction, how things can bend light, et cetera, et cetera. My example would be, let's test it over 2 different time periods, because refraction index changes over time, as is pressure, pressure and temperature. So that was my take. If it was consistent, it's repeatable, then it becomes, scientific evidence, right?
Wrong. And the reason I say wrong is because it doesn't necessarily change over time. It changes because of weather conditions. If the weather conditions do not change, your index do not change.
You really didn't make a distinction between the two, right? Because that's going to happen regardless. So how do you tell the difference between what's the laser, the light behavior over a flat Earth versus a globe Earth?
I'm tempted to get into the weeds here with specifics, but I think what I said is true in that if we test it today, you're on your flat Earth, but we're standing side by side. I'm on my round Earth. We point our laser to our target. We both hit it today, but tomorrow we don't. Something must have changed, and that's how we slowly determine through trial and error, what is directly, horizontal to us versus, and that's how we determine if we're on a curved Earth or a, flat Earth, is that, let's say today there's no atmospheric refraction, but tomorrow there is. Well, our experiment results are going to change over that 1 day time difference, right?
Not necessarily. We're hitting our targets. You're not. So let's try it a different way. Let's set up a laser. You and me are going to drive down the other end. Pick a distance, 30 miles. We both look at the target. We go, oh my goodness, it hit the target. That's amazing. How are you going to tell the difference between whether the ground is curved or flat just by looking at a target?
Well, you wouldn't be able to tell just by looking at the target. You would ask, how high in the target is it, or how high is the target above, our vantage point? So I have the tripod set up at 3 foot high, and the target's 3 foot high. Well, if I put the laser hopefully I'm making sense. If I'm putting the laser 3 foot high and I point it directly 90 degrees horizontal and aim it right, well, then it should hit the target. But if it's a curved Earth, I might have to put the laser, let's call it 30 feet high over that distance to actually hit that same target at, while the laser's at 90-degree angle, right? Not accounting for, the laser's divergence?
Refraction was the one you were using.
Well, we first talked about divergence.
Exactly. So think about this. Okay, so a lot of these laser tests are done over, say, 40 kilometers. And the one I'm talking about that was actually done over 40 kilometers, the laser was 5 foot high, and the target was 5 foot high. And over that distance, there's over 400 feet of curvature. Right? But the laser hit the target, no problem. And they even used weather stations to measure the temperature and the pressure vertically at each end as well, and they had an extremely precision laser. It was like a $30,000 laser that was perfectly horizontal.
What was the
and they
distance
actually
again?
40 kilometers. They did 5 different tests in different weather conditions as well, and they hit the laser, hit the target with the laser each time. Different weather conditions, different days, different distances, different locations, and this is a team of engineers doing it as well.
I guess, sorry to interrupt you. Before you told me it was like a super expensive laser, I was about to say I love these kind of experiments because we can just go run these in our, backyards essentially.
Yeah, we can go do them in our backyard. I can go run a laser. Do you want to go with me?
I think this stuff actually interests me.
You don't
because
need to
can
use
run this in your backyard.
You don't
can do
need
a
to-
kilometer and measure 2 centimeters, right?
Just quickly, sorry to interrupt. You don't need to use a $30,000 laser. You can get a laser for a couple of $100 or $500 that has an extremely small amount of beam divergence over, say, 10 miles, something like that, 10, 20 miles. And you can go and run these tests. We've got so many that have been done in completely different weather conditions, different locations, and the lasers keep hitting their targets, and we can't find any of that curvature that should be there.
Being fair to me, for every laser experiment you guys post, a globe earther can also find one that kind of contradicts.
Yeah, it's always the same one.
No, there isn't any. That's the thing. I mean, I could sit here and present one after the other. But if I asked you to go and try to find one that the globe earthers have done, you're not going to be able to find one. The only thing you might be able to find is some 52 seconds worth of footage from a mockumentary done by a dumb stoner named Jeranism on Behind the Curve. And he didn't even use a laser. He broke the laser before the test. And then they cut out some cardboard holes at nighttime and did a test over a really short distance, and it was just really crappy footage. That's not even a laser test, so you're actually not going to be able to find counter tests from the globe side. They either don't release them because it doesn't ever. Well, if you think you can,
what would a counter test look like logically?
Well, what they would do is they would prove that the Earth is curved, right? Then they would set up a target and a laser. And then they would fire it, and they would say, because the Earth is curved and it hit the target, light bends around the ball. That's all you guys have. If it's anything other than that, you guys are just making up bullshit.
The counter test, I believe, would look like what I've just posted up with my excellent little drawing. 24 past the hour. If your guys are presenting that... Sorry, AI.
Let me look at it. Hold on. Holy crap, how many posts are there? Holy moly.
Yeah,
All right, I made it to the end.
I have a green laser pointer sitting in front of me, but when I Googled it, it's basically said it's going to drop, or it's going to diverge a millimeter over every meter that it travels. Do you guys know of a better, cheap laser pointer wavelength to use?
I don't know
Doesn't
the particular
matter.
models.
It doesn't matter as long as you can acquire the light from it. No, it doesn't. I'll explain. I'll explain. Okay, so if you have a divergence from the center, right, that could be expressed as a cone, right, much like a firing cone, right? So you end up with a circle of uncertainty. Let's say it's 3 feet wide at the end. Now, if you're hitting directly in the center of that 3-foot spread, then you know you're in the center. But if you're hitting at the bottom, you know you're at the bottom. If you're hitting at the top, you know you're at the top. So you know it's 3 feet. Now, the other thing you know that is if the Earth truly is an obstruction, then the bottom leg of that cone has to clear the obstruction 100% in order for you to see it, or the top leg of the cone. So that would only give you a variance of 3 feet. So you could use the economy of scale and tolerances to use that 3-foot divergence to do your test.
Yeah, it's pretty easy to grab a 3-foot poster board and have that, you see that full image of the full circle of the divergence of the laser on that 3-foot poster board. But
now there is one caveat to that, which I have to mention.
Okay,
Hold
go
on.
ahead.
Since you agreed, and I don't want other people to miss this caveat, is that when it comes to a conical spread, it is true that you can hit somebody behind an object, like with a shotgun spread. If your shotgun bottoms, balls that are in the spread graze over the target, but you can also account for that as well. So you can account for the divergence and you can account for the observer height relative to the obstruction relative to hitting the target. Go ahead.
I missed it. How are we accounting for that? Because we know like the wavelength and how much we expect it to diverge, or how do we account for that?
Yeah, if well, like you said, there's a divergence per distance, and that you can express that as a cone, or if you put it in orthography, you can express it as a triangle, right? And then you can size that triangle up to the obstruction you're trying to clear. Does that make sense, brother?
I think I'm following you, but maybe you missed what I was saying earlier, which was, at least with my green laser, the quick Google search I did, it was like 1 millimeter per meter of distance will be the divergence cone. And so I guess I'm scaling this up to, some of the videos that were posted in the side chat, like 3 miles. What is that divergence cone? It's easy to get a 3-foot big poster board and see the whole divergence cone, but I don't know why your divergence cone's actually going to be pretty big.
Why you hung up on it?
Well, why not just do the math on it?
1 kilometer, it's going to be 1 meter wide.
Right. So if you did 40 kilometers, okay. If you did 40 kilometers, how wide would it be?
$40 meters.
Okay, so yeah, that's getting pretty close to the uncertainty. It's still beyond it, but I see what you mean. But you don't need to do something that long. Like you don't need to go 40 kilometers.
Yeah. We can do this in 1 kilometer if we can measure 2 centimeters.
Well, why don't we do so? Well, let's put it this way: where would the drop be? 30 meters. At what distance would the drop be 30 meters? Isn't it like 5 miles or 6 miles? Something like that. I know 10 miles is 66 feet.
And your question was how many meters? Or how many? I have to do math.
30. Well, I was just trying to get it to be in 10. So you have a 3 meter poster board. No, it would be 1 meter poster board.
That's doable.
So it would be 10. So 10 meters. So how much till the drop is 10 meters?
Think like 30 kilometers, feet. Right?
So 30 feet. I'm sorry.
If 10 kilometers right distance is 2 meters of drop, then 30 kilometers of distance would be 20 meters of drop.
Well, it's did you square it?
Fuck.
The only reason I'm picking that value is because then the curvature differentiation from the straight line would be an order of magnitude off from what you're able to measure, and that would be more than sufficient. But you could do less than that if you trust your process.
Yeah, if we're doing a 1 kilometer test, 2 centimeters is like within the margin of error on my, tripod level, and you have to go big distances to get big drop over distance.
The other way, instead of messing around with your laser wavelengths, you can put a thing called accumulator on the end of it, which refocuses the beam.
Oh, 7 miles, bro. 7 miles, it'll drop 10 meters.
What's the zenith angle of my finger pointing at a basketball kind of on the side of it?
90 degrees.
So everything is always 90 degrees? 90 degrees to a curved surface?
Okay, I feel like we're derailing.
Oh no, you got it wrong. You realize that fucked you all up. Yes, you can't have 90 degrees to a ball. You can't have 90 degrees to a ball, can you? You can't have 90 degrees to the surface of a ball, can you? Wah, 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 wah.
When somebody earlier was talking about if we wanted to get rid of at least some of the what do we call it, divergence of a laser, you use a started with the
collimator. Someone posted up in side chat for you. Rayleigh Criterion. Rayleigh Criterion. 32 parts the hour.
Thank you. Yeah, I've definitely collimated my telescope, but it makes me interested in like putting a somehow collimating my laser beam.
Yeah, you'd have to use a decent quality laser, and then you can buy a collimator that it's like an attachment that goes along with it. But I mean, I've seen laser tests done over 6 miles, 7 miles distance where there's basically next to no divergence. I mean, not much divergence at all according to the laser's specifications. And then we have like a side view where someone's taken a high resolution picture from the side showing that the divergence isn't much at all over that distance. I think that's about a $500 laser that he used.
According to the side chat, if you use a $60,000 laser, those curve around the Earth.
Oh, so we're just cheap. That's all it is. We got to buy.
Yeah, ours just goes straight. Ours goes straight. You got to bet the really, really expensive ones, and then those go around the curve of the Earth.
think he's got a problem with his laser if it's doing that.
Well, this guy says what Jesse Kozlowski does. He has a $60,000, $100,000 setup, and his can shoot curves around the ball. Military can't because their shit's too cheap. But this guy's stuff works.
You know what's the funny thing is that the Globers already claimed that they have a perfect model of refraction that can always predict the geometry of the globe, retro-engineered from any observation. So why don't they just use that model, get out there and use a laser and measure the Earth?
This might be related, might not be related, but aren't they using like sodium lights for big astronomy stuff out in like Chile to account for atmospheric refraction? Have you heard of this?
Say again, sorry?
I believe it's like one of those extremely large telescope stuff in like Chile, but they're shooting up sodium lights into the atmosphere so that they can then, calibrate the telescope to account for atmospheric refraction before they do any observations.
Well, the only issue with that would be the claim on the table is that because of the layers of air, that it refracts as we look through the different density layers. So if we're looking perfectly horizontal, that effect gets thrown out the window. So why would they be calibrating something to expect refraction and then look in a different direction? Well, that means they'd have to recalibrate it every single time based on the direction they're looking and their elevation they're looking.
I'm not.
They're using adaptive optics. I mean, yeah, what they're doing with this, in this case, they're not looking through the same phenomenon that people claim is causing the Earth to look flat. They're looking through shimmering what almost looks like water, and they're using adaptive optics to compensate for the warble refraction. Right, the warbling star, the warbling star at night is not the same thing as like the entire ocean being lifted up flat to eye level, perfectly stable and clear. You know, I'm still looking for the meteorological and physical effects that would be present to cause terrestrial refraction.
Well, like the moon being a different color on the horizon versus it when it's directly above your head.
Yeah, and sometimes a different color when it's directly overhead.
Jesse found his best friend in the side chat.
Yeah, Dumb and Dumber. It's great, isn't it?
I probably hasn't heard him talk yet. Maybe he wouldn't be chumming up with him. They must be getting afraid of something. Jesse's coming back in here, so something must be going on.
Yeah, they've probably heard all the boys have got infrared cameras now, so they're coming in here with just saturate us with refraction, so we'll just flip out and walk out.
No, you know how you can put an end to their conversation? You ask them what the zenith angle is when you point to the side of a basketball. According to him, no matter where you point on a ball is 90 degrees.
That don't even make sense, dude. Like,
That's what he
where's he
said.
getting the line? Where's he getting 90 degrees from? Is it to the tip of your finger? Is it to your knuckle? I mean, what the
He
heck?
said it's if I point at a basketball, I'm not at the top, not at the bottom, not at the side exactly, just somewhere on near the side. He said that's 90 degrees. So
you said zenith angle.
Yeah. Zenith
definition
angle, exactly.
means
So go ahead,
perpendicular
explain
to the
how that
surface.
works.
If my definition follows yours, being perpendicular to the surface, what is perpendicular to any surface? Round, square, triangular. Perpendicular to that surface is
What's
90 degrees.
perpendicular to a basketball?
Your finger at the zenith angle.
I'm pretty sure you need to have straight lines for perpendicular.
Is your finger not straight?
The basketball's not, bro. Hello?
Okay, but we can still measure angles on.
You can't measure an angle off a curved surface.
You cannot measure an angle from a curved surface. That's what, you know what? You better give me your theodolite because you don't know what the hell you're doing. See how you quiet the room when you ask them that question? It's just no Globers. Oh, what? Dart.
Okay, so Debate Daddy, you're claiming the horizon is a physical location dependent on your elevation. We should be able to measure that quite comfortably. We should also be able to calculate that and predict where it should be.
He can't
For
post
example,
that picture. It starts with the center of Earth. You can't use that.
Time or
what? Oh, man. You don't have a center of Earth. And he responds, why not? Debate Daddy, please tell me you've got a very good shovel. You're assuming a ball. How about you take a step back and assume you don't know anything? and ask yourself, how would I test the surface to prove whether it's flat, curved, or anything else? What would you do? At the moment, you've assumed a ball, you've assumed a center, you've assumed a radius, and God knows how many more assumptions you're probably going to tack on top.
Well, over the last couple of days, I cross-referenced the amateur rocket launch and the curvature you can see in that. Calculate.
Measure the center of Earth, not rocket launches.
Stop interrupt. Well, obviously, you can calculate the center from the geometry.
You're assuming that geometry. That's what I'm trying to get through your head. You've made a just flat-out assumption that it's a ball. You haven't measured anything. So step one, assume ball. Step two, then I can base everything off that assumption. If we've got a formula, debate daddy, if we've got a formula, doesn't matter how long it is, doesn't matter how short it is, your very first input is incorrect. The rest of it may as well be thrown in the bin. Your first input was an assumption.
Well, I was going to get to it, but you guys cut me off. So you can look at the curve observed in that amateur rocket experiment and cross-reference it with other experiments, like the PDF that they did from a plane.
Excellent. So if we can witness it from the rocket stuff, if we can witness it from the rocket thing, as you claim, that's all well and good. I'm happy with that. Therefore, we should be able to go outside and measure this. So why do none of these laser tests that the people have been talking about for the last hour, why do none of them show any curvature?
I came halfway through. I don't know too much about the laser experiment, so I'm not going to speak much about
it's not really an experiment. You get a laser, you shoot it long distance, and you try to set it up as horizontal as you can. You measure the difference between the laser and the surface, and then you go 10, 20, 30 miles along the laser, and you keep measuring the difference between the laser and the surface. A lot of the times they'll do these over large expanses of water, lakes, for example.
But why would we estimate whether it's horizontal when we have
Why would we estimate? That's very simple. That's very simple.
Perfectly horizontal.
That's very simple. That's very simple, my friend. Why would we shoot the laser across there? The whole purpose is to use it as a straight edge. If you're going to reference some kind of design underneath it, whether it be flat, whether it be curved, whether it be a sawtooth pattern, it doesn't matter. You need some kind of straight edge to reference. And that's what the laser is for. So you measure the surface down to the water and go, oh, look, I'm 2 foot high at the start. Then you go 10 miles away and you should be 68 foot high. Then you go 20 miles away, 268 foot high. 30 miles away, 602 feet high. 40 miles away, 1,068 feet high. See how quickly it gets bigger?
No, I do.
This is the problem. This is the problem, Debate Daddy. It does not. It stays the same.
Well, those things are going to compound over, if there's a slight inaccuracy, which is why, a total station...
Okay, how much inaccuracy do you want to give me?
The total station's, what's the degree of more accuracy it has? 1,000 times, 100,000 times? I don't know. It's perfect, right?
No, they're not. The problem is, if you ask your moron friend down the bottom there somewhere, he'll use a total station that's guaranteed for 1.7 miles, and he'll use it over a 75-mile distance and claim that it's perfect.
Yeah, that's not how you use those things. You guys, that's why you guys need to just throw them out. I'll buy them from you if you want to make a little money, because you don't even know what you're doing with those things.
Well, when I posted the total station...
And anyways, we were referring to the laser test, not the theodolites.
Too, right? Yeah, and then I did the reciprocal. I was talking about the reciprocal stuff in side chat earlier.
Yeah, that's what I would like to know. Why is it just because someone's grabbed a second total station or a second theodolite, why does refraction magically disappear?
It doesn't
disappear. So here's you guys. I want you to listen first. Here's you guys coming in every freaking day. Refraction. Every single time we do a laser test, every single time we do a long-range observation, it's refraction, refraction, refraction. And now you're telling me just because some person grabbed a second total station, refraction magically disappeared. That's your turn to respond.
The way I understand it is like if you have when you're doing math and you have like you subtract on one side, then you subtract.
This is not math. We're outside in the real world.
Like, when you do I'm just making an analogy. Like you're looking at it from the opposite side. So it's not that you're subtracting it and not factoring it in. It's that you're literally canceling it out mathematically. We're talking reality. We're talking looking through a scope. Way to do it. We're not talking mathematically. We're talking reality. This is not a chalkboard. This is a scope looking at a target outside in the real world. How does that cancel refraction when you get the second one looking back at the first one? So the refraction that curves the light up for you curves the light down for them. So you're
no, it doesn't. It's exactly the same for both.
Yeah.
Because you're both looking through the same conditions.
No, you're looking at it from the opposite direction.
Wrong. Just because you're looking at it from the opposite, incorrect. Just because you're looking at it from the opposite direction does not instantaneously mean it's doing the opposite thing. Remember, the stratification is vertical, stacked on top of each other. Layered. One layer on top of the next, on top of the next, on top of the next. If it was a horizontal, as in they were standing vertically, and from my end it was cold and your end was hot, then I would say you had a leg to stand on.
Okay, I mean, like, can I ask how you determine that? Because you're saying, like, it would not cancel it out and it might even double the effect you're seeing.
Okay. Theodolite 1 is you.
Account for it in the other.
Theodolite 2 is me. Okay, we've both got a theodolite. You're at number 1, I'm at number 2. The air in between us is, I'm going to pick a random number, 45 degrees Fahrenheit. It's a nice, cool day. Tell us about this refraction.
No, well, okay, I guess my question is a little bit different, right? Because if we're trying to factor in and it's either going to cancel out, it might actually amplify it, right? So you might have to account for it in both directions instead of having it cancel out, right?
Okay, I'm going to ask you a question.
Am I correct in like understanding what you're saying?
Why don't you do it the simple way? When you look through theodolite number 1, my fine friend, is there miraging? Yes or no? If there's miraging, you probably should come back another day.
Okay, but I showed you the 1 mile total station measurement, and it was said, well, he only did standard refraction measurements, or like he didn't actually.
So why did he do that?
One directional. Well, there was no miraging, so he factored in just standard.
So there's no miraging, there's no refraction, but yet he factored in refraction. That's great. So he's assuming there's a ball.
Oh, what do you mean? His numbers didn't come out, so he had to add some numbers to it? That's weird. Hey, you can't do that.
Well, they do.
I would fire you. If I would fire you if I found out you did that because your numbers didn't come out. I want to know what the actual numbers are, so if we have to make adjustments, we can. Not what your numbers are after you add stuff to them.
So would you rather leave the numbers raw? Because like the thing with the reciprocal zenith angles, if you leave them raw, the angle comes out to over 180 degrees, which, like, after factoring in the Earth curve, it's perfectly 180. So, like, how would you explain that?
How do I explain what?
You would expect the raw numbers to come out to if the Earth were flat, you would expect the raw numbers to add up to 180. Like that's the point I was making.
Why would I expect that?
That also proves.
If you don't have 180 degrees, then you don't have a triangle, do you?
So there's a problem here.
Yeah, you didn't measure a triangle.
There's a contradiction, actually.
There's no contradiction.
Triangle.
Well, here's
the contradiction is you didn't make a triangle and you think you did.
So did they allow for deflection? Before you go spurging on about your so-called contradiction that you're inventing up here.
Okay.
Did they allow for deflection? Because there's this funny thing where you set up a plumb bob and you get deflections right across the world. All different places will give you different readings. Some countries are worse than others. So you can set up your total station right now, and what you perceive as perfect, dead zero, is actually deflected by maybe an eighth over 2 yards.
So I feel like I have a pretty potent critique here, and I'll try to deliver it. This is just...
So you wanted to critique something and not answer the question?
Sorry.
If you don't know, just say I don't know. I'm happy with that as an answer. At least it's honest.
Well, sorry. What? So it's different across different areas of the Earth. Like what specifically is different? The geometry or what they're...
When you set up a plumb bob, a weight on the end of a string.
Okay, I don't know what that is. Sorry.
Really? You're telling us how to do reciprocal zenith angles, and you don't even know how to set up the zenith in the first place.
Yeah, no, I've never done this like myself.
So why are you speaking of it? Right? Why are you carrying someone else's bullshit water then?
Well, I mean...
You just copy-paste. That's what you're doing. You've accepted that as a story because you think it's some kind of get-out-of-jail-free, and now you're backed into a corner because you don't know anything about it.
No. DJ challenged me earlier, and then I went out and did a little bit more reading. I'm still learning. I'm not a know-it-all. But yeah,
DJ challenged you earlier. Not a problem. DJ, are you there, mate?
2 days ago, or it was like 2 days ago, or something like that.
Yeah, I'm here. Yep.
Excellent. Floor's yours, brother.
Oh, there's nothing to talk about. I mean, Debate Daddy already said that the one that he looked up just guessed the refraction. So that's a ridiculous thing to do, right? That would assume that the light's bending downward at a specific rate when they have absolutely no idea what the refractive index is doing between point A and point B. It could be doing the complete opposite of that, for all we know. So it's just an invalid test, especially over a kilometer. You're just working with what I call hyper-specific variables, where like super tight. What is there over that distance? Hardly any curvature whatsoever. So you'd have to be making a hyper-specific claim. And just guessing standard refraction doesn't cut it. That's that would just be just guessing.
Hey, DJ, could I see that as manipulating or tampering with the raw data that they've got to make it fit somehow?
Well, yeah. I mean, it's just guessing at the end of the day.
There we are. You mean you've got your data, and now you are adding refraction, from what I understand. Which is like, why would you do that? You've got your raw data. There it is. Why would you? This is a case of. Yeah, go ahead.
Well, this is
my critique, though. I have a very strong critique. This is like exactly where my critique is. So, in the one experiment where it's the like one directional 1 mile thing that DJ is talking about, he just factors in standard refraction. I'm fine with saying, okay, he just guessed it, right? But the thing is, when we do the reciprocal zenith angle,
it doesn't eliminate it.
Those are the raw numbers, and
it doesn't eliminate it.
So in the one case, you're saying, well, why did he not just use the raw numbers? Why did he factor in and gerrymander his things? And in this one, it is the raw numbers, right? And you guys aren't happy with that. So that's
which one's the raw numbers? Which one's the raw numbers?
The reciprocal one where you do it in both directions simultaneously.
Okay, let's just hold this up for a second. I just want to know one thing, Debate Daddy. Are you talking about refraction or Or are you talking about reciprocal zenith angles? Because you're bouncing between the two, mate. You're starting to confuse the shoppers.
Well,
Which one is it?
I'm talking about the reciprocal zenith angles, and I'm talking about
excellent.
Just
so your leader using the refraction of the one direction one means absolutely nothing. Please continue.
And like the nail in the coffin, though, is that when you take the reciprocal zenith angles, it adds up to over 180 degrees with the raw numbers. And when you don't even have to factor in refraction because it's already baked in. When you actually factor in,
so it's already baked in.
Yeah, but when you factor in, you actually have to factor in Earth's exact geometric radius
before you start,
and it gives you a perfect 180.
Because you're just butchering every single thing you're saying. So maybe do a bit more research.
Do you understand that? Do you understand
that? I'm not here to teach you anything. Okay, like you're just butchering everything you're saying. Go do proper research before you open your mouth. It's not our job.
I don't know. I'm being so rude. I'm trying. Okay.
Because you're saying things like that in the coffin when you're just butchering everything in the first place. Like you're being arrogant. Like there's
I'm not being arrogant. I said I'm specifically not a know-it-all.
And you have no fucking idea what you're talking about.
No, I said I'm not a know-it-all, but what I do know is that with the reciprocal zenith angles, it will add up to.
It's not what you know; it's what you believe.
And
so you just told us. Okay, hold on. You just told us it adds up to over 180 degrees with refraction baked in. So you're cooking the numbers, son.
Yeah, this is
what we're raw numbers. Those are the raw numbers.
Okay.
So how did you get your refraction to bake it in?
Well, the only way to get it to correct to 180 degrees is with.
No, I didn't ask that. Please answer the question.
That's the problem.
How did you get the refraction to bake it in the first place? Did you take temperature readings, air pressure readings, humidity readings across the 1 kilometre or 1 mile distance that you were doing this reciprocal zenith angles?
You did a reciprocal zenith angle. You did it simultaneously.
What I'm trying to, we get that. 2 of them looking at each other. Congratulations. We can all fucking count to 2. I'd like to know when you, standing at theodolite number 1, and I've got number 2, remember? We're both looking through the reticle. We're both aiming at each other. How do you know that you're hitting me and that it's not refracted?
Because when you account for Earth's radius, it's a perfect 180.
You account for my radius. I'm not that fat. Come on.
That's the only way the numbers don't add up if you do anything else.
What numbers? You're looking through a scope. Listen, kid. You're looking through a scope that's attached to the device. There's no numbers yet. You're looking through a telescope. You're aiming at Matrix. He's got one. He's aiming at you. How do you know you are hitting me directly and it's not just a refracted image?
Because you can repeat it. So you can repeat the experiment.
Okay, we do it again. Same question. How do you know you're hitting Matrix and you're not just looking at a refracted image? Because you can repeat it again.
Because if it was one off, you couldn't know.
You can't know. Exactly.
Yeah, if it's repeated again and again, and the only thing that solves for it is
same question.
Then it's R, dude. Like, I don't know what else to tell
Same question. How do you know you're looking at me and not just a refracted image? Do the test again. How do you know you're looking at me and not just looking at a refracted image? It's not going to end, mate. We would like to know how you know that it's not refracted because you're adding refraction in.
Because if there's one number that solves for it in every measurement, that's the solution.
More than 180.
That's going to be that's an extremely strong inference to make, is that if R solves for this every time, well, Earth's probably a globe.
So why do you need R and also refraction on top then in order for you to get your numbers? You ever thought about that? Why is it every time you get quote unquote the raw numbers, all of a sudden, R 7 over 6 R, huh?
Well, I don't want
like
to
DJ said,
but
you're going to repeat yourself again. You seem to believe that reciprocal zenith angles solve for refraction. Listen, kid, I asked you earlier, are you talking about refraction or vertical datum setups? Because that's you're confusing the two. You are conflating the two. You are using one to protect the other. You can't validate your refraction, and the deflection of the vertical is how much at those given points. You can't give me that data either.
Talking louder doesn't make you right.
You think I'm louder?
Well, we're clarifying here at the moment, and that's his methodology, I'm afraid. So yeah, we're looking horizontally across the Earth surface, and we're hitting matrix with our laser beam. It cannot be that's a refracted hit. Just cannot be. Sorry. Especially, and then you've got the total station, a really nice piece of kit that you have to hit it for it to light up as well. It doesn't make a noise or whatever, and you set it on a pole, set it to the right height. When you get it horizontally, it beeps, beep, 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 beep. You press the button, it holds that position. Boom, done. It's locked in. I don't understand how you don't get it.
The only thing he keeps trying to sell, Jen, is his reciprocal zenith angles don't add up to 180 degrees. If it was a flat Earth, they'd have to add up to 180 degrees. And then he proceeded to tell us how refraction's baked into the calculation.
Yeah. Silly.
You guys reject that, and I'm trying
We reject it because it's all claims that you can't validate. There's data that's missing.
Right.
I linked it. You
This is the thing.
just
Hold on
add
a
home
second,
the guy.
Daddy. Hold on a second, dude. Okay, so do you have any evidence that the refractive index, right, the refraction coefficient was 0.13 on that day to account for standard refraction? Was that just a guess?
This is the one I linked to a couple days ago.
Any test done by anyone throughout all of history. The one that you just spoke about, where you said he just guessed standard refraction.
Yeah, that would be a no.
Well, I can't derive. Like, if you're asking me, can I derive standard refraction? No, I don't know how they derived it. If they averaged it, or if that's just the most common average. I don't know.
Well, this is the thing.
Common claim average. Common claim.
When we go out and do long distance observations over large distances, standard refraction, right? If it's standard, it should be there most of the time, right? But I've never seen a single long distance observation that where standard refraction, perfectly comes into play, and the horizon is where it should be, with standard refraction taken into account and measured. It doesn't exist. It's just the Earth's a bit too flat, so you guys have to try to account for that just by guessing some standard rate that just to try to compensate for the flat Earth a little bit. It doesn't even work though. I mean, look, this is the thing. Reciprocal zenith angle tests don't just completely cancel out refraction. It doesn't magically remove refraction. It can reduce certain symmetrical errors. It doesn't negate the effects of the atmosphere. That's the only people that you're going to hear that from is anti-flat earthers. You're never going to hear that from an actual unbiased surveyor. Ever. It's just anti-flat earthers. If you get your information, your flat earth debunking information, purely from anti-flat earthers, you're getting screwed. That's why most of the globers that come in here get wrecked, because they have either strawman arguments because they watch Professor Dave, okay, or the anti-flat earthers. They go and they watch some other anti-flat earthers. And they're getting their information from people like MC Toon. And you guys are making errors, right? So like when people like Omnivore tell you that reciprocal zenith angle tests, you don't have to account for refraction. That's absolute bullshit. He's screwing you over and setting you up for these types of situations when he says that. Now his tactic, when you try to call that out, is just to talk over people until he gets muted, and then he deafens himself, and that's the process. because he doesn't want to have a good faith conversation. You seem more willing to have a good faith conversation, but these are the types of people that you know, if you're doing your research from anti-flat earthers, you're getting screwed.
Yeah,
you should try to.
No, go ahead.
Well, because you said earlier in text, you said some of my conduct you disapprove of, and I mean, I had taken what you had said to heart actually, and went and researched the last couple of days from it. So I thought we were having a good faith kind of weekly back and forth.
It wasn't with me. I've had good interactions with you, but then I saw the way that the comments you're leaving in QOps server. It's like all of a sudden you're around a bunch of other anti-flat earthers, and then you start acting like a troll. That's what annoyed me. I saw you acting like a troll. In QOps,
I forget what I said.
I remember that.
Oh, it was about, because look, I don't know if they actually eat their own feces or whatever. I actually think they're trolling, but on that I don't take that seriously. So I was like, well, should I?
Yeah, you shouldn't really do that. You shouldn't really do that though, because it puts you in a bad light. You know, if you lie down with dogs with poo on them, you'll probably get poo on yourself. You know what I mean? So you don't want to do that because it doesn't make you look good. Okay, and you can tell that they're trolling, and even the name of the server, anti-truth. You know, I mean, come on, what are you expecting to find there?
So I don't know if it's a troll, if there's a long-standing bit or not, because I'm fresh there. So, but they were saying that they even posted videos of people eating poop, and I was like, yeah, I don't know if you guys are into that.
I mean, why would you go to such a place? Silly, really.
Oh, QOps server? I mean, I was invited by a flat earther.
Yeah, I was invited too. That's how I ended up there. I saw DJ there giving a great account of refraction and everything else, as he usually does. But of course, you know, you get your stupid arsehole trolls, you know, muddying the waters, and then in the end, you just got to leave at the end of the day.
Yeah, but no, on the Glober flat debate, DJ, I'm locked in serious mode on that. I guess like there's like memes that both sides will share, but other than that, like I take it seriously and enjoy convo. So I hope you don't take the one jab I took at the feces eating thing like to heart against me or hold it against me.
Oh, good, bro. All good. All right.
Okay. It is also discord.com, and I don't know. I mean, we can have fun sometimes.
Oh man, Glover's wrong as usual.
But
it's discord.gg/flat earth.
To tie bow on the reciprocal unit thing, because I'll look at it later this week when I have time, but like what I was reading is like to say it cancels out is kind of like inaccurate, but when you add the two angles together and divide by 2, it largely cancels it out of the calculation between the two zeniths.
All right, so I'm just going to read out some basics about it. So the reciprocal zenith angle test does not magically remove refraction. It reduces certain symmetrical errors, but it does not fully negate the effects of the atmosphere. Reciprocal zenith angle idea is observer A measures the zenith angle to point B, observer B measures the zenith angle to point A. You take the average of the two. This cancels out symmetric bending if the atmosphere is perfectly uniform between the 2 points. That's the key limitation. It only cancels refraction that is exactly the same along the line from A to B and B to A.
Right, so if like the first person is seeing too high and is not able to account for it, person B would also if they're like at the same time, they would see the exact same too highness, right? So
this is the problem. There's nothing uniform about the atmosphere. Temperature, pressure, and humidity vary along the path. Even small differences cause asymmetrical bending that is not cancelled by the reciprocal method. Then gradient effects, vertical or horizontal refractive gradients bend light in ways the reciprocal averaging cannot correct. Light does not just go in a straight line and then undo itself on the return measurement. and then distance exaggerates errors. So when you have long tests like the one Jesse did, for example, over 7.2 miles, that's not something that surveyors would ever go out and do, right? They're never going to go out and do a 7-mile reciprocal zenith angle test. And if they did, they would never just do one. Okay, because over miles, even tiny.
If you take the two angles and divide it in half, then you always end up with two equal halves. So you're never doing quote unquote reciprocal zenith angles. Calling it reciprocal zenith angle is a laugh, bro. It's a misnomer.
But the fact that like if you take it up divided by half and then you factor in exactly R, you'll always get 180 degrees. That's crazy though. Like, don't you think that that's too much of a coincidence? Because for me, that is not a coincidence if it's repeatable anywhere on the globe.
Have you noticed how it's only anti-FE that seem to be able to get that to happen? Actual surveyors don't.
Surveyors, that
doesn't happen. See, who's giving you this information? Where are you getting this information from? It's got to be from anti-flat earthers.
Well, are they anti-flat earthers because they have really expensive survey equipment and then they know that it's a globe because of that, or are they anti-flat earth and motivated so they like do bad faith experiments?
We have flat earthers that have even more expensive surveying equipment. Okay, these are anti-flat earthers. Okay, people that make money. Not all of them, right? But much of the time, people that make money, with their content. Now, when you're getting fed information that it always adds up to X amount, right? That's absolute bullshit. The atmosphere is crazy. It varies so much constantly. There's no way that you're going to get the same result every single time. It's impossible.
But, you agree that? So I don't know what your intuition is here, because I'm not going to push you to say prove it. But how much do you think it would help to account for refraction or cancel out? Because even there might still be some error, right? But do you think it's a negligible error amount, or because it seems like the angles still consistently add up to over 180 degrees, which
He's still conflating two separate issues. Please stop doing that. If you want to discuss refraction, discuss refraction. If you want to claim that refraction is the cause of reciprocal zenith angles, then that's a fail.
Wait, DJ area tracking, was I conflating?
They don't do that. They don't consistently add up to over 180 degrees.
Okay, well, I mean, DM me your stuff, and I'll I genuinely will look at it over the next couple of days.
179, 178.
Someone trying.
Because I know there's that one Jesse experiment, and they said it actually added up under it, so they were like, well, maybe it's a concave Earth, but he rejected it not because he was cherry picking, but because he said there was interference in that measurement.
So refraction is not interference then? So let me get this straight. As long as it adds up to 180 degrees or greater, you guys will accept it. But if it doesn't, it must be something wrong. I'm going to say refraction. So now you've got to tell me how it's not refraction.
Well, because the reciprocal approach, I think, is trying to do its best to eliminate or account for refraction.
No, it doesn't. The reciprocal side of it. Listen. The reciprocal side of it is setting up a total station, aiming at something, and comparing the angle from what you've aimed at back at yourself to make sure that you are vertical. Now, the claim is if you are on a ball, the verticals should lean away from each other. If you are on a flat plane, the verticals should be parallel to each other. None of that shit has anything to do with refraction.
I was just bringing up the one example that someone brought up in chat where
they were leaning inward.
He measured a concave Earth, and he was talking about it in the video.
That's right. And that data should have been added to the collective. It shouldn't have been thrown out. This is the problem with the anti-FE guys. They will cherry pick to get the exact thing, whereas we will get all of our data and go, oh, here it all is. Have a nice day.
Well, I mean, I would actually call it cherry picking to focus on that one? Like, if it genuinely isn't valid, you want to rule that out.
No, if it isn't valid, you ask why. Now, the claim was that there was interference. So, is refraction not interference? So, all the other times where you're now claiming refraction affects these tests and that you have to bake refraction in, I'm claiming interference and they should be thrown away. You see both sides of the story now, don't you?
I think it's
take a step back, remove yourself from the equation. Take a step out of the equation. You seem to have some kind of vested interest in it. I don't know why. Remove yourself from it, mate. If they're claiming interference on one side of the needle and the same effect happens on the other side of the needle, is that not just interference?
Well, I wouldn't describe it that way. Like, my understanding is,
what's the difference? Interference is interference. You call it refraction, I call it interference. So let's just work this out. What if it was just refraction on the other side? Because we know the air does all kinds of weird and wonderful things.
It is, though. It is refraction on the other side. Like,
excellent. Both so why the necessity to throw it out? Because they're cherry picking data. They're doing it wrong.
Okay, well, they're both seeing equally two highs, which is like equalizing the refraction. So, like, you can.
The other one didn't. The other one was too low. Because it didn't match up to what they expected. See, this is the problem. They're doing it backwards. They already have an expected result. They should not be doing that. They should be going out there, listen, they should be going out there open-minded with neutral, no bias. They should be going out there doing their measurements directly, getting the result. Not expecting a result and then doing their measurements and data fitting. And that's what they're doing, is they're data matching to an expected result. There was no necessity to throw out that extra data.
It's profound with this question, and I'll answer the question myself. How much refraction is in this observation? The correct answer is exactly the amount necessary to make the Earth still a globe. I rest my case.
Yep, that's what it comes down to. Exactly. So look, until you guys actually go out and measure what's going on between point A and point B with the refractive index, which is going to be a nightmare for you guys, then you don't have anything solid to work with. You can think you do all you like, but if you have no idea what's going on with the refractive index gradient, then you don't have you can't make your hyper-specific claim that you're making. It's as simple as that.
Well, yeah, and do me your like any other stuff I haven't seen yet on, or like pertinent to this as well. I just, because I know your belief on this is that the amount of refraction that you guys have, or that would have to be present, is so profound that you disbelieve it. And like, I know that's kind of where you're coming from with it.
It's not that it's so profound that we would disbelieve it. We don't disbelieve in refraction. The issue is the refraction levels you require. If we were looking across a valley, the mountain tip on the other side would be completely inverted. That's the levels of refraction you guys need to get some of your readings that you claim to have.
Yeah, for example, I'm mopping a floor right now, okay? In a hotel. Well, it's not really a hotel. It used to be one. So it's a long, flat hallway. I'm mopping it. And it has a black trim along the bottom, okay, which is 3.5 inches tall. And I know that no part of the floor is higher than the trim. So I know that the maximum variance of this floor must be less than 3 inches from one end to the other. Now, if somebody came along and used an optical method to tell me that, oh no, the floor is actually 7 inches higher on one side than the other, I wouldn't believe them. Would I?
Nope. Yeah, but I'll just wrap up here. I mean, like, and yeah, send me anything you got. So I was under the understanding that both people on both sides of the zenith angle are seeing the same distortion, so we can tell how much distortion there is, and we can subtract that.
That's incorrect.
Okay,
So how
let's
do
say
you
that's true. Hold on. Let's agree to that premise. Let's agree to that premise. The problem is people have done tests sightlining each other across bodies of water, which debunks the globe geometry by orders of magnitude. So according to you, it should be accepted by you that means that the curvature which is supposed to be there isn't. But we both know, and we all know, that you will not accept that.
The you see too far thing? I mean...
No. Just like you said, two men separated by distance, looking back at each other and sighting each other. So if they can see each other, then you're claiming that mitigates the refraction. So you just have essentially functionally straight lines that you can use and apply to the surface. But when you do that with like lasers shooting back at each other or mirror flashes shooting back at each other across bodies of water, you both can see the thing, and it's actually much greater than the globe geometry would allow by orders of magnitude, nothing that any refraction could subsume. So according to you, that means the Earth is flat. So according to you, the Earth is flat and a globe at the same time. It makes no sense, brother.
Well, yes, again, and I reiterate, please send me that so I can look into that. I think Jesse was saying, though, I don't know this, but he was saying that they were talking about just point it in random directions and raise it until you can actually see it, which, I mean, obviously
that was taken out of context. No, that was taken out of context. Jesse was being a deliberate smartass to screw you over because he's a lion sack of crap.
Yeah, that was not only is that bullshit, right? But that's taking what they did out of context. That's straw manning FE core. That's cherry picking a small section.
Do you think he was lying, or maybe he was like, maybe he just...
Okay, debate daddy. I'll tell you something now.
Just a second. Go. All right. Try to draw this out for me. Okay, Jesse tried. I don't know if you want to have a look at his ridiculous pictures he tried to draw. Okay, so I said, okay, draw a side view of this situation. You have about 400, 500 foot of curvature over this 40 kilometer distance. You have a laser set up at 5 foot height. Okay, you can move the laser around if you want. Okay, in your diagram, draw me a side view of how that light is hitting the target, right? Going directly into the camera lens on the other side. The picture's going to look ridiculous. Look, let me show you the picture that Jesse came up with when we asked him to...
While you're loading that picture, friend, I just want to point this out. When you're using a theodolite during the day, you can see the target and the reticle intersect in the eyepiece. So you don't need anybody to guide you to the target. Now, when you're firing at night at a target, you may need someone to help you sight it. I mean, so basically what we're saying is if you have to change the orientation of your device in order to acquire the target, then your test is irrelevant. That's exactly what you do with a theodolite. You level the thing and then you start moving it around. I mean, good grief, dude. What, did we stop learning how to think or something?
Okay, well, so I understand you're saying, well, that's a necessary part of any process where you're going to level it and then you're going to like actually have to dial it in to look at the person, right? So is that kind of what you're saying? Like that applies to any kind of observation?
Yeah, that applies to any sighting of anything, dude.
Okay. I'm just checking I understood because I just...
you don't just set up your device and it's just magically pointed exactly where you want it to be pointed. Like, how does that happen?
So look at the picture I put in the side chat there, debate. reductio. 27 after the hour. This is the kind of mental gymnastics that you're going to have to come up with to try to make this laser test work.
Gotta love MS Paint.
And this is still my challenge that no one's ever been able to fulfill from the globe side. Okay, now I'm not even saying it never happens, but show me an observation of a long distance laser transit over a body of water where the laser is seen bending downward drastically or at all. I've never seen it. In fact, I've got tons and tons of examples of them bending up, but I've never seen one of them bending down. But you guys think that it not only does it bend down every time we go out and do these tests, but it actually perfectly bends around the curvature of the Earth hundreds of feet to find its way just to the target in all of these different weather conditions in different locations all over the Earth.
Why wouldn't you just want to use a neutrino, though, that won't bend?
Yeah, go. All right, show me. Oh, good Lord.
I was going to say, how many hands have you got, just out of curiosity?
How many hands?
Hands. You know, the things that are attached to the ends of your arms that have fingers on them.
I'm actually very fortunate to have 2.
Just a curiosity thing. Don't panic.
How are you going to go out and validate a neutrino test?
This is something I heard, so it's hearsay, but isn't it the case that neutrinos can pass through matter and they don't bend?
I've not validated that. I don't think you're ever going to be able to validate
validated
that.
it. I have validated that it is a claim. There you go.
Excellent.
Right.
But that would clear it up really quickly, wouldn't it?
Oh, listen, supposedly neutrinos, neutrinos are cosmically saturated. That means they exist in all directions at all times, spontaneously and randomly. So how are you going to tell that your neutrino is the neutrino you're detecting? The answer is you can't. There you go. That's your answer, brother.
Yeah, it's not like they're all time and date stamped. It'd be convenient if they were.
Right. So how they detect a neutrino, my friend, is they use an algorithm that is biased to the results that they want. And then as soon as they get a result on the meter, they say, oh, that must be the neutrino that we sent from over there. Now, this is a crude example, but it fits. If you take a television set, an old one that has, analog receiver, and you just turn it on, the screen is just black and white pixels flickering in random intervals, correct? Which is supposedly cosmic levels of radio waves, right, that are interfering with the receiver. Now, if you draw a circle in the bottom right-hand corner and you wait 3 seconds, there'll be a pattern of black, white, black, white, black, 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 white, 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 black, right? Very fast, very fast, very fast. And you could just say, oh man, if this flashes white, then I detected my neutrino. That's about how stupid it is, brother.
Okay, well, I guess that's all for me now.
So in other words, neutrinos are orders of magnitudes less accurate to the task. If you thought trying to figure out refraction was bad, trying to figure out whose neutrino is whose is even worse.
So just to clarify what you said earlier, Reductio, when it comes to your reciprocal zenith angle test, I'm just saying you guys aren't accounting for the necessary variables to be able to make such a hyperspecific claim. I'm not saying that there aren't some atmospheric conditions that would be possible for the triangle to equal more than 180 degrees. Of course, that could happen. And then when it comes to me saying that it's not possible for refraction to explain certain observations, that's what I'm talking about. For example, Dr. John Dee going to the Rampion windmill farm, okay, and repeating it on multiple different days, different weather conditions, and seeing so clearly, right, so much further than you should be able to see on a globe, to the point where the globe would have to be 25 to 35 times larger in radius for that to work on a globe. And I've never seen any evidence that those types of conditions are possible to exist on a globe with a radius of 3959. I don't think there is any evidence that you can have that type of condition that would allow for that. This super refraction, this divine refraction, this atmospheric ducting of visible light without any destruction. I've never seen any evidence that that's possible to exist. And as far as I know, that there isn't any in existence. So yeah, that's my standpoint. And it's just a huge accumulation of tests where basically I have to max out Walter Bisland's slider just to make it work on a globe, which is basically setting it to the flat setting, right? Sliding it up to a refraction coefficient of 0.99 or more, meaning that there's so much refraction that, oh, okay, we know it's a globe because it looks so flat. And then we're doing it in all of these different weather conditions, and some of the times we know the water temperature, we know the air temperature, and it wouldn't be possible to have this extreme refraction, especially with no destruction, no miraging effects visible or anything like that. So yeah. So my stance on that.
Is it possible that on a globe, perspective ramping would allow us to see the surface way too far like that?
What do you mean? Well, I don't know. You don't have any evidence of the globe in the first place, and I don't think that you have any evidence that perspective ramping. What do you mean perspective ramping would flatten out a globe? Do you think?
Well, everybody knows about perspective ramping. It makes things rise up in your vision.
Well, you said that you denied perspective ramping when I spoke to you about it a few weeks ago.
Well, but I recognize that you understand it and accept it. So maybe.
Do you deny perspective ramping?
Well, if it's what allows us to see too far on a globe, then not at all. It must be definitely a thing, because we know Earth is a globe, and everybody knows that things appear higher and higher in your vision the farther they get, right?
Actually, nobody knows it's a globe because no one's measuring curvature here. I don't know why you keep saying that. Nobody knows it's a globe.
It seems like Jesse's denying that the ground appears to ramp up due to perspective, which it obviously does. Everyone can...
No, he's saying, no. He said, listen, if it saves the globe, then I believe in it.
Well, why couldn't perspective ramping allow us to see farther if it's causing the surface to, in our perspective, to ramp up? We are above the surface, right?
No, but we know that surface isn't ranking up because the builders, let's say you're in a hallway, they built that floor level. So we know that's level. We can throw a spirit level on that thing and know it's level. So come on. What are you doing? Wow.
Dude.
Honestly.
Dude, the perspective ramp, where does it exist?
Well, I measured an upward angle to the ship of water.
I don't care. I don't care about that. I'm saying, where does it exist? Okay, you have reality. You're looking at reality. You see a perspective ramp. Where does this perspective ramp exist?
Jesse?
I don't know. DJ's teaching me about it. It's brand new to me. I'm still trying to learn everything.
Okay, so I tried to give you the hints. There's reality, and then you look at reality and you see a perspective ramp. Where does it exist?
On Earth.
No. Nope.
Oh, me. Oh.
From your perception.
Right. Yeah. But it could exist somewhere else too. So obviously when you're looking at it with your live eyeballs, it's in your mind's eye, right? That's how you're perceiving it. You could also see it on a photograph, right? So now that we know that it only exists in images, doesn't actually exist in physical reality.
Oh, wait a second.
What's the cause of it?
Perspective ramping doesn't exist in physical reality?
No, dude. Let me help you out here. I'm standing on a hallway. It's got a flat floor that extends into the distance. The floor is essentially horizontal. But in my view, it's rising. It's not physically rising. The rise doesn't exist in physical reality. It only exists at my eye or in my mind or on a photograph. Perspective ramping effects occur at the optic. They don't occur out in space. So now that we know where they occur, what causes it?
I'm still learning about it. I don't know. I've been trying to find out what causes it and what the formula for it is, and so far, everyone's like, "Oh, perspective ramping this, perspective ramping that. It must solve this," but so far, no one can, actually.
Well, let's work it out, Jesse. Let's work it out. This hallway is most definitely near perfectly straight. The walls are straight, the ceiling is straight, the floor is straight. It's a giant rectangular prism.
Okay, I got it full screen or big screen on my.
Right, but in my view, I'm now standing. I moved all the way to the end so I can see the entryway into the hallway. It's a big square, and then the other end is a small square. Yet they're the exact same physical dimension. I'm closer to the entry and further away from the far end. Now, the distance is part of the reason why they look different sizes, but the actual reason why they look different sizes is because the angles of propagation from the wall that's close to me are much different angles than the angles of propagation of the wall that's far away from me. And so when they cross my focal plane and they flip before they're cast onto the sensor, they have a different amount of available packet angles that they could use to resolve that portion of my field of view. So in other words, it's casting a smaller angle on the sensor. And the angle that the light arrives at the eye or the optical plane or the lens is what determines the inverse angle, which is what determines the size of the angle on the sensor, which is what determines where it's going to strike and how big it's going to look. It all happens at the optic. Not out there a mile away, not out there 10 miles away. It literally happens at the optic itself.
Okay, so what would the formula be? Let's say my eyes are 5 feet above the floor. The floor is 100 feet long. What would the formula be for me what would the expected angle be from my eyes down to that floor 100 feet away?
Well, look, you have the raw geometry, right? Which you could easily do.
Okay, what would
and then you have the angles based on the optic, which you got the arrangement of the lens and all of that.
So is this something that mankind has conquered and put mathematical handles on it, or is it just kind of an unknown thing?
To some degree, yes.
Okay, what do we know about it? Is there is this part of trigonometry?
Trigonometry is part of the process.
So would it be the arctangent of the rise over the run type of thing, or would it be Pythagorean theorem? No.
You need to
Different
look
altogether.
up how the human eye works. Okay, people don't fully understand the human eye still at this point, but they have a good idea of how our perspective works and how our eye creates that perspective. Now, go and study about that.
Right, and this brings us back to the windmills. If we don't understand how the human eye works, how do we know that perspective ramping isn't what causes it to see out around a curve on a ball?
You can't see around a curve, Jesse. Please throw that in the bin. Sorry, go.
Dude, this is not emission theory, okay? Your eyes don't shoot out rays and then grab and come back to you. You receive light. So you're only working with light you receive, and it has to be at angles you're able to resolve. And the striking angle that it comes in at is going to determine the inverse angle, right? So the top to the bottom, it's going to flip on the optical axis, and then it's going to have so it's a small triangle coming towards you where the acute angle is before your optical axis or whatever they call it, and then it's going to go out on the opposite side, right? It's going to be two triangles. Now that's ideal. That's if light is behaving in ideal rays from the source. So you'd have to assume perfect angular distribution, and you'd have to assume that your optical axis is perfectly, essentially flat, which they aren't. Well, very few devices use flat lenses. They usually have angular lenses because they're trying to get a wider field of view than the size of the lens. Because if you only could take in parallel light, then you could only see the size of your aperture. So if you were a human, right, and you have a 5 millimeter iris or whatever, not iris, pupil, then you'd only be able to see 5 millimeters of the earth at a time. So you couldn't even see an entire wall. You couldn't even read an entire page of a book without moving your head. Which is why everybody who does anything, including eyeballs to cameras, they have a lens that draws in a wider angle than the amount of the size of the aperture. So part of the reason why you have perspective ramping is because you have an angular field of view.
So builders take theodolites to building sites. If I were to take a theodolite to this hallway and I put the theodolite, center height center exactly 5 feet above the floor, and then I put a piece of painter's tape exactly 100 feet away from me, would I be able to measure the angle to that painter's tape and it would match arctangent of rise over run, or is there...
It'd be pretty close at this range.
Is there another thing I would need to take into account, or would it be just as close within the instrument limitations? Was that all that's needed?
I think it would be. I think you'd probably get as close as, below the instrument area.
Okay.
And in this hallway.
Okay, so let's say I set up a super accurate builder's level up on a tripod, but I got it perfectly level. And I'm sighting over the top of this level. How far would this hallway have to extend out before the floor appeared to rise up above the top of the angle projected by this builder's level, according to this?
The builder's level would look straight at center the whole time. Your optic, however, would give you the appearance of perspective.
So
I think it's trying to say I'm looking out at the bottom of the hallway and I have my eyes at a certain level, and there's some boots at the end of the hallway. They're below my eye line. So he's saying, how far would the hallway have to be before the boots are above my eye line?
Correct. Assuming my eye line is level, is my horizontal, like looking through an auto level.
Assuming light as ideal rays, if you mapped it out, they would never be above your eye line.
So, are you saying perspective ramping is not what would cause something to appear above your eye line in the distance that was actually below you?
It shouldn't appear above your eye line. Your eye line is the center point of convergence. Anything below your eye line will converge upwards. Anything above will converge down. From the left will go right, and from the right will go left. They will extend out until the point of you not being able to resolve the boots. So it's an angle of resolution, a coefficient, extinction coefficient. You'll probably find that same number is about 1.22 something, which just so happens to be the same number as the distance to the horizon formula. Very interesting.
Well, the thing is, keep in mind I parsed it out with ideal geometry and light behaving as ideal rays. Right? Right, Jesse?
Yes, so that was my next question. So if I measured, or if I looked over that, that level, and the floor appeared, say 2 arc minutes, actually above my eye line, my horizontal, then that would be indicative of the light having taken a curved path on its way to me?
No.
It could be 2 straight paths. It could be 7 straight paths.
Oh, with bends in them? Straight parallel?
Yeah, the floor could have a reflective surface. And so the image of the boots are striking the surface and going off at a different angle, which hits a different portion of your eye before it's flipped on the optical axis and rendered on the sensor.
So light...
So Jesse, what I'm trying to get at here is that ultimately you're just dealing with the arrival angle of the light at the optic. That's all the optic can do. The optic can't go out into space and grab light and decide where to put it. The light comes to it.
Okay, I understand that. So, but I'm still struggling.
Well, Jesse, I want to help you out because you could believe in emission theory, though, and if you believe in emission theory, then that changes everything.
What is that?
That's where your eyes, or any optic, it would have to actually send something out to sense the world, not just receive light coming to them.
Oh, no, I've not seen evidence to support that.
Well, yeah. And one of the biggest critiques of emission theory, well, if your eyes are sending stuff out to see, then how come you can't see at night? And of course, the answer to that is nocturnal emission theory.
The emitters shut down?
No, dude. That was a high-level joke that flew over your head because you're too innocent.
So I'm still trying to understand how the light from the boots could start out below me, reflect off of something also below me, and then somehow come at me from above me. Does that make sense?
Dude, they're hitting the higher portion of your eye, dude.
Right, but
it doesn't matter. It doesn't matter, dude, because you already believe that light isn't ideal rays. Right? You believe that light takes variable paths to get before it arrives at the optic, correct? The answer is yes, you do.
Right, and I'm trying to find some common ground so that we can kind of have a common understanding of what's causing me to see the water surface above me when I go to the beach on certain days, when I'm actually looking up at the water surface.
You're not, dude.
Well, I mean, if you took there are circumstances where, if you took a long soda straw.
Jesse, if you use common sense and you set your optic up perfectly horizontal. Now think about this. It's perfectly horizontal on a ball earth, on a flat earth. None of them. Assuming there's no atmospheric effects whatsoever, none of them are going to be above your optic, unless your optic is below water level. Does that make sense to you? So number one, if you've got your optic 5 foot high, we're on a flat plane, everything is going to be 5 foot below that, unless there's hills and whatnot in the way. On a Baltard, everything is going to be 5 foot or below and slowly dropping due to the nature of the curve. So when you come at us and say things are above my eye line, we just shake our head.
Hey, listen, you know what could actually do that to you? Is if you actually have a bad sight picture. If you have a bad sight picture, it could look like the horizon is higher above the reticle, even though you've leveled the reticle. So yeah, that's one possibility.
But no, there really are circumstances where when you get down close to the water, and like even if you set up a long soda straw, and looked through it, and put a builder's level on that soda straw and centered that soda straw right to the surface of the water, 7 miles out, you would actually measure a physical upward slope to that soda straw. And I'm trying to understand.
So now imagine an ideal ray passing through the center of the straw. You know, at the center point of the radius of the perimeter of the straw. So in other words, you know, you extend the straw out into space. Is it your belief that that straw will touch the water you're looking at?
You mean if the straw were very, very long?
Yes, you could imagine a long straw, or you could imagine an invisible ideal ray coming out of the straw at the exact same attitude that the straw is oriented. So you're saying your straw is oriented upwards, and so you're going to extend the straw or a ray out of the front of the straw. Is it your belief that that will intersect the water?
Not
so in
a
other
straight
words,
ray.
it'll touch the water.
Not a straight ray or a straight straw. It would have to be curved or bent. It would have to be non-straight, right?
Why?
Because two diverging lines don't intersect in that direction, in the direction they're diverging.
You said you get down at the beach and you look through a straw, and in order to see where the water line stops and the sky begins, so you're assuming that that's the surface of the water, you have to tilt the straw.
No. The scenario. The scenario was the intersection of the side of a ship and the surface of the water at 7 miles distance.
Okay, so at 7 miles out, you think you have to lift the straw at an upwards angle?
Well, on some days, yeah, when it's a hot, calm day and the water's cold, yes.
Okay, so again, the question is, do you believe that the straw would intersect that point in free space? So it would touch the boat at the bottom of its hull that's submerged in the water?
No. It doesn't make sense to me that it would.
Hey, so then why are you saying you're looking up at the boat?
Because
what you really mean to say is I have to look up to receive I have to look up through my straw to receive the light from the boat, basically.
Exactly.
You just agreed that straw wouldn't intersect the boat, which would mean it would be below the straw line, right?
Right. So my question is what is going on here? And this isn't a globe versus flat thing. Looking up to the surface of the water doesn't match flat or globe. So it's not. I'm not presenting it as a debunk. I just am trying to understand what you think is going on that causes that phenomenon.
What do you think it could be, Jesse?
Personally, refraction is my best bet. And also, if you guys don't believe me, ask Rakia. He's a flat earther, and he has an auto level, and he's told us that he has seen this also.
I mean, I've had this same conversation with you 10 times at least already. You already know my stance on it, right?
Well, and I'm not trying to misquote anybody, but as I recall, and correct me if I'm wrong, your answer to the extra 2.5 arc minutes above eye level or above eye line was ramping, perspective ramping. But
no,
now it sounds...
that's completely incorrect. No, I never claimed that.
Oh, wow. Okay, so good. I guess we got
that's
that
completely ridiculous. No, I definitely. In the 10 times we spoke about this, at least you didn't get that. According to the mainstream, right? It's just a bit of looming. If you've got colder water, then you've got warmer air above it. Light's going to deviate towards the more dense portion of the medium, and you're going to get a bit of looming. But it's not as simple as doing some ray tracing, imaginary ray tracing in your head. There could be a whole bunch of crazy shit that's going on between point A and point B, like India was trying to get through to you yesterday. Okay, it's not just some ray tracing software that you could use and model it out, right? There could be all sorts of different paths that the light's taking on its way back to you, which you don't know. You don't know exactly what's going on. And then exactly how that light's hitting the camera. That's all you know, is that you're getting a particular angle measurement from your theodolite. You have no idea what's going on with the light. Theodolites are not refraction measuring calculators or anything like that. Okay, you're just doing an angle. That's all. That's all it is. You didn't account for refraction. Okay, there's no sign of any Earth curvature. There's no sign of a geometric horizon. You have the boat at 7 miles, right? You told me that the theodolite's 4 foot, whatever it is. Doesn't matter if it's 20 foot. It still doesn't really work on a globe, because the horizon should be at about 2 miles away. Okay, it's not there. In fact, we can see land 30 miles away, and we don't see any horizon. 30 kilometers away. We don't see any horizon over any of that distance. So all it is just more confirmation that we don't detect curvature when we go out and do long distance observations. If you're trying to use some kind of refraction mental gymnastics to try to think that maybe somehow, right, it's just uncurving the curved surface that's really there and just making it appear like it's flat, and obviously it looks like it's ramping up, because that's how you see. It's how everyone sees every single time, without fail. The ground appears to ramp up. It's not going to ramp up above your eye height. Okay, that would be a different factor, like refraction, for example. But if you're trying to somehow reverse engineer this into a globe, it's not going to fly.
Well, right now I'm just trying to understand.
You're playing dumb is what you're doing. It's so obvious to me that you're just playing dumb. You're putting on an act. I just don't understand. Can you guys explain it to me? What is the perspective ramping? What's the formula for that? Like, what you're doing is you're trying to say, because it appears too high, therefore the Earth could be a globe. That's what you're trying to get at with this, right?
Well, I mean, understanding physical reality and optics and refraction is definitely part of trying to figure out the figure of the Earth, for sure. But during this discussion, I'm trying to understand exactly what you think the light is doing that gave it that extra 2.5 arc minutes of elevation angle above the eye level.
Yeah, there's probably an infinite amount of scenarios of what that light could have done between point A and point B.
Could I present?
You don't know any of them.
Could I present a quick thought experiment?
Mm-hmm.
Thanks. So let's say I took a bright pen, just a little laser pointer, like safe to look at, put it at that ship at the waterline with a magnet stuck it on the side of the ship, just an inch above the water, pointing at me. And then I had a guy out on a hovercraft, and he had a silver dollar. He could go 10 feet in front of me and hold that silver dollar up in the right place and block my view of that laser, right?
Yeah, probably.
Okay, and I'll have one eye shut for this, so I won't be able to see it with the other eye. So he can then go 20 feet, and let's say he has a very magic marker that writes in the air, and every place that he finds that blocks my view of the laser, he circles a little circle with the magic marker in the air, and it just like stays there like a stationary smoke ring. He could go all the way to the ship every 10 feet with that silver dollar blocking my view of the laser and circling the spot, and this would form a series of points through which that ray of light passed that entered my eye, right?
Yeah, so
assuming ideal conditions.
Yeah, assuming you're trying to assume that the light's just taking some type of perfect arc, but you don't have any evidence to support your claim. It's just a thought experiment. So yeah, let's see if that's actually what happens. I mean, like if you're doing the same thing with a radio signal, and you have a ducting situation, is the same thing going to happen? And then all of a sudden you're going to have this zigzag pattern as it goes up and down through the duct? Like all sorts of different things can happen. Okay, you guys need to claim ducting of optical or visible light for many of these observations to actually work, right? It would have to be ducting conditions. So I don't know, man. It's a great test. It's a cool thought experiment. Give it a try and see what happens. You're gonna need laser. You're gonna need like all these like magical
that you're talking about.
Atmospheric ducting.
Never heard of that. I'm Googling it.
Ducting is a scenario where there's a temperature or a density gradient for whatever reason, and it could be a light or radio waves or anything, or even sound waves. It happens under the water in the ocean too with sonar. If the ray starts getting near the top of a certain region, it gets into a less dense, and it's curved, refracted back down into the main part of the duct. And if it gets to the bottom, something causes it to curve back up and keep it in the duct.
Right, but the only evidence you're going to be able to find of it happening is with radio waves. And if you look up about, like, if you try to validate that it can happen with visible light, you're not going to be able to find any empirical evidence that that's possible. And if you look further into it, you'll find that because of the short wavelengths and the speed that it travels, that kind of thing, it would cause destruction. You're going to get heavy miraging effects and that kind of thing in the distance with visible light.
But I think we...
Go ahead. Well, you're not going to get... Okay, so I've never seen any evidence that you would actually get a nice clear view of what you're looking at in the distance, and it looks just like what you would expect it to look like. You know, no miraging effects, no total internal reflection, no upside down inverted images, nothing floating in the air, just nice regular looking shot as if you just zoomed in on what's actually there. I don't think that there's any evidence that ducting of visible light can cause that scenario, and that's what our observations show. For example, we could see features over a 21-mile distance, and then we can see it during the daytime, looks normal. Do it again at nighttime, looks exactly the same. But the amount of refraction, if the Earth was a globe, that you would need some kind of divine refraction for that to work, and there's no evidence that that's possible that I've ever seen.
You know what? There used to be a theory that light travels in conduits.
The robot and heavy AI.
And
your laser test, Jesse. The only problem you've got with it, once you get to the distance from your laser, that the beam is equal divergence is equal to the size of that coin. Once you get beyond that, you'll see the laser.
Well, but the coin would be larger than my pupil, so it would be
It doesn't matter. The divergence is larger than the coin.
You want to make a bet on this one?
You would get an eclipse effect.
But if the...
No buts, that's what would happen. You're laughing because you know it's true. You're trying to weasel your way around to justify unfalsifiability. That's what you're doing. You're deliberately trying to make things unfalsifiable so you can just, I've still got my globe. You're a globe worshipper. Just say it, bro.
Well, that part's not true. So, DJ, I think maybe we agree, though, that some slight, relatively uniform lifting could take place due to a bottom heavy density gradient, right? With not ducting, but just a little bit of a gradient that caused things to appear lifted up a little bit from where they actually are, right?
Excellent. Let's run with that. So what you're measuring is light being out of position, not the Earth. So you've just thrown away all and any physical measurements that you believe you've done. Congratulations, Jesse. Welcome to Flat Earth.
Oh, thank you kindly, sir.
What the fuck, man? Do you think that the humanity can launch missiles from the USA to Iran or to Russia, and they can't even know what is the how is the shape of the Earth? Are you saying that we invent nuclear weapon?
No, we're not saying that at all. The shape of the Earth has absolutely no relevance to one's ability to launch a rocket.
Wait. Are you now agreeing that saying that the Soviet Union and
I haven't agreed to anything.
That both are lying to us? I mean, they agree with themselves to say
Who
that.
agree?
To us.
Who's they?
I mean, how to say it? I mean, I know my English is not that good, but I'm gonna say it.
That's all
right. You are saying that everyone on this earth, every countries and everyone who is going to say the same thing.
No, I'm not saying anything about other people.
Man, do you say that the Earth is flat or how to say it?
Sphere
like a ball.
or ball? It is measurably flat.
Okay, so because you are saying that, I mean, you say that the government tell us that it's
no, listen. It's measurably flat. Now, what I don't want to hear from you is what I am saying about the government. I never said anything about the government. I've got my own. Listen. You wait. I've never mentioned anything about the government. You need to understand some things. All I said was it is measurably flat. Now, what you take out of that has nothing to do with the government, has nothing to do with school teachers, has nothing to do with your parents.
Man, I didn't throw up any thing at you. I just was asking you, do you think the government lied to us when they tell us it's
I never mentioned the government. If you're imagining that they're telling lies, go and talk to your local government representative and ask them.
Yeah, I think that you are one of the, how to say it, conspiracy guys.
Can I ask you a question, dude?
Go ahead, man.
Yeah, what country are you from?
I'm from Jordan.
Okay, do you trust your government?
Me? Yeah, of course. Why not?
Why would you? What makes you want to trust them?
Okay, man. My government is not the Epstein government. Is not the Prince Will government.
I didn't say that. I said, mate, makes you?
Okay, it's not the Netanyahu government. I mean, my government is a good government.
Hello.
Yeah.
What makes them reliable?
Yeah, because I didn't ever see. I mean, look, man, I live in the Middle East, and all around
I didn't ask you that. I said, what makes them reliable?
What is the meaning of what is it? Reliable. What is the meaning of it?
That you rely on someone. So what makes them reliable? That they are telling the truth.
let me Google it just on Google Translate. Reliable.
Oh my god.
Can you spell it? Can you spell it, man?
REL.
Yeah.
IABLE.
Okay. Bold. Okay, gotcha. Reliable. Okay, like
So
why do you trust them?
Yeah, why do you trust them? Yeah.
Okay, look, man.
What reason have they given you for you to go? Oh, okay. They're trustworthy.
Yeah.
They're always telling the truth.
Okay, can I tell you now?
Yeah, go for it. That's what I've been asking you.
Okay. Look, when it's come to my government, everything and all the things that actually happen.
Okay, what?
Yeah.
What?
Yeah.
Yeah, what? Yeah.
Oh man, how do I explain it to you? I wish you can talk my language.
What have they done?
Okay,
You
look,
say,
man.
I trust everything they do.
Man, okay, just let me Google this word quick.
Oh, don't worry, I give up, man. You guys are fucking idiots.
No, man, I'm not fucking idiot. You are the fucking idiot. Meaning you are from those one that goes like the conspiracy guys. You are the idiot here. I mean, you think
what did I say that was a conspiracy? You said you trust your government.
Man,
I said why?
Can you hear me?
I said why. What gives you the reason to trust?
Fuck up, you such a
Abdullah, listen. Why reason for you trust? He's gone.
Hello, can anyone?
You fucking conspiracy theorist, Timbo. You.
Oh man.
Yeah, we can hear you. We can hear you, dude. Whoever said that.
Okay.
Okay. Oh, okay. We can hear you. Okay.
Please, can I ask you a question?
Yes, you can.
No, there is someone. His voice, like Dagestan guys.
What does that mean?
Are there anyone here from Dagestan?
I doubt it.
What?
I doubt it.
Dagestan.
No one knows where that is, or who that is, or whatever that is. Right?
Let's do it the easy way. No, nobody from there.
Where are you from?
Dagestan.
Somewhere else.
Where are you from?
I'm from Dagestan.
Kangarooistan.
Are you sure? Are you sure you are from Dagestan?
Do you want to ask a question about the topic at hand, or we're just going to keep on talking about Dagestan?
I'm interested about wrestling, so I.
About what?
Wrestling.
Oh, what that is?
Do you know wrestling? Yeah.
Wrestling.
Wrestling, as in WWF.
Ah, wrestling.
No, not like that. Do you know UFC?
That's mixed martial arts. That's not wrestling.
We know what it is.
Okay. There is one of these mixed martial arts. There is jiu-jitsu. There is striking. There is wrestling. Wrestling, one of the main these martial arts. Not WWE and this shit. I mean wrestling, freestyle wrestling.
Yeah, we understand. So how is that proving the shape of the earth?
So Dagestan is the best place for this game.
Okay, so if I go to Dagestan and I do wrestling, therefore the earth is what shape?
Do you know the trend that says send them 2 or 3 years to Dagestan and forget? Do you know Islam Makhashif?
This is an English channel, bro. You're going to have to speak English. Or at least Google it so you can translate.
Okay, I'm speaking English. Do you know Islam Makhashif? He is a fighter in UFC.
Not personally, no.
Yeah.
I've never met him.
What?
What's a unit of power? I have never met your friend.
Are you from England?
No.
But your accent is British. I think that.
No.
I think so.
I was going to say.
Got any globe proof or what?
Yeah, we're going to get that out of him.
Men wrestling.
What?
Okay. At the moment, you want to talk about wrestling. In this channel, we talk about shape of Earth. Some people say Earth is a ball. Some people say Earth is measured flat. What do you say?
I don't understand. Can you explain more deep?
Okay. You do know what a sphere is, what a ball is.
Sphere? I know sphere.
Excellent. What shape is Earth supposed to be? Some people say it's sphere. Some people say it's flat. What do you say?
Say or say?
Say, speak. Some people speak Earth flat. Some people speak Earth ball or Earth sphere. What do you speak?
Speak or speak?
Say, talk. What do you think the Earth is shaped like?
What is this accent? What is say?
Oh my God.
This is going to turn into a fucking comedy show, isn't it?
Say or say?
Okay, when you speak words, that is what you are saying. I am saying to you. Some people say Earth a sphere. Other people say Earth is flat. What do you say?
I'm saying it's sphere.
Excellent. Why do you say sphere?
Because modern science approves that. With
modern science. So which field of science, which field of modern science deals with shapes?
Okay. 1 second, please. ثانية واحدة.
No, I've got plenty of time, bro.
Do you know satellites?
No, they're not modern science. So which field of science? No, satellites are not science. Which field of science deals with shapes? You know, squares, circles, triangles, that kind of thing?
Astronomy science.
No.
طيب. Hello?
Try again. Did he go? What happened? He left.
I think your accent was just too powerful for him.
Yaga having a laugh.
What accent?
That's what what accent?
British accents have that effect on people.
Hey, Bill.
Hey, Jesse. Yeah, that British accent ran him off.
Was that Jesse I just heard speak?
Unfortunately for him.
Hey, so can you address the last comment I put there about the 600-foot high laser claim?
Oh, let's see. My question to you was, how
well, hold on.
high...
I was asking you a question. You can see it in the last message there.
But I asked you, how high do you think it looks?
Yeah, don't sidestep. Just answer the question asked at present.
Sir, you're answering my question with a question. Where are you getting the 600-foot claim from? You specifically said 4607, so I took the screenshot of 4607 and I put it there. Can I get how?
You dropped out a bit there, Travis.
Oh, sorry. Can I get how you got that 600-foot claim from that? From that screenshot at the 4607 mark?
It's posted for your convenience at 17 minutes past the hour, Jesse.
Well, maybe he went to go make a sandwich, I guess.
Hello.
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 How's it going?
For me, fantastic. Saturday morning, relaxing.
Morning. You in Australia?
Yes.
Dagestan.
Cool. What time is it over there?
10:30 precisely.
Wow.
10:33 actually, Matrix.
Well, my computer says 10:30.
Oh, sorry, my car's wrong. My phone says 10:30. Car says 10:33.
So, guys, what do you think of the rocket launch the other day?
What about it?
It's a great comedy show. Next question. Haven't you seen the glitches and stuff?
Did you guys notice anything like
in one of the scenes? Yeah, exactly. In one of the scenes where you see the curvature of the Earth in the top right-hand corner and the side of the rocket along the left-hand side of the image, it pixelates, switches to another view, and then pixelates back. Except the problem is the only bit that pixelated was the Earth itself. The rest of it stayed solid. Isn't that interesting?
Have you got like a clip?
Who posted it earlier? Was it Clipcord that posted it earlier? I can't remember. Someone posted up earlier and I just looked at it and went, that's not going to rub off real well. And it was hours ago too. It was about 2.5, 3 hours ago.
Let me have a look in the chat if I can find it.
That's a lot of scrolling, dude.
Yeah, there's a lot of stuff in here actually. I find it interesting how it was on April Fool's as well.
That's the only thing you found interesting?
Well, I didn't really watch a lot of it. I only watched like the initial takeoff.
Oh, you mean, yeah, we agree that you can have rockets. So can you have rockets on a flat surface?
I guess.
Yeah. So it's not a globe proof, is it? Rockets.
No. No.
What tells you that, like, what about the rocket launch is definitive proof for you that Earth's a globe and they're going to the vacuum of space?
I guess the biggest thing people would argue is that, like, why would they lie kind of thing. That's
Hey, can you hear me?
Yeah, but that's not just hang on a minute. Wait a minute.
It's not proof, obviously, but it's
But whether they are lying, like you got to work out whether they're lying or not, and why. What did you say? Why would they lie? Like that's not important. Are they lying? Right. So why would they lie would be like a question for them to answer. Are we just looking at are they lying? Yeah.
Yeah.
Right. So your biggest proof of globe is why would they lie?
No, it's not my proof. I just said something I can think of would be most people would watch the live stream and.
Yeah, did you watch the live stream?
Yeah, I watched like a minute or two.
Okay, of them launching.
Yeah, so take off.
Have you seen the live stream after that?
No.
Just go and watch it, dude. Most of the time, it's just a blue screen, and then you say, "Why is it a blue screen?" And they say, "Oh, they're trying to save bandwidth for important occasions." And then the other time, they're showing you the back of a rocket. It was weird with this dark ball, which is supposed to be the Earth, and this like crescent moon next to it. Aren't you heading to the moon? What's going on there? But even, any of that doesn't really matter unless they can, So if you go up and you see a ball, right? You go up, they show you a ball. You should be able to measure that on the surface, right? You go, all right, they showed us this ball, supposed to be this big, so that means there's this much drop over distance. So over a certain amount of distance in a linear path, the Earth should drop away from you at 8 inches per mile squared.
Yeah.
Right. So this should be pretty easy to measure, right? Over water, over a lake, still water, Yeah. So you don't need to go to space to work out if the Earth's a ball, because you can't verify what they're showing you. But on Earth, you can verify whether the Earth supposed to it drops away over a distance or not, right?
Yep.
Has anyone ever shown you that Earth's a ball?
With my own eyes, no.
No. Well, has anyone ever presented any proof that Earth's a ball?
There is a video. I'll put it in the chat.
And what was in the video? What's the contents of the video?
They're using lights to kind of measure it.
Lights.
Just watch it. It's in the chat. It's a YouTube video. It's like a minute long.
They used a torch. It's a clip of that Netflix mockumentary.
Hey, quick
they
question.
They didn't use lasers on that one, dude.
Question about that clip. I took a screenshot from that 1 minute video you presented, and it shows that guy to be about 23 feet tall with accurate.
Yeah.
Did you see the screenshot?
Yeah, I can see. Yeah.
Does that look accurate to you?
No.
So hopefully you brought something better than that, though, right? You wouldn't present that and think we'd accept it, did you?
No, I just wanted to hear your thoughts on it, really,
It's pretty silly, 23 feet guy with 6 foot arms. That's what my first thoughts.
But in the video, the light, it's not
The
visible.
light didn't prove flat or globe. It would actually ended up right in the middle, is what actually happened. In the middle of the two different observations. That's what happened.
Can you see a problem with doing it with a torch, though?
I can.
Yes.
Yes. Because the light, curves.
It spreads out. Spreads out and
out,
diffuses, right?
So if you did that with a laser, it would be a different result.
Yeah, it's already been done. Many times. The military do it all the time. But there's a group of engineers that did it as well over some frozen lakes. They did 7 different observations at varying distances. Didn't record any curvature at all. So would you accept that? Because you accepted a video with a torch through some cardboard that you hadn't even looked at properly. But now I'm offering you some laser tests. Would you accept them?
I'd love
the
to
results.
See them,
yeah, but would you accept the results of them?
Yeah.
Yeah. Okay.
Yeah.
Cool.
I'm not biased.
Awesome. When I stop driving, I'll post them for you. Oh, already done. Have you got the PDF that goes with it?
It's posted just before it.
Perfect.
Wow, it's an hour long. Okay.
Yeah, you can't watch something for an hour. You never watched a movie before? They're like an hour and a half to 2 hours.
Of course I have.
Yeah. Or what? Do you complain when your missus says, "Do you want to watch a movie?" Do you say, "Oh my god, that's like an hour and a half, 2 hours"? No, I can't do that.
I haven't got one, unfortunately.
Well, when you do, you have to make these kind of sacrifices to watch these shit movies for 2 hours.
I know, I've been there.
Some fucking rom-com shit. You just smile, sit there, right, and watch it. So if you wanted to discover that the Earth was a sphere or flat, I'm sure you can take an hour out of your time to see what they did in the laser tests. There's a PDF that goes with it as well. So each test is numbered, and then you can go to the page and see what the target height was, what the hidden shot height should be, where the laser should hit, where it actually hits, based on a sphere. Pretty interesting stuff. I wonder if you'll have a double standard for accepting that kind of evidence.
Like I said, I'm not biased.
Good to hear.
Well, welcome to Flat Earth. You're a flat earther.
Not quite yet.
No, yes, you have to be if you're not biased. After you watch it, you're a flat earther. So welcome to Flat Earth.
Thank you.
Like it or not, you're already a flat earther.
Who the fuck is that guy?
Hey, Professor Triangles.
His voice is so deep, what the fuck?
What?
Flat Earth is going to live rent-free in your head for the rest of your life.
Oh, okay. It's a soundboard, isn't
I haven't heard that one before.
Yeah, this is part of the deprogramming sequence. You'll get to hear a lot of this as you get deprogrammed more and more. You'll like it.
So you were actually taught some stuff at school. Fair enough. Is he still there or is he gone?
Me?
I don't even know who I'm talking to. I just hear a voice. Oh, there he is. 011 up top. Nice. You were taught some stuff at school. You weren't given an option whether you could pick or choose. You weren't given any evidence to back it up. It was just a cool story. And then to reinforce it, they make you take a little test. And because you're a good little boy, like all the rest of us, good little boys and girls, we don't want to disappoint our mum and dad or our school teacher, and we definitely don't want to look like a dunce in front of our mates, so we try really hard to absorb the information and regurgitate it on cue, i.e. when you're doing a test. And you did that. You probably did quite well. And all of a sudden, some people one day come along and go, Earth's flat. And you laugh at them. I did. Everyone else probably did. We all had a little chuckle. We all probably said, clowns, how did they come to that conclusion? All we've done is grab the information we were taught at school and we've gone and tested it. That's it. Nothing more, nothing less. Except the issue comes now when you do the test and you find out that the math ain't mathing, what we're taught at school doesn't match up to what we're measuring. That's when you start scratching your head and asking more questions. Those questions I'll leave up to you.
So where does like the rocket go?
Who knows? Do you know?
No.
Do you know the path that it's claimed to have taken?
Yeah, it's like a dick.
Yeah, so it goes supposed to go orbit the Earth twice, right? And then it thrusts, and then it puts these rocket thrusters on. And goes at 25,000 miles per hour in this second orbit, and escapes the Earth's gravitational pull. And then it's all on its own. Then it's got to rely on gravity after that. It goes all the way to the moon, and then whips around the back of the moon due to gravity, and then whips back to Earth. Like have you ever been on the back of a boat on a biscuit? You know those things with the rope?
Yeah.
Yeah, when it flicks you around when the boat turns.
Yeah.
That's what the rocket's supposed to be doing around the back of the Earth and the back of the moon. Not the rocket, the capsule.
So, one thing I didn't
They've
understand
never
is they're
failed.
going all this way, but they're not landing on the moon. Like, you would have thought they'd at least land.
No, they're not going anywhere. Didn't you watch it like 5 minutes after the thing went up in the sky? It turned into an animation, and that's all you get.
Yeah,
You
or
get
a blue screen.
camera following an animation with a globe behind it in the animation, and stars in the animation. Why? How come? Do those stars actually line up? Somebody should check that.
You know what you guys should do?
What?
You should
Check
all
if
like
the
put your
Earth's
money.
curving or not?
No, you should all put your money together. Get a plane. Get a plane and just fly, right?
Why? Why would you do that when you can just
He
go to
wants
the
us.
water?
He wants us all to die because planes can't fly forever by themselves.
Can I ask a good faith question of you?
Probably not. Oh yeah, go ahead. I'm kidding.
Let me try. Well, actually, to our guest here. If you are on a 10-mile wide lake, you and your friend, okay? And your friend goes to the other side of the lake. There should be an amount of curving drop over that 10-mile wide distance. Does that make sense what I'm saying?
Yeah.
How much from past experience, just recalling instances you went to the beach to fish or whatever it is, how much curving drop do you think the globe requires across a 10-mile wide distance?
6 million meters.
Let's be realistic. 6 millimeters, 6 meters, 6,000 meters. I mean, just realistically.
What was the
This isn't a
question?
gotcha.
Sorry? What was the question
This
again?
isn't. 10-mile wide lake. You're on one side. Your friend is on the other side. You have binoculars. You want to look at each other. There should be a curving drop over a 10-mile wide distance. Does that make sense?
I'm going to guess it's going to be 4 inches.
Man, you are very close to what we say, but the globe math requires 66.67 feet of curving drop over that distance, about the height of a 7-story building. It's about the height of a 7-story. That's what the globe requires. You can just ask AI, any of the AIs. You can look up Earth curvature calculators. There's some made by universities. There's several out there. But when you say 4 inches, that's what matches reality. That's why we are flat earthers, because we went to lakes and did our observations across it. And we're like, yeah, there probably is maybe 4 inches of curve across this lake. There's not 66 feet of curve.
But there is a curve.
Well, I've never seen any or measured any.
No, it's not curved. It's flat.
If a 10-mile wide lake had 4 inches of curve across it, I believe that equals out to a globe that's like more than 1 million miles in diameter, which is like 250 times larger than what we've been taught.
But like water always remains level, so there shouldn't be any curve.
Oh, 100%. 100%.
We told you you were a flat earther.
What about little waves and wind? Like when the wind pushes the water, like things like that.
Oh yeah, true. Yeah.
You're going to get some little things, right? Even on a flat surface.
Yeah. True. Yeah.
That curving drop over distance gets exponentially larger as the distance increases. On a 20-mile wide lake, it's about 266 feet of curve, or about a 27-story building. There's a great video of people at the Great Salt Lake in Utah on opposite sides of a lake, and they have lasers about 4 feet above the water's surface, and they're able to see each other on opposite sides of the lake, and there's just not a 27-story building's worth of curve. That hump would hide them from viewing each other. I'll put it in the side chat, and maybe you can check it out later. I'll just tag you in it and watch it when you're on your free time.
Do you guys know what the word NASA means in Hebrew?
Apparently, it's Nashor, and it's apparently. I'm not a Hebrew expert, but that's what we get told.
Yeah, it means to deceive.
It also, in Swahili, it means to trap. And some of these super old languages, it has kind of these negative meanings, but that's interesting, but it doesn't really necessarily prove anything.
I'm just wondering why the company that is now called officially like the CIA is blowing things up into the sky, because they're not a space agency anymore. I asked Alexa, and Alexa said, no, NASA is not a space agency.
Then what is it?
In September, it was reclassified as an intelligence agency, the CIA.
Oh, okay. Wow.
Surveillance and information gathering.
Is it one thing that
they're called astronauts who are in this rocket? Do you think they're getting paid a lot of money to lie?
About 100 grand each.
Not a lot of money. Not if they. What are they going to do about it?
Well, they have to be. They have to be in on it, you know. So, like, surely they must be getting paid a lot of money to like keep it going.
Can anybody remember the name of the TV program about 20 years ago, where a bunch of regular people went to space? Can anybody remember the name of the documentary?
No.
Basically, it was kind of a hoodwink.
When they pretended
Space Cadets.
They were sending them. Oh.
Thank you, Fences. Space Cadets. So back in the early 2000s, the program, I think it was on Channel 4 here in the UK, called Space Cadets. Now, these people, let's say there were 6 of just regular people off of the street, were invited to go to space. And they were in the capsule, and they had cameras, and it was like a documentary, all of these types of things, and they never went anywhere. But they believed that they went to space. It's interesting when you look into it. I'll see if I can find it for you. It's a good documentary / whatever you want to call it. But yeah, thanks for reminding me, Fences. Space Cadets. People will believe if they really believe that they're doing something.
Yo.
I thought he was about to bust into a tune then. Yo, yo. Come on, CTR. You had something to say. Don't be scared. We're not going to bite you. Hard.
Where is the edge?
Okay, that's awesome. Logical, thanks for posting that in the side chat for me. So that's your eyes can boldly going nowhere. It's also one of the other thumbnails I saw. So it's very possible that these people that are in this capsule might actually believe that they're doing something because the outside environment looks like they're doing something. All of the gizmos, the bells and whistles are going off like they've been trained and they expect to be doing something. They might not actually be going anywhere. Might actually still be on the Earth in some hangar. I don't know. But these simulations have already been demonstrated to cause people to believe that what they perceive to be happening, what they believe to be real, they can be tricked into believing it. Check out the video in the side chat. It's awesome.
I'd like to know how they simulated the multiple G's getting pulled while those things are allegedly getting launched.
They told them that's not going to happen. It's a different way of launching. They were launching like an airplane. That's all you would feel. And they were flown somewhere.
Oh, right. I haven't seen it. I don't remember seeing it. Probably have in passing, but I probably pointed and laughed.
It was a new wave of space travel. It launched like an airplane, and they would just feel the same way.
Some airplanes are like roller coasters. They're great fun. Especially when they take off.
Guys, if I'm making my mission to like fly to the end of the Earth, would you guys back me?
I'm all in. Let's go. If you're trying to do what?
I like live stream it. If I live stream it,
how far are you going to get?
Back.
How far are you going to get?
I'll just keep going until the plane runs out of fuel.
Okay, cool.
How are you going to live stream it?
Yes, I'll write your last will and testimony.
I'll just use my mobile data and like stream it on my phone.
How?
Cool.
Okay.
A one-way trip to your death.
I've never seen people streaming from airplanes before. You're the first one.
Pro tip, don't land in the middle of Australia. You won't get reception there to broadcast.
I'll just get a backpack, you know, like the streamer backpacks where they have like...
Yeah, we'll make you some fucking sandwiches as well. You're going to run...
Not really, it'd be like 4 hours before he runs out of fuel, presuming he's in a small plane.
Is the guy whispering in the background?
Wouldn't we like ships would fall into like abyss or something?
So
what not if the water or the environment's contained.
Where would the ships fall to?
Why does the water not fall out of your bathtub?
Because your bathtub is sealed, you know, there's no
Okay,
holes.
I'm trying to get through to the other guy. Appreciate the answer though. Let's see if he's got a different one.
Who? CTO, answer it. Answer his question.
I didn't say anything.
Kayuma.
Yeah.
Why does the water not fall out of your bathtub?
Because it's sealed.
But Earth is not a bathtub.
Okay, but I'm asking you why the water doesn't fall out of it.
No, you should answer my question first.
Okay.
Shouldn't be ships
The water's contained. Because it's contained. Obviously, the water isn't going anywhere because it's not going anywhere. It's still here.
Yeah. Don't go anywhere.
Where's the proof that we are sealed?
In fairness, yeah.
We have water that's not going anywhere.
So you're trying to make an analogy where Earth is like a big container?
I mean,
the gentleman asked quite clearly if the surface of the Earth was flat, why isn't water falling off? I'm just pointing out it's possibly contained, being as the water's still here, measurably flat.
Guys, I respect the argument that the Earth could be flat, but the one thing that like stops me, and I please don't think I'm not trying to like initiate an argument or get on anyone's nerves. I'm just saying,
I'm sorry. I can barely hear what you're saying. Can you turn up the volume?
Or get in the same room with your computer.
Am I that quiet?
You're pretty quiet, bro. I've got you on 200.
Yeah, you're really
you
quiet,
should turn
man.
it up a little bit. Sounds too low.
Yeah, turn it up, bro. It's really quiet, man.
Hello. Can you hear me now? Is it better?
Yeah, it's better.
Better.
Okay, I was using my laptop. Anyway, a lot of the argument for the Earth being flat is that we've been lied to about the Earth being round. But has anyone here actually like?
I've never used that argument in my life, dude. I've never used that argument.
Let him finish.
Just remember, you guys are like, it's like two people out of the whole. You have to admit, a lot of the information on the flat Earth is very skewed, especially since it's turned into a massive meme, and people who do it, like who do believe it, they do get taken the piss out of, which I don't agree with, because I think everyone should be able to.
That's propaganda for you, dude.
But all
that's
I'm
part
saying
of propaganda. Okay, so that's part of the propaganda. Okay, I don't need to be interrupted.
But you interrupted me.
Go on, dude. No, you're fine. Go on, carry on.
Has anyone here actually seen the firmament or the edge of or the ice ring, or has anyone actually done tests?
No, and there's no ice ring. No one's been to the sky to lick it and touch it, and there's no ice ring either. If you're talking about Antarctica,
I'm sorry. What ice ring? What are you talking about?
Well, a lot
none of those things.
I don't know. The old map used to be that there was an ice ring, like
ice ring. Where's the ice ring?
That's just something I saw on the old map of flat Earth. You know.
That's what I'm trying to help you understand. When you say that there's a lot, when you say there's a lot of bad information out there and the piss out of this, no real flat earther of any substance is going to claim that map, which has Antarctica as the circle around the Earth, is the true representation of our claim. No one claims that. Not really.
Okay, Jedi, bro. Remember earlier I brought up that video of the guy shining the torch? Do you remember?
Yeah.
Explain to CTR how that was like a load of bullshit, basically. I feel like
you're talking about the.
Yeah, you know.
Does he know about it?
Tell him what you told me, because
I've seen that video where they're trying to prove the Earth's flat, and then one of them holds up the torch at a certain distance. I've seen it.
Okay, so he used a torch, right? It's not a collimated beam of light like a laser. The original intention was to use the laser test, a collimated direct beam of light targeting over distance. He broke that, a stupid fool. So they ended up using a torch. There's a lot of issues with this. We can talk about specifically the documentary that took place. Right now, we've spoken to Jaron over occasion. He even mentioned this himself on his own YouTube channel. This is a highly doctored video. Not everything that was in the video was the true timeline of events, for example. But if we're to take what's being done here and go out there and try and reproduce with the correct tools and correct environment, then we don't measure the curvature that's supposed to be measured, even though it's not, in the video with the cardboard cutouts with holes in it. So we can go and do this, but we don't get the results that was said to be in this because he's not using a laser, he's using a torch.
So if I use the laser,
why is a torch not as effective as a laser?
Because it's not a collimated beam of light. The divergence of the light from a torch is huge.
Yeah, it's not focused. The laser's not focused. Yeah, that makes sense. But I feel like if I wait, what's the distance? I will actually do this test. What's the distance? Is it 17 meters that he did, or is it?
I think that's the height. I think it's over a few miles.
No, the distance. I don't know, but yeah, I will do that test. I'm actually really intrigued. Again, to be honest, I don't really care what people believe about the Earth because everyone gets to live their own life. But I think it is fascinating though, and I do respect how much time and effort is put into, going against the grain of academics being taught that the Earth is round. But I don't know. I think, in all honesty,
Where
I
do they
don't care.
teach that the Earth is a ball in academics?
Geography, science, you know.
No, they don't.
No, but a lot of it would. I mean, if I ask a geography teacher, in fact, I remember one time in Miss Clark, my old geography teacher, someone asked if the Earth was flat, and she went on this whole spiel about how it's not.
What did she say?
But I don't really remember. It was years ago, but
Okay,
she
no worries, dude.
she just kind of. It was just kind of like the whole gist was just like it's not flat, and then she did show like a bunch of stuff about the geographic formations and tectonic plates and stuff like that. How would you
should
guys
have said, "Oh, plates?
That's a
Plates
good
don't
argument.
exist. Plates can't exist on the surface of a ball." You should have said.
Well, I don't
It's
know.
not a
'cause
ball, it's a sphere.
I was like, I don't know, how old I would have been like 14. And to be honest, geography, I couldn't be arsed. I was sleeping through half it anyway. But that is a good point. Do you guys believe in tectonic plates or no? And how would you explain volcanic activity then, if you don't?
What does that have to do with a
the
ball?
surface of the Earth?
Pardon?
Heat and pressure build up under the surface of the Earth. Volcanoes. Heat and pressure.
Yeah.
Yeah.
So
no
like,
need for a sphere to explain this. It's just heat and pressure on the surface.
How thick?
Now, if you wanted
how
to,
thick would the Earth be if it was flat?
no
Yeah,
idea.
how thick is it?
No idea.
Because otherwise, because a lot of it, the conventional method of explaining.
Tell them, Jedi. Tell them, Jedi. Tell them.
Okay. So we're not saying that the Earth is like a disc, for example, like a penny or a coin that's got thickness to it that you can down and come out the other side. We've got no conceptual idea of this, right? That's the furthest we've dug down to about 7-8 miles, something like that. The Kola Super Deep Borehole in Russia. That's as far as man has gone down. The Arianas Trench, Atlantic Ocean, 12 kilometers. That's the furthest water goes down that we know from the surface of the Earth. How deep the Earth goes, I have no idea, dude. But I wouldn't suggest the Earth is like a disc that you could fall out the other side. Maybe that's where the Australians live. I don't think so. So yeah, it's not that.
Then how is it? Then why is it flat? Then like how what?
Well, how is it
It's
flat?
not a
Because
disc.
water's level on the surface.
Because
Okay. Is it because I said it's
How
not a
does
disc?
ship-
Now you're confused.
Because if ships, ships travel at sea, and if they just go straight on a straight line, they will just go back to the same route.
A straight line.
Yeah, wouldn't that be the case?
I don't
Like,
know.
just
Which
straight,
direction are you going? Which direction are you going?
No, let's say just same direction until you just keep sailing
Same
until. Yeah.
East.
Wouldn't that like you would like go around?
We don't navigate. Yeah, dude, we don't navigate like that. That's why I'm asking you which direction you go in. You're probably going to be going east, west, or something like that, right? East and west are circles, though. If you keep going east, you'll end up where you started because it's a circular path around a pole, isn't it?
Right.
East and west. He said, keep going straight. They're circular paths of direction round a pole. If you stick a pole in the floor and call it north and walk one direction or another direction around it, you can call that direction east or west. You'll end up where you started if you walk around a pole. Right?
If I walk around the pole.
Yeah, well, this is what you're talking. If I go straight,
look in the side chat.
When we navigate across the surface of the Earth, you usually use for directions. We don't go straight when we go east or west. There are circles around a pole. You understand this, right? It's in the side chat.
Then why is it that if you see the Earth, the globe in a map, like the whole world map, and if I navigate to, let's say, on the east side, I will end up going. Let's say I'm in the I navigate from the Philippines and go to using the Pacific Ocean. It's if in the map it looks like the Philippines is on the right side, or if I navigate going to to the east side, I will I will end up going to the US or the Americas.
That's
Wouldn't
a
that mean that
rectangular projection of a map.
what? Right?
When you're talking about going east and west, what do you think that is?
East. Going left and right?
Okay. Is east an absolute direction? Can I go to east and when I get there, this is east? Go no further, I'm at east.
No.
Right.
Okay.
When I get to north, can I go any further or am I at north?
You can always go
No, you
farther.
can't. Yeah, you can't.
But to be at north, sorry, I'm not speaking very well. To be at north, right, it's an absolute point on the earth. East and west, they're not absolute points, they're directions around that absolute point of north. So I'm confused what you're thinking about in your head. It sounds to me, and I might be incorrect, that you've got some kind of rectangular map in your head.
But you see the world map if you search it, right?
Yeah, the world map, yeah, the rectangular projection, Mercator projection map, yeah.
Mercator,
That's a map.
Mercator projection.
Yeah, that's a map.
Right, then how
Okay, let
does
me say it like this. There are thousands of different shapes of map.
Okay, then what is like the real map do flat earthers use?
I don't know. Oh, what do we use? We just use the same as everybody else does. Because it's a map that gets us from point A to point B. That's what they're designed to do in this instance.
Yeah, I like Google Maps myself.
How do you guys? Can I ask a quick? Sorry if you're done. How do you guys explain earthquakes? Is that like pressure?
The Earth's not a ball. That's why they happen, because the Earth's not a ball. They happen because Earth is flat. Isn't that amazing?
What?
Wait, what do you mean?
Well, you got to explain how they work on a ball first.
I'd like to know why the ground shaking now and then is exclusive to a globe.
No, I'm just asking what you guys' take on it is. I'm not saying it's exclusive. I just asking.
Well, my take on earthquakes is the ground shakes.
No, but like, okay, for me, it would be pressure of tectonic plates.
That's the story
plates are
you've been
flat.
told.
Plates aren't bowl shaped.
Okay, but what would you guys' take on earthquakes be?
So why does your story necessitate a ball? So let's apply the same story to a flat surface. Can that still happen?
Sorry, what do you mean?
At the moment, you're telling us.
Yeah. Okay, yeah. But no, I'm just asking, like, because I don't know the record. You guys have looked into this a lot.
You've got a story that you're told is the cause of earthquakes. In that story, what part of it necessitates a sphere?
Well, mainly because in school I was taught about, tectonics and the shifting of the mantle.
Yep, that's the bit I'm getting to. Which part of that necessitates there must be a sphere?
No, but this is all I'm saying is all of that what I've been told in school, which is what I believe, is that's my rationale to it. So all I'm asking.
Excellent. That's what I want. All that stuff you've been taught, grab hold of all that, and now remember that bit of it. Which part of all that stuff you've learned necessitates that there is a sphere?
Well, I guess
you don't understand.
No, but there's more to it than that. But I'm just
there's not more to it. It's pretty straightforward.
In simpler terms. Why?
Who, me?
What? I don't understand what that means. What do you mean by necessitates?
Has to be.
Yes.
So what he's saying is, what part of like an
Yes,
earthquake
I know what
being
you're
a thing
can't
Right, so
be
what's-
applied to it also being flat. I know, but all I'm saying is in school, it's not just taught as, oh, because the Earth, it's taught in sequences. So, like in geography, you'll learn about the mantle, but then in science, you'll also learn about other things which would be correlating to space, the Earth being round, orbits, gravitational pull, things like the tide being affected by the moon, stuff like that. But all I was trying to ask is how would you guys, like, for example, how would that actually, like, do you guys think there
Same
is
way.
tectonic plates on the Earth, on the flat Earth, or no?
Same
That's
way.
what I'm saying.
If we
Yeah,
go with the idea that if we've got the idea that plates are like flowing under and over each other, that's completely fine. You can demonstrate that on flat surfaces. If these plates or whatever they are floating on molten, hotter, more liquid rock, then I guess that's fine. We obviously understand that geology takes place. There's terrible background noise. If you could sort that out, Leon, that'd be great.
Okay, so going back to the rocket launch on April Fool's Day, explain to CTR how that was a load of shit.
Hi, Ma. Mute yourself, please. Thank you.
CTR, did you watch the rocket launch on April Fool's Day?
No.
So, are you aware of what's going on?
No.
So, NASA are currently flying towards the moon for the first time in
Oh
50
yeah,
years.
yeah, and they're trying to make it so they can go back. Yeah, I've seen it. I've seen like snippets of it. They're trying. Yo, Kuma, could you? Okay, thank you. Rubbing his balls up on the mic, bro. What the hell? Yeah, no, yeah, they're trying to make it inhabitable. But I haven't seen like read into the logistics.
No, they're not. They're not landing on the moon. They're just flying past it.
No, but they have. No, yeah, they're flying behind it, and they also want to. They have plans to do. They want to see how if they could set up a base there. That's like one of their objectives.
Yeah,
why did
Jedi.
Why did they wait 70 years?
Pardon?
What?
Why'd they wait 50 years?
Why they wait 50
Good question.
years?
Good question.
Well, because they lied about going the first time.
And
So
they did
they
that
kept
on
it-
April
they-
1st, right? That was done on April 1st, right? And then this one was done on April Fool's Day also. April Fool's, see you guys.
Really?
Ah.
Really? I did not know that. That's insane.
What is the meaning behind April Fools again? It was
Who cares?
No, there was
Well, April Fool's Day. It's about like.
No, but the
Joking.
reason behind it.
Pranking.
There's a reason why. No, but there's a reason why it got called April Fools. It has something to do with the calendars being moved.
I don't know about the reason though. I don't know.
Yeah, it had to do with calendars, seasons.
Yeah, something like that.
Doesn't really make sense that the new year begins right in the middle of winter, does it?
April 1st is actually the new year. And then they shifted the calendar to 12 months, and that screwed it all up.
Yeah, the Georgian calendar, isn't it?
Gregorian.
Same thing.
Okay, yeah. So what? So
George and Gregory are the same people?
Yeah.
Yeah. Okay.
So AOG, what's significant about the launch? I'm confused. I'm a bit lost.
I was just wondering if you've seen any of it.
Yeah.
Well, you haven't
What you
seen
thought?
any of it either. You said you'd only watched a minute of it. So what are your thoughts?
I watched a
Yeah,
couple
no.
minutes of it. Yeah.
Yeah, a
No, he
couple
said
of minutes
he
of
said
it.
1 minute.
I was just trying to see other people's thoughts because I haven't seen a lot of it myself.
So do you believe that they're actually going to the moon?
Yeah, I do.
Mm,
You
I
do?
don't know,
Okay.
mate. I don't
Why
think
do you
so.
believe? We'll talk to the other guy then. So why do you believe? Sorry, I said we're going to talk to the other guy. So why do you believe that they're going to the moon?
Well,
Not you.
probably because. Oh, not me. Okay.
Oh yeah. Oh you. Yes, you.
Me.
Yeah.
Well, I believe that the moon landings were real.
No, the guy with the accent.
That's because
Bro, we all have
humans are-
accents.
Are you guys fucking
CTR.
retarded or what?
CTR
Bro,
or
just use
me?
people's names. Just say the names. It's way easier
Look at
than
my screen. The guy
Yeah,
with the
oh,
accent.
Okay, me.
No, not you. It's not a fucking accent.
Okay, CTR.
No, bro, we have the same
The other
accent.
English idiot.
He's
Leon.
talking to Leon. He's talking to Leon.
Right. Leon spoke and you said no, not you. So.
Oh well, he sounded like you. Leon.
Okay, right.
Why do you believe they're
Yeah.
going to the moon?
Well, I believe that that was the real because of the overwhelming amount of technical, physical, and independent evidence supporting them. I mean,
like
the
what?
mission was tracked.
Hey, did everybody see all those live, or did you guys all see the posted videos on YouTube?
Let Leon speak. Let Leon speak, please.
I will, and I'm going to mute you.
Yeah.
Did everybody see all the handheld cell phone cameras they had from down there that they posted on YouTube yet?
No, haven't seen any of them yet.
I haven't either.
But I saw video of about 1,000 people taking videos of it.
Okay, right. So Leon, you were saying about. I personally believe that we are going to the moon as well.
Okay, we're not asking you that. We're not asking you.
All right, my bad.
Leon, go ahead.
Leon, what was all the evidence that they showed you that was so overwhelming?
You were saying that no one had handled the cell phone or something like this. No one had
I didn't say
thrown it or
anything. You said you believe that they're going to the moon because of all the overwhelming evidence. Now, what's that?
I'm trying to say that let's say independent Apollo signals were tracked beyond NASA.
Hello.
lunar
Did
samples
you understand
handled-
Did you understand my question or not?
Yes.
Yep. So you're going to answer it?
No, I'm just trying to bring the evidence.
Okay, go for it.
I mean, the evidence is straightforward. Independent tracking lunar samples.
Well, show me.
telemetry.
Show me
You
that.
want me to bring the sources?
Yeah. Show me the independent tracking.
All right. You want me to send a link, or I can just say it?
You can post it in the chat if you want. And then after you post it, go through and point out the parts that are overwhelming evidence.
All right.
Evidence.
You got it yet? Not very overwhelming. Underwhelming. It's like he's not going to present anything.
Okay, whilst we're waiting, I'm pretty sure CTR mentioned something earlier. He asked you guys, have you guys done any experiments yourselves
There's no such thing as a flat Earth experiment.
Okay, right.
It's just observations.
From the question.
What I was gonna ask was, have any of you guys done any observations using, for example, lasers or any kind of tool to measure the curvature or the lack of curvature? And if you have,
I use my P9. I use my P900, my Nikon.
What's that?
That's the camera that ruined the globe for everyone. That's the history-breaking camera.
I'd love to hear about it. Can you explain?
That's a
Can you
camera.
talk us through? Yeah, can you talk us through what you did?
Well, you click the little button on the front and it takes photos.
It's a camera that sees really, really far.
I saw farther than 3 miles.
Uh-oh.
Okay, so let's just break it down. Allegedly, we're supposed to be on a ball tard, okay? Now, if this is true, at a given elevation, the horizon should be at a very specific distance. Now, the Globebuster 9000, or P900, whatever you want to call it, happens to be able to zoom further than that so-called given distance. Now, this is not possible because there's supposed to be Earth in the way. Cameras don't see around corners, bro. Except for the P900, P950 and P1000. They all seem to be able to.
Is there any like photos that you've taken with it? That'd be pretty cool.
Jump on the internet, bro. Just type in P1000, P950 or P900 photos and you'll get inundated with the shit.
Did you check out our laser test?
In fact, it was probably the ad for that camera was somebody took a long distance shot and I was like, really, that lens is within my reach of just buying that thing. And I looked, I'm like, holy crap, it's like $1,000. I'm getting one of those. And I bought one.
I still don't understand why ships aren't falling from Earth.
You still don't sound like you don't understand.
All right, I can handle him now. It's time for me to help him. You ready, dude? The spaceship guy, you ready? Spaceship guy. Are you there?
Gotta whisper.
Are you there? The guy who wants to know about ships. Hello? Why would somebody ask a question then not be there?
Wasn't it Kayuma? Was that you?
Oh, what's going on?
The guy that wanted to know about the ships falling off the edge. Was it you, Leon?
That was Leon, yeah.
Oh, Leon wanted to know. Do you still want to know why, Leon?
Well, I didn't ask any of this question.
You didn't want to know why ships don't fall off the Earth?
Well, let's hear it.
Oh, so you want to know? Oh, that's because space is fake, and there's nowhere for ships to fall to. Outer space doesn't exist. I love it.
Then how does the satellites, work?
Don't know he's back.
No, no such thing.
What? How do they get like?
You want to fix it? Can I talk to this guy who said space is fake?
No, there are satellites.
What about? Wait, if space doesn't exist, can you explain GPS timing, orbital mechanics? I don't know, ISS tracking.
How many different things do you want to explain? Pick one only.
Okay, GPS timing. Let's say GPS timing.
GPS, okay, that's an antenna system on the ground. What do you want to know about it?
It's what?
They use antennas on the ground. It's ground positioning system, ground
Wait,
positioning system. It's called ground positioning system.
Wait, if it were ground antennas, GPS would fail over oceans, desert, polar regions.
Oh, they just put the antennas in the ocean. Man, what year are you living in?
The ocean.
Oh, you're
Yeah.
Wait.
How do you think planes follow beacons? They've got
GPS
antennas in the
receivers
ocean.
don't just pick up a generic location signal. They solve timing from multiple.
That's why you got to make sure you're following where they tell you to go, because once you lose their signal, you're flying wherever and crashing. Goodbye, everybody's dying.
Okay, great. Show one verifiable map maintains network or I don't know what for these ocean antennas and explain why every GNSS receiver firmware stack is built.
How many things are you going to ask us? How many things are you going to ask us?
I'm just saying that if it's ground based,
Why don't you show that all those things are only on a ball? So explain why they're all on a ball.
Okay, before I do that, if it's ground based, explain why the system model.
We're still waiting for the previous answer on the other question.
Okay, I will. Okay, but you want me to explain why GPS works on global Earth, right?
No, show it.
Okay, I will show you. Here this is.
Got it yet?
Okay, here's the first link.
Just going to ignore that question too, are you?
Is he done talking about ships falling off of the no space Earth?
Oh, that was the Whisperer. Come on, Leon. I know you can do it.
Yeah,
I see the number guy left. The guy with that had the number for the name, he knows that's what it's all about. He's just preparing ahead of time for just presenting his number to people.
Oh, well, while we're waiting for someone to present information.
You call it a pancake, you call it a coin, a disc as a cartoon, a cheap hollow toy. They grin and they point to the infinite void, saying don't fall off of the edge, little boy. They build up a scarecrow of turtles in space, a cliff at the end of the human race. It's easier to fight a thing they invent than look at the evidence that we present. No way, it's not what we claim. Measured flat, you can call it a plane. Mountains and valleys for you and me, a vast level realm as far as can see. You keep on repeating this silly old lie while observing the same ground, air, and sky. No, it's just land you were shown your hand. You're fighting the claim that was never ours. You talk of your globe, a spinning blue ball with gravity's magic that holds it all. You quote a textbook, a NASA clip, with that overconfident smirk on your lip. You say pizza on elephant seed while ignoring the evidence coming from me. You calculate a curve with a stick and a string, but never question the whole damn thing. No way, it's not what we claim. Measured flat, you can call it a plane. Mountains and valleys for you and me, a vast level realm as far as can see. You keep on repeating that silly old lie while observing the same ground, air, and sky. No, it's just land you were shown your hand. You're fighting a claim that was never ours. Stand. We talk of perspective, of sun's gentle arc, of a local light circling over the dark, shooting lasers across still steady lakes, and the claims that turn out as fakes. You just plug your ears, sing your globe song, the same tired verse that we've heard for so long. You don't debate, you just want a cheap win with a joke about where the elephants have been. Do you finally understand? Mountains and valleys laid out as planned. The sun makes a circuit, the seasons unfold on a majestic fixed stage, ancient and old. Stop repeating that silly, exhausted lie. Look at the world with your own living eye. No, it's just land. Your logic is sand. You're fighting the claim that was never our stand. Never our stand. Just listen for once. Just listen, it's all right here. Just look. If your theory is found to be against the second law of thermodynamics, I give you no hope. There is nothing for it but to collapse in deepest humiliation.
Almost want to grab a cognac, a big fat cigar, sit back and put my feet up.
I like the idea of making these little bumper quotes. They're fun. Yeah, I decided to go for kind of a lounge feel with that one. Usually I try and match the timeline of the person who said it.
I like the other one that I did, where it's got that sort of eerie background. It gives me the heebie-jeebies. That's why I like it.
I know what you mean. There's a lot of them that end up weird like that. It's okay when it's a little eerie, but when it gets to the point where it's annoying, I can't play those. And I've got some stuff that's so eerie it's annoying. But some of it's just outright AI glitches. We should make more of these.
It is inconceivable that inanimate brute matter should, without the mediation of something else, which is not material, operate upon and affect other matter without mutual contact. That gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum, without the mediation of anything else, by and through which their action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. Gravity must be caused by an agent, acting constantly according to certain laws. But whether this agent be material or immaterial, I have left to the consideration of my readers.
Welcome to 24/7 Flat Earth Discord. please try to remain civilized and cordial. If you have any questions, feel free to ask.
Oh, 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 yeah. Oh, oh, oh. They say the light just stops to think when it hits a new address. That a pencil in a glass of water breaks from all the stress. And a fish you're trying to catch is right below the spot you see. Well, sit right down and let me set your inner physicist free.
Oh, it's just a bend, it's not a break. A simple change of pace, for goodness sake. The slows and takes a turn. A fundamental law to learn.
So many stories get it wrong in every textbook, poem, song. Let me shine a light on what is true. Refraction's not the trick.
The trick's on you.
They whisper that a prism paints the colors found inside. That white light's just itself until by magic it's denied. But Roy G. Biv was always there, just riding side by side. It's just the speeds are different, so they all fan out wide. And a mirage on the highway, a pool of water in the heat. Isn't the sky falling down? Oh, it's the sky meeting the street. A bent and lifted image from the layers of high air. A thirsty illusion, but the science, it is there. Oh, it's just a bend,
it's not a break. A simple change of pace, for goodness sake. The light just slows and takes a turn. A fundamental law to learn.
So many stories get it wrong in every textbook, poem, song. Let me shine a light on what's not the trick.
The trick's on you.
We want the world to be as it appears, to trust our eyes and fight our doubts and fears. But light is just a messenger, a runner on the ground. And when the terrain changes, well, his path gets bent around. So blame the medium, the density, the index, and the speed. Not some rebellious photon with the mischievous little need. Oh, so when you see that spirit sheen diagram in class, aim low for the fish, don't let that old myth pass. The diver sees you high above, not where you really stand. It's geometry of bending, not a sleight of hand. And rainbows aren't a place, you can't go chase their end. Their personal performance on the droplets light depends. Your rainbow's yours alone, a vision sweet and slightly shifted by a million tiny prisms in the aftermath ring gifted.
Yeah. And it was never a break.
Yeah, a beautiful correction that the universe will make. The light just
slows and takes a turn.
A lesson we must learn. So close your misconceptions. Let the proper knowledge burn. Let me shine a light on what is true. Refraction's not the trick. The old tale's just a flick. The trick was on you. Yeah. It was always just a
thought increases, fortunes over time, and ed towards a wealthy ward, weird warden of your mind. Homogeneous, universe, a constant mass, an increase in radios, accounting for the radio velocity of extragalactic.
What was that, man?
How's everybody doing tonight?
How's it going, man? Just hanging out.
Are there any Globers in here right now?
Perhaps.
We think they're hiding.
Hello, Matrix.
How's it going, man?
Good, how are you?
Oh, I can't complain. Beautiful Saturday. Extremely warm outside.
I'm in Toronto. It's just starting to get warm here.
Yeah, the last, what have we had, 3 days in a row where it's been over 30 Celsius.
Oh, it's hot.
I hate when it does that.
Someone must have dropped in. Oh, welcome to whoever dropped in.
Let the server meet the damn bot, too.
Does this bot automatically mute itself when people come and talk?
No.
No. I stopped it. We're just quick on the draw and muting it so that we can get back to having a conversation.
Is there any Glober who wants to have a conversation about the Earth?
Don't be shy. Nobody's going to bite your head off or anything.
That's why they keep me behind a microphone, so you're all safe. No takers. Fair dinkum. Oh, the music wins. Now, Travis asked for, what was it? Divine refraction. All right. Let's see if it works.
I see the tower standing tall across the sea. They say, bro, it's hiding geometry. Then they panic, twist in reaction, and whisper softly, divine refraction. Camera zoomed in, still clear view. They close their eyes, optics, dude. No math, no measure, surf assumption, globe theory, Kanu function, refraction junction, divine refraction, science fiction attraction. Oh yeah. When logic fails, they change the section and chant the mantra, divine refraction. Where's the curve, my friend? He says light bends, depends on the trend. Kitna bend karega yaar 90 degrees. He smiles, hard possible, please. No shimmer, no haze, and no distortion seen. Yet they claim a bending beam. I say measure it, they say trust the nation and summon once more. divine refraction. But when the photo's clean, when the line is flat, they shout refraction. Imagine that. मैं बोला थोड़ा logical, वो बोला अरे यार नैसा बात